In the previous course section, we added navigation. And since we added navigation, we have an application that spans multiple screens. Now we also added this favorites screen, and we do have this favorites icon on the meal detail screen, but at the moment this icon doesn't do anything, this button doesn't do anything. And it would make sense that when we tap this button, we could mark a meal as a favorite and then see it on this favorites screen. And in general, in more complex apps, it would be pretty normal that you have some state, some data that should be managed across multiple screens. Like here, when we add this favorites feature, where we toggle between the favorite, not favorite status on the meal detail page with help of this button, and we then need the information whether a meal is a favorite or not also on a totally different screen, this favorites screen. It would be totally normal in more complex apps that you have some data, some state that should be managed app-wide because it's needed in different parts of the app. That's the case for regular React apps. So with that, I mean React apps for the browser. And that's also the case for React Native apps, as you see at this example. And that's why in this course section, we will dive into managing app-wide state. And we will learn how we can manage app-wide state with either the React Context API or Redux. And we will see examples for both approaches combined with React Native. Now here's one important note though. If you don't know what React Context is or what Redux is, why you would use it or how you should use it, then I have to tell you that this is not the focus of this course. I do expect these React fundamentals, they are a course prerequisite, and you should therefore dive into dedicated courses or tutorials, resources to pick up those basics. Attached to this lecture, you also find a link where I compare Redux to Context and share some thoughts on what the differences are and which one you might want to pick. But if you don't know how to use React Context or Redux, definitely check out the official docs or take dedicated resources like my React the Complete Guide course, where I teach both concepts in depth. In this course, we will just learn how to use them in a React Native app, and we will learn that at a concrete example, this Meals app here. So let's add Context and Redux, and of course, we only need one of the two for managing app-wide state typically, and therefore I will show both approaches after each other, and I will start with the Context API. For this, in this project folder with that Meals app, and by the way, you find the latest snapshot attached so that we can start from the same starting point. But in this Meal app, in this project folder, I will start by adding a store folder. It doesn't have to be named store, but it's a common convention to choose store as the name for the folder that holds the app-wide state-related logic. Now in this store folder, I will add a context subfolder, and I will add a Redux subfolder, which we need later. We will start in the context subfolder, and in there I'll add a favorites-context.js file. In that file, I want to manage my favorites context. Now, for this, we now first of all need to create a context. And this is done with help of the create context function that is exposed by React. We can call this function to create a context object, and here I then create the favorites context. And I name it favorites context with an uppercase character because we will use this or a property of that object, as it turns out, as a component later on. So in JSX code, and therefore we should start with an uppercase character here. Now to create context, we can pass an initial context value, and even though we don't really need the value here, I will add it because that will help us with auto completion in other parts of the app here in the IDE. And then here in this context, I want to manage the IDs of my favorite meals, and that should be an array. And I then want to have a function add favorite that allows us to add a new ID. Now here I will just create the dummy definition of this function, not the actual function, and therefore I'll just add an arrow function where I get an ID and have an empty body because I'm just adding this for better autocompletion. We will add the actual implementation of this function a little bit later. Now our context also should have a remove favorite function, which also takes an ID and then will do something later. That's the context object, and that should actually be exported so that we can use it in other files later, because we will need it in other files to tap into this context and use it. Now with that, we also want to create a functional component in this context file. At least that is how I typically manage context. I will name it favorites context provider. The name is up to you though. And I will export this as a default here. Now in there, I will receive props and I will pull out the children prop with object destructuring. And then in there, we want to return our favorites context, so this object here, dot provider. And between the opening and closing tags, we have our children. So that this component, this overall favorites context provider component, can later be wrapped around our app, around other components that should be able to interact with this context. That's why I choose this approach. Now in this favorites context provider component, I then also want to add all the logic that we need to manage this context. So the actual implementations of these methods and the logic we need for managing an array of IDs. We'll do this in the next lecture. Before we go there though, we will use this favorites context provider component in app.js, and we should wrap all the components that need to work with context. Now, since we're managing some app-wide state, many components or very different components in very different places of the app need access to this context. For example, we will need access in the meal detail screen, but also in this favorites screen, which is managed with the drawer navigator. To expose our context to both, I will simply go here and wrap my entire navigation container with all the navigators and screens inside of it with my favorites context provider component. So we have the opening tag here and the closing tag after the closing navigation container tag. And this favorites context provider component must be imported from our store folder, and there the context folder, and there the favorites context file. We must import it into app.js to have that component available there. And with that, we set up our context shell, but right now it won't work, and it actually even gives us an error. And we will take care about that and about the actual logic that should go into that context in the next lecture. So let's now fill this context function here with live. And this function should contain all the logic that we need for managing our favorite meal IDs. For this, I will use state. So this use state hook from React, because we are in a functional component here. And that will be my array of IDs, which I want to manage here. So my array of meal IDs of the favorite meals. Initially, it's an empty array. And I will then name my state variable favorite meal IDs, and the state updating function could be named set favorite meal IDs, like this. Now we need two functions in here, the add favorite function and the remove favorite function. Now in the add favorite function, I expect to get an ID as a parameter. We need to make sure that that will be the case later. And then here, I will set my favorite meal IDs, so I will update my state. And I want to update it based on the previous state because I want to add a new ID to the existing array of IDs. Now in React, when updating state based on the previous state snapshot, you should pass a function to your state updating function, and that function will receive the previous state snapshot, so the current fav IDs, for example, and should then return the new state snapshot. So in this case, I want to return a new array where I spread all my current fab IDs into, and then add this newly received ID as a last item. So I'm creating a new array, which then is returned as a new state snapshot. In remove favorite, I also expect to receive an ID of the favorite that should be removed. And I will also call set favorite meal IDs. And we will also update this state based on the previous state snapshot. So we also get our current fab IDs there. But then I want to return a filtered version of that array because I want to filter out the ID that we received as a parameter here. So therefore my new state is my old state filtered. And I go through all my meal IDs that are stored in this favorite meal IDs array. And if meal ID is not equal to ID, I want to keep it. But if it would be equal, this would return false, and therefore the item would be filtered out. So this line of code will filter out the meal ID that we got here as a parameter. Now you will have different ways of writing this code, but this code should achieve the desired goal. Now we need to pass our managed array of meal IDs and these functions into our context provider. For this, we can construct a value object. And on that object, I will add an IDs property because that is the name I chose in my default context object here. So I will choose IDs here as well. And then point at my favorite meal IDs. So at this state here. And we will also add an add favorite property to this object and point at this add favorite function here. So here, this add favorite name here refers to this add favorite function. And this add favorite identifier here in front of the colon simply is the name by which we will be able to execute this function from inside our components. And we will do the same thing for remove favorite. Add a key named remove favorite and then point at this remove favorite function here. That is what we're doing here with this setup. So now with that, we got this value, and now we can pass this to our context provider by setting the value prop, which is expected by that provider, equal to our value constant. So now this value here simply refers to this value constant here, so to this object. And we're passing this object as a value into our context provider. And that means that now all the components that are wrapped by this context provider, so in our case, since we're wrapping everything, all components, will be able to tap into this context and either call these functions or read our IDs. So that's therefore the next step. Now we can use context in these other components. So let's now use the context, and let's start in the meal detail screen. That is the screen where we have this icon button which we can tap. And now I want to make sure that when we tap this button, instead of just logging something to the console, we actually change the favorite status of that meal. For this, we need two things. We need access to the methods defined in our context, and we need access to the IDs to find out if the ID that we got here for this meal for which this screen was loaded is part of our favorite meal IDs. So if this meal for which this screen was loaded is a favorite. We can get both things by using another hook that's built into React, and that's the use context hook. And these context features which we are using, defining context, using context, that has nothing to do with React Native. These are all standard React features, and they work as they do in any React app. Now, use context will give us a context, in this case the favorite meal context, or favorite meals context. And we get this context by passing our context object into the use context hook. And with that, I'm talking about this object that we defined in the favorites context file initially, this favorites context. So in meal detail screen, we can pass favorites context into use context. And for this, of course, you need to make sure that you import favorites context. Now with that imported, we got hold of our favorites meal context. And with that, we now can do a couple of things. For example, we can find out whether that meal currently is our favorite or not, or one of our favorites. And I even want to change the icon that we show here on the detail screen based on that information. If this meal is one of our favorites, we should have this filled star icon, but if it's not a favorite yet, I want to have an empty star. Now that we got hold of the favorite meals context, that is fairly easy to find out. We can add a new constant, meal is favorite, which should be a boolean. And to find out whether this meal for which this screen was loaded now is a favorite, we can use our favorite meals context, so this constant here, and access the IDs there, and find out if in this IDs array we have this meal ID. And we can easily find out whether that's the case by using the includes method, which is a standard JavaScript method, and we pass meal ID to it. Includes works great on primitive values, and it will return true if this meal ID is part of this IDs array, and false otherwise. So now we can find out whether this meal is a favorite or not. We can then use this on this button here to set our icon conditionally, instead of always setting it to the star icon. We can use meal is favorite, and then use the star icon if it is, so that's this filled star, but use star outline if it's not, and that will be an empty star. Now to actually change the favorite status, we have to work on this function. First of all, I will rename this function to change favorite status handler because that sounds more appropriate. And I will update it here on the onPress prop and here in the dependencies array of use layout effect. And inside of this function, we now can add a if check and check if meal is favorite. So if the meal is a favorite, in which case we want to unfavorite it. And we do unfavorite it by using our favorite meals context. So again, this context object, and calling the remove favorite method on it, passing the meal ID to that method. This would then switch this meal from favorite to non-favorite. Else, if the meal isn't our favorite at the moment, but we clicked this button, indicating that we want to turn it into a favorite, we would execute favorite meals context add favorite and pass our meal ID into this method. So that is how we can toggle the favorite status, and this should already work, and this should be all we need. If we save this and we force a reload of our app, if I go there, you see I can toggle between these two star states because indeed behind the scenes this favorite status of this meal is being changed. Of course, we don't just need that status on this screen though, we also want it on the favorite screen, and there at the moment we're not displaying any favorite meals. Time to change this. On this favorites screen, I'm only outputting this dummy text at the moment, and that's not the goal. Instead, what I want to output is a list of favorited meals. And if we think about it, we already have a list of meals that we output. On the meals overview screen, so when we select a category on this screen here, we are already outputting a list of meals. So it would be great if the logic for outputting this list of meals would not be tied to this specific screen component, but could be used in other components as well. And it turns out that we can easily achieve this by taking the relevant code and putting it into a separate component. So for this in the components folder, I will add a new folder, meals list, sounds like a fitting name. And I will move the meal item into this folder because we only use that meal item in a list. And I will add a new file in there as well, which is the meals list.js file. And in that file, I will add a new functional component, the meals list component, like this, which also, of course, is exported like that. And now the goal of this component is to render a list of meals. For this, we can grab all the logic we already wrote in the meals overview screen component. Starting here with the return statement, where we return a view with a flat list, and then including this render meal item function, which is used by flat list, we cut all of that from the meals overview screen component, and instead add this here in this newly added meals list component. We also need to bring over the styles, and therefore I will also cut my styles object here from meals overview screen and bring that into meals list. Like this. Now we need to add a bunch of imports, and we need to import view and flat list and also style sheet from React Native, since we're using these objects and components in this newly added component. In addition, we must make sure that we get the data that we use here in the flat list. So for that, we should expect some props, and I'm using object destructuring here to pull out a prop named items. The name is up to you because it's your component. But now we can use this items prop here as data. So instead of displayed meals, I will use items. We could have also stuck to that name displayed meals and named the prop displayed meals. Here I just went with items. And that should already be all we need to do here. We then output this meal item. So actually there's one more thing. We also need to import meal item from the meal item file, which is in the same folder now. And with that, we can go back to the meals overview screen. And there, instead of rendering the flat list and so on, we now render the meals list component, which we just added. And for this, we have to import it from the components meal list folder and then the meals list file. And we can get rid of these unused imports here, which we don't need anymore. And now we pass these displayed meals here to meals list by using this items prop, which we added there, like this. And with that, if we reload everything, we should still be able to get our list of meals here once we choose a category as before. This all works, and we can still visit the detail screen. So that's great. This all works as expected. But now with that newly added component, we can go to the favorites screen and use that component there as well. Here we can now actually output our meals list like this. And we don't need to import the text anymore, therefore. And we set this items prop to our favorited meals. And to get our favorited meals, we again can use the use context hook, which is imported from React, to tap into our favorites context where we manage these meal IDs. So now we can again use our favorites context to get our favorite meals context here. And then we get our actual favorite meals, which we need, by using our meals raw data, imported from that dummy data file in the data folder. And here we now need to select all the meals that are part of our favorites meal context, or to be precise, of the IDs array that we manage in that context. So we need to get all the meals in the raw data that have an ID that's part of this IDs array that we manage in our context. This is fairly easy to do. We can use the filter method again to filter out all the meals from the raw data that have a fitting ID. So we look at all the IDs of all the meals, and if an ID is equal to an ID that's part of our favorite meals IDs, we want to keep it. So therefore, the actual logic here should be that we use our favorite meals context IDs, so this array of IDs, and we use the includes method there to see whether a given meal ID is included. So we take a look at all the meals in the raw data, and if the ID of a meal is included in our favorited meals IDs, we return true, and therefore the item will be kept in the newly created array that is returned by filter. So filter will return an array with all the meals that have an entry in our IDs array in our context. And therefore then we can pass our favorite meals to items, like this. And with that done, if we now go to another meal and favorite this meal and favorite this meal, let's say, and we then go to the favorite screen, we see these two meals there. And we can't go to the detail screen without issues because we're still in our overall Stack Navigator setup, and the logic for navigating to the detail screen is baked into our meal item. I have my navigate method there. And to this component and to React navigation, it does not matter if we are in our main stack of screens or if we are on another screen that was loaded through the drawer, as long as we're still in the same navigation setup. We still have access to all the stack screens the way we configured our navigator, and therefore we can access these screens. And therefore navigating to the meal details from inside our favorite screen works without issues. And if we unfavorite an item here and we go back, this item is now missing on the favorites screen, as it should. Of course, it's still part of the other screens though. So that's working. And as a last step, I now just want to make sure that we also show some message if we have no favorites at the moment. And for this back in the favorites screen, I actually will add some styling here with the style sheet, of course, which therefore should be imported from React Native. So I'll import style sheet from React Native like this. And I will also import view and text because I want to output a centered text where I tell the user that there are no favorites yet. So here we have the style sheet which we create, and we'll add the styles in a second. But for the moment here, I want to check if my favorite meals do have a length of 0, which means we have no favorite meals, in which case I will not return my empty list, but a view with a text inside of it where I say you have no favorite meals yet. And now we can add some styling and, for example, add a root container style here, which we will add to the view, where we set flex 1 to take all the space we can get, justify content to center the content vertically, align items to then also center it horizontally, and I will add a little text style object here to style the text in the view, where I want to set a font size of 18 and a font weight of bold, and then also a text color of white. So these are my styles, and now we can add these styles here, and on the view we add this root container style, and on the text we add this text style here. And with that, we now also got a nice message if we have no favorite meals yet. You could show more text, you could add an image, you can do whatever you want, but this is how we can use the context API in a React Native app. And as you can see, you use it in exactly the same way as you would use it in any React app, because this is just a regular React app, just targeting a different platform. So that was how we can manage app-wide state with context. And if that's all you're interested in, you can stop here. You don't need to use or dive into Redux, you can totally ignore it. But if you are using Redux, the rest of this section is for you, because we will be using Redux to achieve exactly the same result now. Now, one quick note, for this course, I will use Redux Toolkit, which is the officially recommended way of using Redux. I do teach this toolkit, as well as Redux in general, in depth in my React Complete Guide course. So, besides the official docs, which are also great, and of course free to use, you can also use my Complete Guide course to learn more about that. But again, you can also use the official docs here to learn how Redux and Redux Toolkit works. That is absolutely fine as well. Now, we will be using this package in this section here, and therefore the first thing which we have to do, which is of course also mentioned in the docs here, if you dive into the Quick Start tutorial, is to install Redux Toolkit and React Redux. So we copy that and install this with npm install @redux.js/toolkit and React Redux. With that installed, we can use it. And now to use Redux here, I will go into this Redux folder in the store folder. We could delete the context folder because we're not using context now, but I will keep it here so that we see both. And in that Redux folder, in the store folder, I will add a store.js file. Now in this store.js file, we will create a so-called Redux store, which is kind of comparable to this context object we created before. For this, we import something from @redux.js toolkit, and that something is a configure store function. We can then create a store by calling configure store like this. And to configure store, we pass an object where we add a reducer key, which holds an empty object as a value for the moment. Reducers are the different slices of state, so of data, and actions that can change that data that are used by Redux to then construct an overall store of data and actions. But again, if you want to learn all about Redux, definitely take a look at the official docs. Then we export this store here, and now as a next step, just as with the context, we have to provide it to this app. So just as with context, we should wrap our Redux provider and our store around all the components that need to interact with the Redux store. And therefore here, since I have totally different components in different parts of the app, I will wrap Redux around my component tree here in the same place as I wrap my context provider. I will just comment out the context provider now, and instead use just provider opening, and then after the navigation container, closing tags. Now provider, this component we're using here, is a component provided by React Redux. Therefore, you should import provider from React Redux. So not from Redux Toolkit, but from React Redux. Now to this provider, you need to pass your store. So I will get rid of my context provider import, or comment it out because we don't need it anymore, and instead import store from /store redux, so /store/redux/store. This store which we just created and exported. I'm importing this here, and then to this provider, we pass it by setting the store prop to this store we just imported. And that's all we have to do here in app.js. With that, we're providing this store to our app. And now the different parts of the app will be able to use it. That's how we get started with Redux. Now, just as before with context, we're now providing it, but we got no logic. So therefore, as a next step, we're going to add the logic before we then learn how we can use Redux and tap into this Redux store from inside the different parts of our app. So let's now add the actual logic. We could do this in this same store file. The convention kind of is to use separate files for the different features your app might have. And therefore here, still in the store Redux folder, I will add a favorites.js file, but you don't have to create it. You could manage all the logic in one and the same file. Still here, I have a separate file, and in there we create a so-called slice. That's a Redux toolkit feature for defining some state, some data, and some actions that should be able to change that data. We create such a slice by importing a function from @redux.js toolkit, and that function is called createSlice. We can then call this createSlice function here in this favorites.js file in the Redux folder, and we pass an object to it. This function will then return an object which I'll name favorites_slice. Now in this slice, we then have to set a name. Favorites could be the name. This is up to you. It's an identifier you can use. And then an initial state. And for this, I'll set an initial state, which is an object where I have some IDs, and my IDs here should be an empty array. So that's my initial state. I have IDs with an empty array. Now these functions which we need to change that state are now not added to the initial state, as we did it with context, where we had one context object that had both the data and also the functions to change the data. Instead, with Redux, we have a separation, and we now simply have a reducers key here in our slice object. And reducers are functions that are used to change our state. Therefore, we can add functions here in this object, methods. And I'll name my first method addFavorite and use this arrow function syntax here to define it. And every method that you define as a reducer will automatically get the latest state as an input. Redux will be calling this method for you and will give you the latest state snapshot. Therefore, we should accept it as a parameter. So that's function number one. The second function which I want to add is the removeFavorite function, which also is an arrow function here for me and gets this latest state snapshot. In these functions, we can then change the state. And with just Redux, without Redux Toolkit, you should do this in an immutable way. When using Redux Toolkit, you can mutate your state in a mutable way because Redux Toolkit will take care about that under the hood. That's just a side note in case you have worked with just Redux in the past. With Redux Toolkit, mutating state is okay. If this doesn't tell you anything, you might want to dive into the official Redux docs first. So now with that here, we got our addFavorite method. And now here, we want to update our state IDs array. And in this case, if we add a favorite, push a new ID onto this array. Now it would be nice if we would get this ID as part of this method, and indeed we can accept a second parameter here, an action parameter, which can hold an extra payload which we can pass along when invoking this method later. We can get access to this payload by using action payload. We use this key because action is an object created and provided by Redux, and it uses a payload property to transport any extra data we might attach to this function in the future. That's why we have to access action payload here. And then we could expect that in the future, when we invoke this, or when we dispatch this action as it's called, that we set an ID property on this payload object. And you will see how to set that property in a couple of minutes. So therefore now we could expect to get this ID on our action payload, and we push this ID to our array of IDs. And here when removing a favorite, we also get such an action with such a payload. And therefore then we could update our IDs by using the built-in splice method, which can be used to remove an item from an array. And we now need to find the index of the item that we want to remove. And that could be done with state IDs index of, passing action.payload.id to index of to get the index of the item that should be removed. And then to splice as a second argument, we provide the number of items that we want to remove in this case. And we only want to remove one item, that one item which has this ID. That's what we want to do here. So now that's the logic we have here in our favorites slice. Now we need to export and expose a couple of things. For example, we want to export favorites slice, so this constant here, dot reducer. This is an internal thing, but we will be able to then merge this reducer into our store later. That's why we have to export it here. Besides that, we should also export two actions, as it's called. To be precise, these two actions, so that we can dispatch these actions and invoke these methods from different places of our app. For this, I will export a constant named addFavorite, though this name is up to you, which points at favorites_slice.actions, which is a property provided by the Redux Toolkit library, .addFavorite, so which points at this method here. And then I will repeat the same thing here with export const remove favorite by pointing at favorite slice actions remove favorite. These are the things we should export here. And now as a last step before we can start using Redux in the different parts of the app, we have to go back to store.js, and here we should import our favorites reducer, which is that default export from this favorites file in which we just worked. And in this reducer object here, in our configure store function, we should add any key of our choice, for example, favorite meals. and then point at this favorites reducer like this. And then we will be able to tap into this reducer from different parts of our app later. So that's the second step. Now let's see how we can use all of that. So let's now use Redux in the different parts of our application, and let's again start in the meal detail screen. There we again have this button, which we can tap in the header to toggle our favorite status, and we need to find out if this meal is a favorite at the moment. Now we're not using context anymore, so we should remove this or comment this out and get rid of these imports, which we don't need anymore, also the use context hook. And instead now we're using Redux. And to get hold of data in our Redux store, we can use a special React hook provided by the React Redux package. And that's the use selector hook. You should import this from React Redux. And then this hook can be used to get data out of our Redux store. In this case here, I want to get my favorite meal IDs. And we can get them by passing a function to use selector, a function which will be executed for us by React Redux, and a function which should accept a state parameter because that will be provided by React Redux when it executes this function. And then we can use this state parameter to drill into our store, because that in the end refers to our Redux store. And to be precise, we can use any keys that we set up here in this reducer object as properties on that state. And then we get hold of the different slices and the state managed by these slices. So we can then drill into our state properties inside of these slices. So that means that here we drill into favorite meals. So into state.favoritemeals.ids. And that gives us all these favorite IDs managed by that Redux slice. Now we can use these favorite meal IDs to find out if our meal is a favorite by simply checking if this favorite meal IDs array includes this meal ID. And that is how we can read data from the Redux store. Now to change data, we have to invoke these reducer methods here. But we don't do that by calling them manually, instead we dispatch them. That's why we exported them like this here. Now dispatching is also done with help of another hook, and that's the use dispatch hook, which is also imported from React Redux. This simply returns a dispatch object, a dispatch function to be precise, which we can execute to dispatch an action. Now to dispatch an action, we also need to import that action. And for this, we should import from store redux favorites. That is that file where we are exporting these actions. And from there, we can import add favorite and remove favorite. So simply these two functions in the end, which we are exporting, these two actions which are generated by Redux Toolkit for our reducer methods. We do have these actions here, and now when we remove or add favorites here in this change favorite status handler function, we instead call dispatch. So this dispatch function here, and to this function we pass the result of calling remove favorite. So this remove favorite thing we're importing here. This will create an action object which is then dispatched, and that's all done under the hood by the Redux Toolkit. Now to this function which we're executing here, remove favorite, we can pass the data that we would like to have in our action payload. And in our action payload, I expect to get an ID property. So I expect my payload to be an object with an ID property in both remove and add favorite. Therefore, we should pass such an object to remove favorite and set the ID property to meal ID like this. And then we do the same down here when we add a favorite, but instead of calling remove favorite, we call add favorite. That is how we can dispatch actions and how we can read actions with use selector. With all of that, if we reload everything, this should work. And if I go to the detail page, indeed, I can toggle this star, so that seems to work. Also on different meals, of course, not just on the spaghetti. But now we, of course, also want to get our favorite meals on this favorites screen. And that's therefore the next task. And of course, something which you can try implementing on your own before we finish this in the next lecture. So let's now finish this all by using this Redux state, this Redux store data, also in another component, the favorites screen component. There we also need it, and we of course learned how we can read data with help of use selector. So we're going to do the same thing here and not use context anymore. That wouldn't work anymore because of all the code changes I made. And therefore instead here we get our favorite meal IDs by using the use selector hook, which must be imported from React Redux. And then to use selector we pass this function which receives the state and which then dives into our favorite meals object here, and then on that into the IDs. And that gives us our favorite meal IDs here. And then we can use these favorite meal IDs here to find out whether the meal ID, which we have here when going through all the meals in the raw data, is included in our favorite meal IDs or not. And that is all. That's the only change we need to make here. The rest of this code works as before. So if we now save this, on favorites, we should have these two favorites which we added before. We can go to the detail page and unfavorite them. We can, of course, add other favorites. And this app therefore now works as it should. Of course, also on Android, if we take a look at it there, because it's now using Redux instead of context, and both are viable options. So that's it for this module. We now finished this app and we can now favorite or unfavorite our different meals. We can view our favorites on the favorites screen. We can then dive into the details from there and of course change the favorite status if we want to. And we achieved all of that with help of the Context API or Redux, whatever you prefer. In this module, you saw that both approaches can be used with React Native. And most importantly, you should have seen that it's really just React plus context or Redux. There is nothing React Native specific about that. We just use the Context API as we would use it in any React app. And the same is true for Redux, here at the example of Redux Toolkit. And that's the main takeaway, but you also now got two concrete examples, and you should therefore now be able to, of course, also use the Context API and or Redux in any other React Native app you might be building. By now, we learned a lot, and therefore it's now really time to practice all these things we learned, and we will practice all these things by building another app. An expense tracker app, which allows us to register our expenses, to add expenses, to also view all our expenses and edit expenses, and also to delete our expenses. And in addition, we can also switch between different screens where we can view our recent expenses and all our expenses. And this expense tracker app, which we're going to build in this course section, simply allows us to apply all the things we learned up to this point. We will add navigation and multiple screens. We will add layouts and styles to make this app look pretty and to have all the things laid out correctly. And we will also manage local and app-wide state, which means we will manage state that is specific to components. That would be this local state, but we will also manage some state that affects multiple different parts of the app and is important for different components in the app, and we will therefore also manage that. Hence, we will apply a lot of the things we learned up to this point, and we can therefore dive right in, though I want to say that this, of course, is also a great practice for you. You saw the app which we're about to build in this course section, and therefore my challenge for you is that you try to build this app on your own. That you simply try building this app which you're seeing here. All the data is just stored locally in memory, so you don't need to worry about connecting some backend or anything like this, because we will also use this app in the next course sections where we will then dive a little bit deeper into managing user input and where we will also explore how we could store that data on some backend server. But for this section, the practice is to build this app in an offline-only version. Definitely try this on your own first. We will start building this app together in the next lecture. So let's start building this app together. And for this, I created a brand new Expo managed React Native project here. And I didn't add anything there at this point. We really got a very basic empty React Native project here. And now we're going to add our different screens and our different pieces of logic step by step. Now, there are a lot of different ways of starting work on apps like this, but what I personally like to do first is add all my screens and set up the core navigation logic. And then we'll enhance that step by step by adding styles, by adding configuration to the navigation options, and so on. Hence, what I'll do as a first step is I will add a screens folder. I will also already add a components folder because we will need that later as well. But in the screens folder, I want to create my main screens components. And if you take a look at the app which I plan to build, then you can in the end identify 3 main screens. We have that screen with all the recent expenses. We have that screen with all the expenses overall, so with all the expenses, and we have that screen that allows us to manage expenses. So a screen that allows us to add new expenses and a screen that allows us to edit or delete expenses. And if you look closely, you see that it's always the same screen, so it's one and the same component which will be used in different scenarios and different ways. Therefore, in that screens folder, we can add these 3 screens, and I will add my all expenses screen here. So the all expenses JS file, which will hold the component that is used for this screen that shows all the expenses. I will add a manage expense JS file, which will be responsible for holding the screen that allows us to manage our expenses. And I will add a recent expenses JS file so that we also have a file that holds the component that will be used for showing all our recent expenses. These are the 3 screen files which I want to set up. Now we can already start adding some dummy React component functions in there, though we will add the exact JSX code and styling and logic that belongs to these different functions step by step throughout this section. Still, I will already add my all expenses function here in the all expenses JS file and also export it. And for a start, we can return some text here using this React Native text component, which therefore must be imported, where I say all expenses screen. And then I'll copy that into the manage expenses JS file, change the name to manage expense, also here for the export and also here in the text. So manage expense. It's not manage expenses, but manage expense because it's a single expense that we will be managing. And then last but not least, I'll copy this into the recent expenses JS file and I'll rename it to recent expenses, also for the export and also here in the text. And with that, we got these 3 component files set up with those dummy components. Now we can add our navigation configuration, at least the core setup. And for this, I will use the React navigation package about which we learned before. Now for that, we also learned how we can add it. We must install it. And just as before, I can always recommend that you dive into the official docs to learn all about this extension and how you can use it. And if you want to get started, here on the Getting Started page, we learned that we must install the @React Navigation native package, and we must add some dependencies, and then we also need to add all these specific navigators that we want to use. Hence, I will get started by installing @React-Navigation/native. So that's what I'll paste in here into my terminal in this project and execute. And whilst this is executing, I'm copying this command to install all the dependencies we need, so that we also install those dependencies here. And with that setup, we can now install the navigators that we want to use. Now, here in this demo app, I plan on using the Stack Navigator for opening this overlay that allows us to manage an expense, and the Tabs Navigator, the bottom Tabs Navigator to be precise, to show these, well, tabs at the bottom. Therefore, we can have a look at the API reference of those navigators. And for the native Stack Navigator, we need to install it like this. So I'll copy this command and install the @React-Navigation/native-stack package for this native Stack Navigator. And thereafter, for the bottom tabs, I will grab this here, my bottom tabs package, and install this as well, like this. Now, with that, we installed all these different packages. We can close this extra terminal window now. We, of course, need to keep our npm start process up and running. And we can now set up our configuration for the navigation. And we will tweak this and change this throughout this course section, but we'll start with a basic configuration in the next lecture. So let's now start setting up our navigation configuration. And I will do this in app.js as I did it before. You don't have to do it in there. You could do it all in a separate file and just import your configuration setup, your configuration component into app.js. But I like to set up my navigation code here. And I will start by deleting the styles in app.js. We don't need them. I will also delete all that content here. Actually, not the status bar, but view and text, because we don't need that either. We can therefore get rid of these imports here from React Native. And I will then add this fragment here, this fragment tag, to wrap it around status bar, because below my status bar, I now want to set up my navigation configuration. And for this, just as we learned it before, we need to import something from @React-Navigation-native, and that something is the navigation container. This is a component that must be wrapped around all your other navigation-related components, or all the other components coming from the React Navigation packages that deal with setting up your screen structure and your navigation structure overall. So therefore, we can create an opening and closing navigation container here next to the status bar in our app component. And we can now start setting up our navigation. Now for this, I want to create a stack and a bottom tabs navigator, and therefore we need to import from these two packages. We need to import from @React-Navigation-native-stack for the stack navigator, and we need to import from @React-Navigation-bottom tabs for the bottom tabs navigator. Now from the native stack package, we can import the create native stack navigator function. And from the bottom tabs package, we can import the create bottom tab navigator function. And then here we can create a stack constant which holds the result of calling create native stack navigator. And as you learned before in an earlier module, this stack constant will hold an object that gives us access to two components, the navigator component and a component for registering screens. And we'll do the same thing here for the bottom tabs by calling create bottom tab navigator. Now, then we can set up our navigation here, and we want to work with nested navigators here, since we have two navigators, stack and bottom tabs, that will need to work together. Now, when it comes to nesting, there are always different approaches you can find, and it depends on the desired end result you want, but I want to make sure that I, in the end, have this manage expense screen, which allows us to edit or add expenses, which is reachable from everywhere in this application. And if we are on that screen, then I don't want to see the tabs at the bottom. On the other hand, I want to have tabs at the bottom that allow me to switch between all expenses and recent expenses. And therefore, the setup I choose here is that I will use the Stack Navigator as a main root navigator here, so to say. And I will add two screens to this Stack Navigator. One screen is the Manage Expense screen, and the other screen is a nested navigator that will be based on the bottom tabs that will be responsible for allowing us to switch between all and recent expenses. Therefore, we can add our Stack screen here. And the first screen I'll register here is this Manage Expense screen, which allows us to edit or delete or add expenses. And the component that should be loaded if we navigate to that screen should be the Manage Expense component. Hence, we must add an import to that component and then point at it here. Now, the other screen I want to register here in the Stack Navigator is this Nested Bottom Tabs Navigator. Therefore, I will first of all create another component. And we could create that component in a separate file, but I'll keep it here to have all my navigation set up in this file, which is not a must-do, as I mentioned, just something I like to do. And I will name this component Expenses Overview, though the name, of course, is up to you. And in there, I will return my bottom tabs setup. So we create our bottom tabs navigator here, and then we register the different screens that we want to have in that navigator. So for example, the first screen that I want to register here is my screen that should show the recent expenses. Hence, I'll give it a name of recent expenses like this. And then the component that should be loaded here is, of course, the recent expenses component, which also must be imported from the appropriate component file. Now, that's the first screen we want. The second screen I want to have in here, and which is therefore registered with bottom tabs.screen, is the all expenses screen. And as you can guess, here we want to point at the all expenses component, which must be imported. So that's the core setup for the expenses overview, which will become our nested navigator. Hence, I will use expenses overview as a component that should be loaded for my second stack screen. So here in the stack navigator, in this root app component, we add another screen. The name here could be expenses overview. And the component that we load is that component that sets up the bottom tabs navigator, and therefore we actually then have the choice between two components thanks to the bottom tabs. So here I'll point at the expenses overview component we created a second ago. Now what I will do is I will switch the order of these two screens, because the topmost screen that you register in the Stack Navigator will be the first screen that's loaded when the app starts up. And I want to load this overview screen where we have the tabs and can switch between recent and all expenses. I don't want to start the app with showing this manage expense screen. That wouldn't make a lot of sense. Alternatively, we could also set the initial screen option here on the Stack Navigator. As you can see in the official docs, there you learn that you can set the initial route name, that's the name of the prop on the Stack Navigator component to control which route should be loaded initially. But I will simply use the order of screens here to define that expenses overview should be the main component loaded when the app starts. Well, and with that, we got all that core setup. If we now saved it all and we force a reload to make sure that all the changes get applied, then we can actually see our tabs here at the bottom. They don't have icons yet, we have to set them later, but we can see that they work. We can switch between recent expenses and all expenses, and this works on both Android and iOS. At the moment, we then got 2 headers, and it's not looking pretty, and we have no way of reaching manage expense, but it's generally working. As a next step, we can now refine our navigation configuration and work on the styling of our headers. We can work on the icons that are used here in the tabs and the text that we can see here. We can work on the header titles, and we'll do all of that in the next lecture, but we got a working navigation setup already. So let's now tweak the configuration of our navigators to make this all look a bit prettier and more the way we want it to look. And I would suggest that we start with the headers. For a start, I don't want to have 2 headers, but just 1. And I also want to change the colors and the titles that we see there. Now, to achieve this, I first of all will start here in my Stack Navigator setup. And here I want to make sure that if we are on the expenses overview screen, we don't see the header of this Stack Navigator, but of the Tabs Navigator instead, so that we don't have 2 headers here. This can be achieved by adding options to this screen, and the option which I do add here is this header shown option, which I set to false. Now, I only add this option to this screen and not to the overall navigator as screen options because for manage expense, for this screen, I want to use the default header of the Stack Navigator because this screen will not be part of the bottom tabs navigator. Instead, there is no other navigator responsible for this screen, and if we would hide the header here, this screen wouldn't have any header at all, and I don't want that. You could disable it if you don't want a header, but here I do want a header, and therefore I'll definitely not disable it for this screen, but just for this first screen, which is in the end that screen, that component that renders the bottom tabs navigator. So with that saved, the double headers are gone, and as you will see later on the Manage Expense screen, there we will still have a header. Now I also want to change the styling of the header here, and for this we will have to go to the bottom tabs navigator because we're hiding the header for this screen here in the Stack Navigator, hence it's the bottom tabs header that's visible now, hence that's the place where we have to style it. And here I want to have the same styling for all my screens, so for both tabs, hence I will apply the styling for the header with help of the screen options prop on the bottom tabs navigator itself. And then here on these options, I want to set various colors. Now when it comes to these colors, we could hard code them here, but I will already create a new folder, which I'll name constants, in which I'll add a styles.js file, where I then want to export a global styles constant, so a constant which I name global styles, which is an object where I will add a colors property, which holds a nested object where I want to manage the colors I will work with in this app. And actually, I already created a palette of colors with which we can work throughout this section. And to make it a bit easier for you, you find this attached. You find my styles.js file attached. And this will then contain this palette of colors in this colors object, which are a bunch of colors I pre-configured for this app. You can, of course, tweak them, you can choose different colors, but these are the colors I will work with, and you can just use them as well if you want to. So now with that file added, styles.js in a constants folder, and with the colors added in there, we can go back to app.js and use the colors in the screen options of the bottom tabs navigator to style our tabs headers here. And for this, I will start with my header style property, which we can set, which allows us to set the background color of the header. And here I want to use my global styles object which must be imported from the constants folder and the styles file in there. And on global styles, I want to access the colors property and then use the primary 500 shade here. That's the color I want to use as a header background. Now, the header also must get a tint color, which is then the color used for the title and so on. And for this, we can set the header tint color, which I will set to white. Now, I don't just want to style the header, I also want to style the tab bar at the bottom, and I want to give it the same background color and so on. For this, we can add more properties to the screen options, because I want to have the same tab bar styles for both tab screens. If that would not be the case, you could apply screen-specific styles through the options prop on the screens. But here I want to have the same styling for both screens, hence I will use screen options on the navigator itself. And we can then give the tab bar a style with the tab bar style object and set a background color as well. And I will set the same background color as for the header, so that's my primary 500 shade. I also want to make sure that the active items in the tab bar are well visible, that we can see them really well. And therefore, we can add a tab bar active tint color, which will control the color of the items that are active in the tab bar. And here, I will actually reach out to global styles, to colors, and use my accent 500 shade. With that all set up, if we save everything, you should have a header and a tab bar that looks like this. And I think this doesn't look too bad, though as mentioned, you can of course adjust the colors however you want. But I'm quite happy with that look, and with that we got the colors set up the way they should be. Now what's of course missing though are the icons, and I also want to adjust my header titles and the text below the icons in my tabs. And I don't set this up in screen options here because of course the titles and the icons and so on, these are elements that change for the different screens. We don't have one setup for all the screens, we have different settings for the different screens of course. Therefore, we set those options on the screen components themselves. We can start with the recent expenses and set our options to an object here, where in this object, we for example set the title, which will set the header title to recent expenses like this. So almost as it was before, but now with a white space inside of it. I will also set the tab bar label here and set this to recent expenses as well, or just recent. Maybe just recent, it's up to you. And last but not least, we can set the icon that will be used for this screen in the bottom tab bar by using the tab bar icon setting here in the screen specific options. Now this actually wants a function, a component function, that returns a JSX element that is rendered as an icon. We get some props here automatically by React Navigation. To be precise, we for example get the color and the size of the icon that should be returned, and we can use this for configuring the icon. And for creating an icon, I will use another package which is already part of the project, because I will use the vector icons package from Expo. So from @expo vector icons. And I will use the good old Ionicons, which I used before in the course already. Now this is a component that we can use, and therefore here I will return this using the shorter form of my arrow function here. And on this Ionicon, I will set the name to our class, which is the icon I would like to use for my recent expenses, and set the size to size and the color to color like this. And we can then apply the same options to all expenses, so copy it over, but then of course adjust the title to all expenses, the label to all or all expenses, and I'll go with the latter here. And for the icon here, I will use calendar, like this. and also just forward size and color as we're getting it from React Navigation. Now, just to be clear, all these options here, which I set on my screens and on the navigator, are described in the official docs. So you'll learn about all these options here in the API documentation for the bottom tabs or for the native stack navigators. You'll learn about all the props and options you can set here, and these are just the options I did set here in my configuration. With that all applied, if we go back, we have different icons, different labels, and different header titles. And therefore, this app is slowly taking shape, and this is another huge step forward. Now, as a next step, we can start working on the actual content of these screens before we then also, of course, start working on the logic of this application. So let's now start working on the content of these screens. And here, it's actually the same kind of content for both the recent and all expenses screen. Because in both these screens, I want to output my expenses, a list of my expenses, and a little summary section above those expenses. So therefore, what we can do is we can create a shared component that we could name expenses output.js. And I will actually put it into a subfolder in my components folder, which I'll also name expenses output, since we'll add a couple of other components as well that will work together with that component. So now I have an expenses output folder in the components folder, and in that expenses output folder, I have an expenses output.js component file. And in this JS file, we can create our expenses output component as we always did. We can export it, of course, to make it available outside of this file. And then in here, I want to return two main things. A short summary about all the expenses that are part of that output, and a list of all the relevant expenses. Therefore, I expect to get some props here. And I will use object destructuring to pull out these props here in my argument list. I expect to get the items to be precise, so the expenses. Maybe that's a better name. I expect to get the expenses that should be displayed in a list and that should be summarized. And then we can output both here, wrapped in a view to also apply some styling. And inside of that view, we then have this summary, and we'll replace that with a proper component soon, and a list of expenses below that. Now let's start with the summary. For the summary, I simply want to output the period of those expenses. So are these all the expenses or the expenses for the last 7 days, for example? And I then want to output the total sum of all those expenses. Therefore, here I'll add another nested view for styling and layout purposes. And in that view, a text, or to be precise, two text components. In the first text component, I want to output the period. So here we want to say something like last 7 days to give some context about the expenses that are being summarized here. And then here we want to have the sum in dollars, like 177.95. Now, for the moment, this is both hard-coded. Soon, this will be configurable. So that's one part. That's the summary part of my output here. And below that, I then want to have a list of all the expenses. Now, for the list, we can use a good old flat list because we want to have a scrollable list. And this list should be optimized for performance because we could potentially have a lot of expenses and we don't want to load and render them all, even if they might not be visible on the screen. That's why we would use flat list here. So here we can then use flat list, which also must be imported from React Native, flat list like this, and we can then output our expenses here. Now, since we have these two different elements, we could keep them in one and the same component, but it is kind of a good practice in React in general to split your bigger components up into smaller components. And therefore here, to also practice this a bit more, I'll add another component here in the expenses output folder, which I will name expenses list.js. So this sits next to the expenses output. And then I also add an expenses summary.js file. And in expenses summary, we will create an expenses summary component like this and export this, of course. And we can copy this over to expenses list and just name it expenses list there. And then here in expenses list, we will return that flat list, which is imported from React Native, to which we will add some content and configuration soon. And in expenses summary, here I in the end want to return that view with these two pieces of text, which I will therefore cut from expenses output and move into expenses summary. And in expenses summary, in this expenses summary.js file, we therefore have to import view and text from React Native in order to use these components here. And I'm just doing this to split up my bigger component into smaller components where every component then has a single responsibility and its own styling. It's not required technically, but considered a good practice. So in expenses output.js, we can now output the expenses summary here. So this custom component can and should now be imported and should be output here. We therefore don't need the text component in here anymore. And below expenses summary, we can output the expenses list, which also must be imported from our own component file here. And we can therefore also get rid of the flat list import here in expenses output.js. So that's now the core setup, though of course it's missing all the configuration and data that it needs to work. And that's therefore what we will continue with in the next lecture. So now that we created the general structure of our own components, it's time to add more meat to those components to make them more useful. Now in expenses output.js, I'm getting my expenses, and I expect that this is simply an array of numbers or of objects where every object represents one expense. And actually an expense should be an object because an expense is not just a number, but also a description and a date. So I expect to get an array of objects that have descriptions, dates, and numbers, and maybe an ID. Now for the expenses summary, we also need a short description of the period, a short name for the period of expenses that we're looking at. Therefore, in expenses summary, I expect to get my period name here as a prop. And instead of hard coding this here, I will output period name here like this. Of course, for this to work in expenses output, where we use the expenses summary, we must set this period name prop. And since expenses output will be used in both the all expenses and recent expenses screen components, this also must be a prop of expenses output. Because the period name will not be set in this expenses output component, it will be set in the two screen components that use the expenses output component. So besides accepting expenses as a prop here in expenses output, I also get my period name here, or my expenses period here, something like this. This also must be accepted as a prop and then should be forwarded to the period name prop of expenses summary. Now to expenses summary, we also should then pass our expenses. So I will forward the expenses which I get as a prop here in expenses output to an expenses prop on expenses summary. And this prop therefore should be accepted in expenses summary like this. And we then must build the sum of all these expenses, so of the expense amounts. And for this we can calculate our expenses sum here in the expenses summary component by taking a look at our expenses And as explained, this will be an array full of objects. And on this array, we can call the built-in reduce method. Reduce is a standard JavaScript method that can be executed on arrays, and it allows you to combine multiple values in an array into a single value, a single number, for example. For this, reduce takes a function as a parameter, and this function will automatically receive the current value, which will change for every function execution, and this function will be executed for every element in expenses. And here that will be the sum that I want to calculate. And then the second value this inner function will receive automatically is the current item we're looking at. Because again, this will be executed for every item in the expenses array. So therefore we will get every item for every execution. And we then get a total value which is carried over across those executions to build a final result from all these executions. And here we then have to return a new value which will be carried over as the first argument to the next function execution for the next item here. And here I simply want to return my sum plus the expense amount of the expense we're currently looking at. And for this, I simply assume that expense is an object that has an amount property. And we will have to make sure later, once we start creating expenses, that this will be the case, that our expenses will have amount properties. Now, you can also add a second argument to the reduce method after this function, which is the first argument. And this second argument is a starting value for this carryover value for the very first item for which this function is executed. Otherwise, this would be undefined. Here, I'll set a starting value of 0 so that for the first expense, sum is 0. Then the amount of that expense is added. And for the second expense, the result of the first execution will be used as a sum, and the next amount is added. And this is done for all the expenses until we have a final sum. And that sum will then be output here after the $sign, which I keep here hard-coded to show that total sum. Now, as a last step, I just want to make sure that we also call toFixed on this result here and pass it to toFixed. And toFixed is another built-in JavaScript method which ensures that this will be output as a number with exactly 2 decimal places. If it has less than 2 decimal places, it will get 2 decimal places, 2 zeros. If it has more than 2 decimal places, those places will be cut off, so that we get a nice clean number with 2 decimal places being output as a sum here. So that's now the expenses summary component, already with some logic added to it, but that's the component we will need later for outputting a summary of all our expenses. In expenses output, we're using this component, and we're passing all the necessary data into expenses summary through props, and therefore this component should work if we had any expenses, but we have none. Now, expenses list also won't work without any expenses, and therefore as a next step, before we work on the expenses list component internally, and we start passing data into flatlist, and before we then start adding styling, as a next step, before we do all of that, we will set up some dummy expenses data so that we have something to look at. So let's now add some dummy expenses. Later, we will of course add functionality that allows users to add their own expenses. Now, to add some dummy expenses, I'll just go to expenses output for now and add a constant here, dummy expenses, which is an array full of objects, and every object will represent one expense. Now here, every object should then have an ID, because every expense should have a unique ID by which we can identify the expense. This will also be important for editing or deleting it. And I will simply use E1 for the first expense, E2 for the second expense, and so on. Then every expense should have a title or a description, which later can be entered by the user. For the moment, I'll enter some dummy text myself, like a pair of shoes. And then we need the amount. The amount can be any value you want, but it should be a number like 59.99. And here for this app, we will assume that this is in US dollars or any other currency you want. In the end, this only matters here in summary, where I output a dollar sign, and later when we output the expenses in our list. Now we also should add a date, because that date will be needed to differentiate between recent and all expenses. Recent should be the last 7 days, at least in this app, and we need a date to find out which expenses are part of that period. And hence here we add a date, and this date can be set by constructing a new date with the built-in date object that is available in JavaScript. And to this we can pass a date formatted in the following way, where we say 2021-12-19 to add an expense that occurred on the 19th December 2021. You can of course pick any date you want. And now, according to this logic, I'll add a couple of other expenses as well. For example, a pair of trousers here for, let's say, 89.29. And let's say this occurred in January 2022. And then I'll copy this and add another expense here where I say some bananas, and that's, let's say, $5.99. And that occurred, let's say, again in December 2021, maybe the 1st December. Then I add a fourth expense here. That could be a book, and that maybe cost like $14.99. And here we say that this occurred in February 2022, let's say February the 19th. And I will add one last expense here, and this is E5, where I bought another book because I'm really creative, let's say for $18.59. And this occurred on February 18th, 2022. So now I got some dummy expenses with some dummy data set up, and we can now pass those expenses as expenses here to the expenses summary component. Now, again, normally we would receive those expenses from outside through the expenses prop from the all expenses and recent expenses components, and that's how we will do it later. For the moment, I will just add the dummy expenses here and use those dummy expenses here as a value for the expenses prop of the expenses summary. But that is just something we will do temporarily. Now for the period name, I will set this from outside though, and I will use the expenses output component in all expenses and recent expenses. So here in all expenses, we can return the expenses output component we just worked on. And for this, we of course must import it from the components folder, and we can get rid of that text import which we had here before. And we can now set this expenses period to, let's say, total, because that's the total for all the expenses in this component. And then we can do the same here in recent expenses, get rid of the text import, and instead output expenses output here, and import that of course, and set the expenses period here to last 7 days, because that will be my recent expenses. For the moment, please keep in mind that we have no logic for actually filtering for the recent expenses. For the moment, with our dummy expenses set up in expenses output, we will always output all the expenses. This will change later. So with that, we're yet another step closer to our first intermediate result. As a next step, let's now work on this expenses list before we then finally can see something on the screen. So let's now work on the expenses list. Now we do expect to get our expenses here as a prop, because we need them inside of this component. Hence, I'll forward my dummy expenses to expenses list through an expenses prop to that component. And then in expenses list, we can expect to get this expenses prop here. And to flat list, we can forward our expenses array to the data prop. You learned before in the course that flat list has this data prop, which wants an array, which will then be handled internally by flat list to output these items of this array. Now, to output the items, we can use the render item prop, which wants a function that will be called for every item. We could define a brand new function here or create it inline, but here I'll create a separate function, which I'll name render expense item. And here we will actually get some data for that item. And we can then return the JSX code that should be output for every item. So first of all, here I'll point at render expense item then to call this function for every item we pass to flat list. And then here we want to output the JSX code for a single expense item. Now, this will get a bit more complex later. For the moment, I'll just output some text here with the text component from React Native. And I will simply output item data dot item. You have this item property in this object that's passed in automatically by flatlist, and this will then be one of the items in your array. So all these items are output, all the array items you pass to data are output here through render expense item, and therefore inside of render expense item, you get access to a single item of your array here, one at a time, through this item property on this incoming item data, which is sent in by flatlist. And this item therefore will be such an expense object, and we will go through all these expense objects. And here, let's say we want to output the description just so that we can see something on the screen. Hence, we can access .description on item data. Item data is more than just the item. That's why we have this item property. We could have also accessed the index property, for example, to get the index of an item. But here I'm interested in the item itself. Last but not least, we also need to take care about keys. And for this here, with flatlist, we can add this key extractor prop, about which we learned earlier in the course already as well. Key extractor also wants a function that basically tells flatlist which property of the item for which it's outputting some JSX code should be taken as a unique identifier, as a key. Therefore, key extractor also gets the item, however, really the item itself, not some wrapper object, as it is the case for the render expense item function here, but the item itself. And this function will be called for every data item, and we should return the value that should be used as a key. And in my case here, that's the ID. Every expense has an ID, and this will be unique, and therefore it's a good key. And with this line of code, we tell React Native and the flatlist component to use that ID as a key. Now again, we'll add styling later, but this should output such a flat list. And therefore now, if we save everything with our all expenses and recent expenses screen components outputting expenses output, we should see last 7 days or total, depending on which screen we are. You see, this changes as I change screens. Below that, the sum, and then the same list of items. And the sum and the list of items is always the same for both screens because we have no logic for filtering our items yet, but this is a start. Now, before we add any filtering logic, let's work on the layout and styling next. As always, definitely something you can try on your own first. Starting in the next lecture, we will implement this together. So let's now diving into styling and creating layouts for these different screens and components. And for this, let's maybe start with the summary component again, with the expenses summary component. Now, of course, as always, the exact layout and styling is always up to you. Here's just one suggestion from me. For this, in the expenses summary component, I'll add my styles constant, my styles object, with help of the style sheet object from React Native, which therefore must be imported from React Native, which we have used many times before in this course already. To this style sheet create method, we pass an object, and in this object we can then define our style objects with their style properties. And here I want to set up a general style for this wrapping container, and then a specific style for the period and for the amount, for the sum. Now for the container, I'll give this style object a name of container. And now here I think what will look good is if we give this a little bit of a padding, then a nice background color to set it apart from the background, so from the overall screen background I mean, where I will use my global styles from this constants styles.js file. And for this, the global styles, of course, must be imported like this. And then with that imported, we can access our colors there. And I want to use primary 50 here as a shade, which is a really light purple color because I will later also change the overall screen background color. And then this light purple background color on the summary part, in the summary section, will look pretty nice on that overall darker screen background, which we will add later. I also think that rounded corners look good, so we can add a border radius of 6 to this container. And then we want to manipulate the flex properties because I want to make sure that the period name and the sum are next to each other and not below each other. For this, we need to switch the flex direction from column, which is the default, to row. And then I want to have spacing between the two items here that are in that row. So between the two pieces of text. And that, of course, can be achieved with justify content space between. Justify content because with flex direction row, the main axis now is left to right, and justify content does target that main axis. And then I also add align items center to center these two items, the period name and the sum, vertically. Now we can set up the text specific styles, and for this here, I'll set up my period style, which will be applied to the period text. And give this a font size of, let's say, 12. And give it a color of global styles.colors.primary 400, which is a darker purple. And then I'll add my sum styling, where I want to give this a bigger font size of, let's say, 16, and a font weight of bold, and then also a color. And here I'll use almost the same color, but I'll use a slightly darker purple with the 500 shade. Now, as a little side note, here in this app, I'm using the default system fonts. You could, of course, also set up custom fonts as you learned it earlier in the course. Here, because I like those default fonts, I will stick to them. Now we set up all these styling objects in our style sheet. Now we can apply them to our elements here, to our JSX code. And the outer view should receive the container. So we add the style prop and then add styles.container. And this period text will receive the styles.period styling object. And the sum, the amount text here will receive the styles.sum styling object. With all of that done, if you save everything, this is how it should look like. That is not the final style. This is just an intermediate style, but it doesn't look too bad. Now it will look much better as soon as we change the overall screen background. And for this, we can go to the expenses output component here, because that will hold the summary, and that is the main component that is returned by both the all expenses and recent expenses screen components. So if we change the styling here, we will affect those two screens. Now we do have a wrapping view around our summary and list here, and we can use this view to manipulate the style of the screen, the background of the screen, for example. For this, we can now also add our styles object here with style sheet, of course, imported from React Native as always. And then on style sheet, as always, we call create and pass an object to it, like this. And then in this object here, I will set up another container style for this view that wraps the summary and the list. And here on this container style, I want to add a lot of padding, let's say 24 pixels, and a background color, which will therefore be the main background color of this screen. And here I'll also use my global styles, and therefore, just as many times before, you of course also must import those global styles here. You must add this import in expenses output.js, as we did it in other component files as well. And then here we can access global styles.colors.primary700. Now we can apply our container style to this view by setting the style property to styles.container. And if we do that, and this by the way is a very dark purple, if you check the colors here, it's a very dark purple. If we do all of that and we save everything, now we get this background color. Now we also see the padding in effect, and this looks better. Now, of course, what would also look pretty good is if this would take up the entire available screen estate. And that, of course, can be achieved by adding flex1 to this container. So if we add flex1 to the container in expenses output, then this takes up all the available screen, and this looks quite a bit better. So that's another major step forward. As a next step, we can now style this list here. But for this, I also want to change my list items, because actually an expense that's shown on the screen should not just be a bunch of text. We also want to display the date and also the amount, of course. And therefore, in the next lecture, we will work on these expense items and then also on the styling of these items and the overall list. So let's now work on these list items. And for this, since the actual JSX structure of these items will become a little bit more complex, I will add another new component, the expense item component in the expense item.js file. So in here we have our expense item component like this, and we can export it like this. And then here I want to return a component that should be pressable. This will become important later because we should be able to tap those expense items in order to open up this overlay, this manage expense screen to be precise, which then allows us to edit or delete these items. So therefore we'll have a pressable component as a wrapper, and then in there a view. And both pressable and view are imported from React Native. That view will be used to style the overall container that holds all the expense item information. And we'll have multiple such expense item components below each other as part of our overall list. Now, in such an expense item, I then want to have some text, of course. And this is also imported from React Native. And I want to have the description for this expense. Then I want to have the amount, and I want to have the date. Now all of that should also be laid out in a nice way, and therefore I'll add another view, and this view will hold the description and the date. These two items will sit above each other, and together I then want to position them next to the amount. So on this view, which holds this inner view and the amount, I will set flex direction row later. And on the inner view here, I will keep flex direction to column to make sure that description and date sit above each other. Now I will also wrap this amount into a view though, because I also want to add some extra styling to that, which will be easier when wrapping it in a view. So that's now the JSX markup that I want. Now, of course, we don't want to have that dummy text here. for description, date, and amount, but instead it would be reasonable to expect that we receive some props here, which I will then pull out of the incoming object with help of object destructuring. And I expect to get the description, the amount, and the date of an expense as props here. Therefore, I add these 3 props here to this object destructuring assignment. And then we can output them here. We can output the description here, the date here, and the amount here. So that's now the structure of an expense item. Let's also add the styling right away. For this, of course, we can add our good old styles object here with stylesheet.create. And as always, you must make sure that this style sheet is imported from React Native. We saw that multiple times already, but it is important. And then here we can set up different styles. For example, we can set up the item style or the expense item style, which will be applied to this outer view. On this view, I want to add a padding of 12 to have some distance to the edges. I want to add a vertical margin of 8 to make sure that multiple expense items that are output as part of a list do have some spacing between them, so that we have some vertical spacing between multiple expense items with help of margin vertical, which is that outer space around the container. And of course, I want to have a nice background color, for which I'll again use global styles, which is imported from that constants styles file, which we also used before. And then on global styles, I'll access colors, and then it's the primary 500 color, which I want to use here. Now, as mentioned before, this view here, to which we will apply expense item, should have flex direction row to position this view and this view next to each other. And therefore, I'll set flex direction row here, and then also justify content space between to push these items in the row away from each other. I will also add rounded corners with border radius 6, let's say. And I then want to set up a nice little shadow. Now, we can add elevation of, let's say, 3 for Android. And for iOS, I will add a shadow color where I will use global styles colors gray 500, which is a purplish gray, and a shadow radius of 4, and a shadow offset, which is an object with a width of 1 and a height of 1. And of course, feel free to play around with these settings to get the shadow you want. Here I will then also add a shadow opacity of 0.4. But again, definitely tweak those settings to your requirements. So that's the overall expense item style. We also got some text in there. And for that, I will create a shared object, which I'll name text base, where I set a general text color that I want to use on multiple text elements inside of this expense item element here. And the color I want to use here is global styles.colors.primary50. Then, in addition, I will add some specific style objects for the description text, for example. And here, for the description, I want to set a font size of 16. I want to add a margin to the bottom of 4 to have some vertical spacing to the bottom between this text and whatever is below it, which in this case will be the date. And I'll give it a font weight of bold to make this description stand out and make it bolder. Next, after this description, I will also add a price container, which is the styling that will be applied to this view, which holds our amount. And actually, therefore, let's name it amount container. That sounds better. And here I will add some horizontal padding, so to the left and right of 12, and some padding, and also some vertical padding of 4, so that we have some inner spacing around the content of this container, but less spacing to top and bottom than to left and right. I'll give this a background color of, let's say, white. So this container will have a background color of white. And I want to center the content horizontally and vertically. And since this is a flexbox container, like all views are by default, we can set justify content to center and align items to center to achieve this vertical and horizontal centering. Last but not least, I'll also give this container a little border radius of, let's say, 4. And now, last but not least, I also want to define the styles for the text inside the amount container. So I will name this amount and give this a color of global styles.colors.primary 500. So use this darker purple and give this a font weight of bold. That's now the overall styling that I want to apply here. And with that all written down, we just have to assign these style objects to our different JSX elements. This view here, for example, receives the styles.expenseItem styling object. Then here in this view, this first text will receive multiple styles, hence I'll pass in an array, and I want to add my text base style and my description style here. The date will then just receive this text base style, and that's why I created this as a separate style object so that we can reuse it, even though it's just a color. But this shows you how you can reuse styles for multiple objects, just like this. And you can then still add extra styles, as we're doing it here for the description, if you want to. Next, I will add a style to this view, which holds the amount, and of course that should be the amount container. And then this text here receives the amount style. Now that's the expense item. At the moment we're not using this though. Now I do want to use it in the expenses list component. In there, in render expense item, instead of rendering this dummy text, we should render our expense item like this. Get rid of this text import and then pass our props to this item. And in the end, what we can do here is we can just spread all our item properties into expense item. Because our items in this array are these dummy items with ID, description, amount, and date. And even though we don't need the ID in expense item, we can still forward it into it. And all the other properties have exactly the prop names I am expecting in expense item. So as long as you also have this similarity between the prop names you are expecting here and the property names you chose in the raw data, as long as you have that, you can just spread the raw data into expense item. And this syntax will then expand your raw data into key value pairs where your property names are used as prop names and the values are used as, well, values for those props. That again is nothing React Native specific, that is standard React with standard JavaScript. Alternatively, you could of course also set all those props manually if you wanted to, but here I'll use this shorter approach. Now, with all of that out of the way, if we now save that, I get an error, can't find variable item. Because that should be item data here, not item. So we save this and force a reload. I get another error that objects are not valid as React children, as this should probably say, and that is related to the date. I'm outputting my date here like this, but actually the date is an object here. We want to transform this into a string in order to output it, and to transform this, for the moment I'll just call toString. We will fine-tune this later. With that, if we force a reload, this should now work. Looks like it crashed on Android. Let's see if we can restart it. Yeah, it's coming up again. And the styling is not final, as you can tell, but it generally works. And the styling is not final because the date is too long, which we will fix soon. But we got this list, we can scroll it, and we can also see if this works as a list, if it would get too long, by simply adding more list items here. And for demo purposes, I'm just going to copy most list items which I already have. add them to my dummy items here, and just make sure that I still have unique IDs, but I'll keep the descriptions and amounts to keep this simple. And if we do this, we can see that we can also scroll that list. So that works as we would expect it to work. If you want to make sure that you don't have this strange gap here at the bottom, you have to make sure that in expenses output, where we add the padding in all directions, you don't add it in all directions, but instead we set a horizontal padding of 24, so left and right, and a padding to the top of 24. But to the bottom, we set a padding of 0, so that there is no padding to the bottom, and now this gap at the bottom is gone. So with that, we got our list, and this is working as it should here. Now we can work on the date to make sure that we have a properly formatted date that looks a bit nicer. This will also then fix this issue we have here with the amount. Now let's work on that date problem here in expense item. And to fix this, what I will do is I will add a little util folder here in my project for utility. And in there, I'll add a date.js file where I want to store some date-specific utility functions. And I'm creating that file because we will actually need 2 date-specific utility functions throughout this app and module. The first function, which I will also export, is the getFormattedDate function, which should receive a date object as a parameter, and then should return a string which is formatted in a certain way. And there are different ways of formatting dates. You could also use third-party libraries that help with that. I will keep it pretty simple here, and I will just output a string manually using string interpolation with this template syntax here, which we have in modern JavaScript, where I want to output the year, the month, and the day separated by dashes. And we can get the year by using the date object that we are receiving as an incoming parameter value and calling get full year on it. Then for the month, we can call get month. And these are all built-in methods that exist on date objects in JavaScript and that is supported by React Native. And we can then call get date here to get the day. So that's what I output here. And now we can use this getFormattedDate function in expense item here where we output the date. We can call getFormattedDate. Of course, we need to import this from the util folder and the date file there and pass our date to this function. And if we do that, if we save that all, then we got a nicely formatted date. And now this amount field here also looks a bit nicer. I think it would look even nicer if we also had less chumps here in our sizes of these amount boxes. And this could be achieved with another value, which you saw before in the course already. In the styling on this amount container, we can give this a min width, let's say, of maybe 80. And if we do that, we have at least that min width here. And it could get bigger if more space is needed because of bigger values, but we have at least that min width, which means that most expenses look equal here. And that doesn't look too bad, I would say. But there actually is one problem if you take a closer look at our dates here. If you take a closer look, you see that, for example, I bought a pair of trousers in a month that seems to be 0. What does this mean? And the problem here is simply that in our util folder in the date.js file, getMonth returns the month, but it kind of returns the index of the month, which is the actual month number as we humans know it, -1. So January becomes 0, February becomes 1, and so on. The solution is simple. We have to add 1 here to that value returned by getMonth. With that, if we save that, this looks better. And for the day, we don't have the same problem. Here we can see that in our raw data, the first expense has a date of December 19th, And that is what we see here as well. But we had to fix the month. So that's just a little side note. And with that, we can now continue and work on the rest of this app. And actually, there is one other thing I wanna work on here in expense item before we continue, and that is the amount which we're outputting, just as with the total sum here in the expense summary component. I want to make sure that we always have exactly 2 decimal places here, and therefore I will also call toFixed2 here on this amount in the expense item component. And with that, we now got this fixed as well now, and now we can continue with the rest of this app. So slowly but steadily, our app is taking shape. How can we now continue working on this app? Well, there definitely are a couple of things we can still add and we must add over time, but I would like to continue with this Manage Expense screen component. We will actually build the final form of that component and of all the user inputs that we want to show to the user in the next course section when we dive a little bit deeper into handling user input. But in this section already, I want to make sure that we have a plus button in the header, which we can tap to open this screen to add a new expense, for the moment with a dummy button in the next section with some actual user inputs. And I want to make sure that we can tap these single expense items and we open that same screen in a different mode so that we can edit or delete one of these items. And that's actually the next thing with which I'd like to continue. Now, for all of that, we can start by adding such a plus button to the header and making these expense items pressable so that we can open this extra screen. Keep in mind that we did already configure this extra screen in app.js. There in our Stack Navigator, we did already register Manage Expense as a screen, so we just need a way of opening it. And we could start by adding such a plus button in the header. Now we configure the headers here in our app.js file. Alternatively, we could configure them by calling set options inside of our screen components as taught in the navigation module in this course. But here, to keep things straightforward, I will add this plus button in app.js. And there, I want to add it on the bottom tabs navigator in the screen options there. Because no matter if you are on the recent expenses or on the all expenses screen, you should have a plus button in the top right corner that allows you to open this Manage Expense screen. I don't need that in the header of the Manage Expense screen itself, because of course you should not be able to open that screen on which you already are from inside that screen. That's why the bottom tabs navigator is the right place. So here in the screen options, we can add the header right option to control what should be added in the top right corner of the header. Now here we should pass in or provide a component function in the end, so a function that returns some JSX code that will be rendered in that top right corner. And in this case, I want to render a button in that corner. To be precise, an icon button, a pressable icon. That's my goal here. Therefore, what I'll do is I will actually go to components and add a new folder, which I name UI for user interface, in which I want to store some general user interface elements like buttons. And it's in this components UI folder where I will add an icon button JS file. And in there, we can then create an icon button component function and export that component function, of course, to make it available outside of this file. And here in this icon button component function, I want to return a pressable component imported from React Native, which then wraps the icon that should be part of that button. I will actually wrap that icon into a view, which also must be imported for styling reasons. And then for the icon, I will again use Ionicons. So again, I will import this from Expo Vector Icons as we did it before. Import Ionicons. and render my Ionicons component, which will render the actual icon inside of that view, which is inside of this pressable wrapper. Now, on this icon, the name defines which icon should be used, and this should be settable from outside this component, so that we can use this icon button in different parts of this application and use that same component with different actual icons. Therefore, we should accept some props here, and I will accept an icon prop here, which is then forwarded or used as a value for the name prop of Ionicons, so that we can set the actual icon that should be used from outside this component. Now, I also want to get size and color from outside so that all these values on the icon are also set from the place where the icon is used, so where the icon button is used. Last but not least, I also want to get an onPress prop, which I forward or use as a value on the onPress prop of Pressable, so that the function that should be triggered upon a press on this icon can also be defined in the place where this icon button will be used, so that this is a highly configurable custom component. Now we just need to add a bunch of styles here with the style sheet, of course, which is imported from React Native, so that we can provide some styling for this icon button. And here it's totally up to you how this should be styled, but I will add a button container style object here in the style sheet, and that will be added to this view here later then. And the goal here simply is to give this, let's say, border radius of 24 and a padding of 6 pixels in all directions and a margin of 8 pixels in all directions. I will also add another style here, the pressed style, which should be applied when this icon is pressed, and there I then want to set the opacity to 0.75. Now we can add those styles to the appropriate JSX elements, and for example, on that view, we will set our button container style, and then on Pressable, we also set style, and we set this to a function which receives an object which contains a pressed property, which can be used to assign a style dynamically based on the pressed state of this component. So if it's being pressed, the style will be applied. If it's not pressed, it won't be applied. And to achieve this, we can check the value of pressed. It's a Boolean, so true or false. And if it's true, then we will add the pressed style. If it's false, nothing will happen. Now that's my icon button, and this icon button can now be used in app.js in our header right component function here. In this function here, I want to return my icon button, and again I will use the short form of the arrow function here. So this icon button on which we just worked, which therefore is imported from components UI icon button. And on this icon button, I now want to set the icon, which in this case is the add icon, one of the supported icon values when using Ionicons. And of course, we should also set the size and the color. Now I will hard code the size to 24 pixels. You can of course play around with that value to make sure that it looks good. And regarding the color, I'd like to get a color that is defined by React Navigation, because it should be a color that looks good on the background color of the header. For that, we defined this header tint color, and indeed, React Navigation exposes this header tint color to us inside of this component function here via some props that we receive here. To be precise, we will get a tint color prop here, which is the tint color that should be applied to an element returned by header right. And it's therefore this tint color which I set as a color on this icon. Now last but not least, we can add the onPress prop to decide what should happen when this button is pressed. And we will work on this in a couple of minutes, but we can already add it. And that's now the first step. Now actually for the moment I'll add an empty function here to avoid that we're getting an error. And with that, we should see a plus here. Now, actually on iOS it's a bit cut off because of the margin I have around my icon here. And therefore what I'll do is actually I'll add a margin horizontal of 8 and a margin vertical of just 2, so that we have less margin around the icon to the top and bottom and more margin around it to the left and right. And with that, it also looks good on iOS. We can tap it, we got a little tap effect, but of course at the moment nothing happens. But this is step number 1. Before we now work on the actual logic, I also want to make my expense items tappable. And for that, we actually already wrapped them with pressable, so we're almost there already. We just need to add the onPress prop here, of course, and then add a function that should be triggered when that item is pressed. And for this here, I'll add a function named expense press handler, and I will point at that function here. For the moment, nothing happens here, but later this will be executed, and then inside this function, we will make sure that we navigate to this manage expense screen. Now, what I also want to do here in expense item is I want to add a little bit of feedback when we tap one of these items. And for this, I again want to change the opacity. Therefore, I'll add another style here in the style sheet, a pressed style, and simply set the opacity to, let's say, 0.75. And now, just as before, this style should be applied to pressable if this item is being pressed. Therefore, we can add the style prop here and then receive a function where we pull out the pressed value. And if this is being pressed, then we want to add styles.pressed. Now, by the way, on Android, you could, of course, also add this Android ripple prop, as we did it earlier in the course, to add this ripple effect. But I'm fine with this opacity effect on both platforms here, but definitely feel free to experiment with that ripple effect as well. Now, with that, we also got a little bit of feedback when we tap those items here. So that's great. Now it's time to work on the actual logic. So let's now work on the logic. What should happen when we tap those items? Well, in that case, I want to open this manage expense screen. We want to navigate to that screen. And therefore, for example, here in expense item, in the expense press handler, we want to call the navigate method that is provided by React Navigation. Now, earlier in the course, you learned that you can use the navigation prop, which you receive automatically in all your screen components, to call methods like the navigate method. But expense item is not a screen component. This component is not loaded as a standalone screen. Instead, it's used inside of some other screen. But therefore, this component actually doesn't receive the navigation prop provided by the React Navigation package. To still get hold of this navigation object with its navigate method, we can use a hook though. This was also covered in the navigation course section. We can import it from @react-navigation/native, and from there we can import the use navigation hook. This hook can now be executed here in this component function, in the expense item component function. And this will give us a navigation object, which then has this navigate method, which we can use to navigate to a different screen. So with this navigation object provided by this hook, inside of the expense press handler function, we can call navigation.navigate and then navigate to the screen we want to go to. And in our case, that is, of course, this manage expense screen. So we use the name, the identifier of that screen, and then in the expense item component, we use that as a first value, a first argument that we pass to navigate. And with that, if we save everything, we should be able to tap an item and indeed navigate to that screen. Now, as you see, the styling of that screen is off. We have the wrong colors, but the navigation works. Now, before we work on the appearance and the style, let's make sure we can also open that screen if we click this plus here. To achieve this, we need to go to app.js and then connect our header right icon button here with this navigation action. Now, how can we achieve this? Well, as so often, you will have various options. We could use the use navigation hook inside of this component function here as well. But actually, we can also utilize the fact that screen options can be used slightly different than we're currently using it. At the moment, we're passing an object to screen options, and very often that is what you will do, but you can actually also pass a function to screen options, and then just return an object, here wrapped in parentheses to make sure the syntax is not confused with the function body. Instead, this is an object returned in this short form of the overall arrow function. Now, if we use this function form, we return the configuration object, but we also get a couple of parameters passed into this function automatically by React Navigation. And we can use object destructuring to get hold of the different properties of that object that is passed into this function by React Navigation. And for example, we get the navigation object here. So this function here, which we pass to screen options, will be executed by React Navigation. It expects to get back the configuration object, but it will give us an object as a parameter, and that object, which we receive automatically, will have a navigation property, which is that navigation object that we also get when using the use navigation hook, for example. So that's how we can get hold of this object here in the screen options. And then, of course, in header right, which is inside of that screen options function, in this onPress function here, we can also use this navigation object and navigate to manage expense there as well. And that's one way of making sure that we can also click this add button in our header to open this extra screen. With this all saved, now we can also click this plus button to open the screen. And that's therefore another important step forward. Now let's work on the styling and the appearance, and then let's make sure that we open the same screen in different modes depending on whether we clicked the plus or an existing item. Because of course, if we click the plus, we want to add a new expense. If we click an existing item, we want to edit that expense. And we want to reflect those different modes on that screen. So these are the things we will work on next. So let's dive into configuring this extra screen. And before we work on those different modes which I mentioned, let's work on the general styling. Now for this, we want to set some header colors and so on. And we did set this here on the bottom tabs navigator already. But now we have to target this other navigator because now we're talking about this screen, which is part of the different navigator. Now for that, we could add options here to this screen or some general screen options to the navigator, though it won't matter too much because for this screen, we're hiding the header anyways, and then we only have one other screen left. Still, I'll use screen options so that if we ever would add more screens, we had some default settings set up. And then here we can again set the header style, set this to an object where we have a background color, and this color could then be set to globalstyles.colors primary 500 for the same purple background as we have it in the other navigator. And we can add a header tint color and set this to white. And with this alone, we already get this nicer header. Now we also might want to change the title. And for this, I now go to these screen specific options here by adding the options prop here and setting this to an object where we can set the title to manage expense. Though actually I don't want to do that because I mentioned those two modes that were either adding an expense or editing an expense, and I'd like to reflect this in the title. So we will have to set this dynamically from inside the screen component. We'll do this in a second, but before we do that, there is one other option that I do want to set, and that's the presentation option. We haven't used this option before, but this allows us to control how this screen will be loaded. And I will set this to modal to change the presentation, especially on iOS. On Android, it won't change too much, but on iOS, this will now open this screen differently. If we set this to modal, you will notice, if I reload this all here, that if we click this plus here, this modal pops up. We can then swipe down to close it, so drag it down to close it, but now we got this modal, which I like quite a bit. On Android, it actually doesn't look too different, but it's technically also a modal there. And that's of course totally up to you if you want this effect or not, but here, that's the effect I will go with. So with that, we got some general configuration options for this screen. Now, as a next step, I want to make sure that we also have these different modes before we then start adding some content to that screen. So let's now work on those modes that we can enter inside of Manage Expense. Now, when I say modes, I simply mean the fact that we can either be adding a new expense if we click this plus here, or editing an existing expense if we click on an existing expense. We open the same screen in both cases, but I actually want to do different things on the screen. Later in the next course section, when we add some real user input elements, I want to either have some pre-filled input elements versus empty elements. For the moment, I want to change the title. So therefore here in Manage Expense, we need a way of finding out why this screen was opened. Is it to edit or to add? And we can utilize one important piece of information which we need to pass to this screen if we are editing anyways. And that's the ID of the expense. If we tap an expense, so here an expense item, and we then navigate to Manage Expense, we will need to forward some information to this screen anyways. We will need to forward the ID of the expense that we want to edit because we need that inside of the screen then to load the data, to know which expense to delete, and so on. Therefore here in expense item, I'll add a second parameter value, a second argument to the navigate method, and pass my expense ID in this object, which is my second parameter value. And for this, I expect to get the ID of the expense for which this item was rendered as a prop. So with that, we set some route parameters that are provided to this to be loaded screen. And we only do this here, not in app.js for this plus icon, because there we're creating a new expense, therefore we have no ID of some existing expense that should be forwarded to that screen. Therefore, in Manage Expense, we can now extract that parameter, and we know that if we have an ID, an expense ID, that we are editing, and that if we have no expense ID, we're adding. Therefore, here we can use this route prop, which we get automatically, since this is a component that's loaded as a screen. This route prop is provided by React Navigation, as you learned. And we can use this route prop to extract the ID, the parameter. So for that, we can get our edited expense ID by accessing route.params.expense_id. And it's expense ID written like this because that's the naming I chose in expense item for configuring this parameter. If you chose a different value here, you have to use a different value here. Now it is possible that we load this screen without any params. In that case, params would be undefined, and trying to access a property like this would cause an error. We can use this conditional operator that's built into modern JavaScript to check if params is undefined, in which case we don't drill into it. So this code then is not executed, and this overall instead returns undefined. If params happens to be defined, if it is an object, we do drill into it and we do get that expense ID value. So that is a safe way of drilling into an object which might be undefined. Therefore, we know that if edited expense ID is not undefined, we are editing because we have an ID. And if it is undefined, we failed to retrieve an ID, which means we are adding. Therefore, we can translate this into another helper constant, which I'll name isEditing. And here I simply convert edited expense ID into a Boolean by adding 2 exclamation marks in front of it. That's a common JavaScript trick to convert a value into a Boolean, because with that we convert a falsy value into false and a truthy value into true. So therefore now we have true if we are editing and false otherwise. Now that information can be used to, for example, set the title. Because I want to set the title in the header based on whether we're adding or editing. Now we also learned how we can update the options of a screen from inside that screen. We can do that with help of the navigation prop, which we also get here, since this is a screen component. And on this prop, we can call the setOptions method, which takes an options object, which allows us to set values like a title. So here we can then, for example, set the title to, and then check whether we're editing, if is editing, and if this is true, using a ternary expression, we say edit expense. If this is false, so in the else case, we say add expense. So this is using a ternary expression to set the title dynamically. As you learned in the earlier sections though, you shouldn't call setOptions like this directly in the component function. Instead, you should wrap it with useEffect, or to avoid that it's flickering initially, with useLayoutEffect, which is a hook imported from React. UseLayoutEffect takes a function that should be executed and an array of dependencies that controls when this function should be re-executed. And we pass our setOptions code into this function. And then regarding those dependencies, our dependencies are the navigation prop and the isEditingHelper variable or constant. If those change, we would have to re-render the title, but in this app, this won't change dynamically. Still, we should add those dependencies since this is a good practice. So now with that, we can reflect the different modes. If I save everything now, we should be able to actually open this to add a new expense and see add expense in the title. And alternatively, if I click an existing item, we see edit expense. So this is working the way it should. And that's another major step forward. As a next step, I want to add some content to this screen, even though it won't be the final content because we'll add that in the next course section. But still, we can at least get started. Okay, so let's now continue on this Manage Expense screen and start adding some logic to it. As mentioned multiple times, we will add the actual user input elements, the text inputs where users can enter amounts and descriptions, in the next section. But I want to add some dummy buttons already that allow us to close this modal if we open it, so that we don't have to drag it down, but that we get a button here. I also want to add a button that would allow us to delete items, and I want to add a button that would allow us to confirm a new item even though we don't have any input elements yet. But we can still add some dummy data for the moment. Therefore, here in Manage Expense screen, we can start by adding a view, which of course, as always, is imported from React Native. I don't need the text component anymore, but in that view, I now want to have 3 buttons. One button for closing the modal without doing anything, one button for closing it whilst adding a new element, and then one button for deleting an expense in case we did open an expense in editing mode. Now I will actually start with that last button, because for this I want to use the icon button which I already have. Here I want to render this button conditionally and check if we are editing, and if this is the case, I want to display my icon button, which of course must be imported. And I then want to set the icon to trash, which is an Ionican that renders a trash bin. I want to set the color to one of my global styles colors. For this, we of course need to import global styles, and since it didn't add it automatically, I did add it now. So we import global styles from this styles constants folder. And then I want to access the error 500 color there. And I want to set a size of, let's say, 24 pixels again, or maybe 36 to mix things up. Let's see how that looks. And then add the onPress prop to define which function should be triggered when that button is clicked. And then here we can, of course, add a function, the delete expense handler function, for example, and then point at that function when that button is clicked, like this. For the moment, this function doesn't do anything, but we can fill it with more life later. With this, if we save this all, if we tap one of our expenses, we have this icon here, which we can tap, but which doesn't do anything. Of course, that's not really the layout I want to have. I also want to have a background color here. So therefore, what I'll do is I will wrap this icon button into a view. So opening and closing view around the icon button like this. And then we can add some styles as we did it many times before by using style sheet, which is imported from React Native, and calling create on it. And then here in this style sheet, I want to define some styles for my delete container. So for the view that wraps my delete icon, and also actually for the overall container, the overall screen container, so to say. In the overall container, I want to set flex 1 to take up all the space we can get, and add a padding of 24 so that we have some spacing in all directions, and set the background color of this screen by setting it to global styles.colors, and then I will choose the darkest purple shade, which is primary 800 in my case. And for the delete container, I want to add a little bit of margin to the top, let's say 16, and then some padding to the top here also of 8. And I'm adding this extra padding because I also want to add a border to the top with a width of 2, and then a border top color of global styles colors primary 200. So a pretty light purple. And then I want to align my items in the center here along the cross axis, which, since this has flex direction column as a default, will be left to right. So we center this horizontally. Now we can assign these styles, and the outer view receives the container style. The inner view here receives the delete container style. Styles.delete container. With that out of the way, with everything saved, this now looks like this, which I think is a little bit nicer. Now I have this bar here because above this bar, I would like to have my buttons for confirming changes to an expense or adding a new expense. Here we don't have a trash icon because I'm in add mode instead of editing mode, and therefore this is not rendered conditionally. But either way, above that, I want to have a button for confirming and for canceling. And we have to build those buttons first because I want to use custom buttons. Therefore, that is what we will do next. So let's add some custom buttons. We did this multiple times already. Here I will do it again. In the UI folder, in the components folder, I will add a function button, a component function button in a button.js file. And in this button, we will create our own custom button. As always, you can build your own button with your layout and your styles. Here for me, I will simply return a view, which is imported from React Native, that is wrapped around Pressable, that is imported from React Native, which is wrapped around another inner view, all because of styling and layout reasons, which is then wrapped around some text, which is also imported from React Native. Now the text should have a caption that is received from outside through the children prop, so this special children prop, which holds the content that is set between the opening and closing tags of our custom component. And Pressable should have the onPress prop and trigger a function that's also set from outside through the onPress prop that we receive here on the custom component. So I set onPress, which we receive, as a value for onPress on the built-in Pressable component. Next, we can start adding some styles here. So I will add my good old style sheet object here from React Native, create my style sheet, and then in there, as always, there are plenty of styles you can set and configure. I will add a general button style here, where I will give this a border radius of, let's say, 4 for some rounded corners, a padding in all direction of 8, then also a background color. And here I want to use global styles from my styles file, which must be imported. And I will pick the primary 500 color here. But I then, as a special feature, also want to provide an alternative style for this button. You should be able to set a mode property on the button. And if mode is set to flat, I want to render a button without a background color. So where then we just have some text, almost like a link. For this, I'll add a flat style object where background color is set to transparent to get rid of the background color. And we will also style the button text differently on whether we are in flat mode or not. So we have a general button text style, which will be applied if we're not in flat mode. And here I want to set the text color to white, so that we have a nice contrast to this background color here. And I will add text align center here. But in addition, I then also want to add a flat text style object here. And in this flat text style object, the text color should instead be set to color global styles .colors.primary 200, a light purple color. Last but not least, I want to have some feedback if we press this button. And for this, I'm going to set up a pressed style again, where I will set the opacity to 0.75, and where I will actually also change the background color to global styles.colors.primary 100, which will be useful in case we are in that flat mode. I then also want to add a border radius of 4, so that we have this border radius even if we are applying this press style in flat mode. Now with all these style objects set up, we can assign them, and this inner view will receive this style prop, where I then apply multiple styles. And the first style is this button style, but then in addition, I want to check this mode prop, which I'm receiving here. And I want to check if this is equal to flat, if it has a value of flat, in which case I will also add the flat style. So the button styles are always applied, but the flat styles are applied in addition if that mode is set. And this flat style will override the background color that is set by button if we are in this flat mode. Now for the text, I will do pretty much the same. I will add style, set this to an array, and always apply my button text. But then I check if mode is equal to flat, and if that's the case, I will also add my flat text here. Now on this outer view, I also want to allow some extra customization from other components that might be using this button. So I will accept a style prop here, which I do add to this outer view. This doesn't have to be set, but if you want to apply some extra custom styling to the button, you could apply it to this outer view with help of that style prop. I'm adding this to show you how you could build a reusable and still pretty configurable button. You could also add more props to make the individual nested elements configurable as well, but this button here will do it for our purposes here. And with this button added, we can now go back to Manage Expense and add our buttons here. Here I want to add another view, and in this view I will add my button, therefore imported of course from Components UI button. And this first button here will say cancel, and here I want to set the mode to flat to render this in this flat mode, so without a background color. I also add on press here, this on press prop, and I will add a function cancel handler, which should be triggered if this button is pressed. So here I then point at cancel handler. Then in addition, right next to this button, I'll add another button where I say confirm, or actually I want to say add if we are in add mode and update if we are in editing mode. And therefore we can check if isEditing is true. And if it is, I will say update. Otherwise, I will say add. This button is not in flat mode, so I won't add this prop here, but I will add the onPress prop and add a function for confirming this basically, which I'll name confirm handler, and this is the function at which I want to point here when this button is pressed. So now we have these two extra buttons. If we save this, we got the buttons here, it looks okay, but I would like to have these buttons sit next to each other. And to achieve this, we can add some styling to this view that wraps the buttons. Here, we can add an extra buttons style object, or a button container style object, whatever you want, the name is up to you, and set the flex direction to row here. And set justify content to center to make sure they are centered, and then also align items to center to make sure they are also centered vertically. This buttons style object can now be applied to this view. So here we point at styles buttons, and with that they sit next to each other. Now I'd like to control the margin between them, the spacing between them, and the width each button takes. And for this, I will use the fact that I made those buttons configurable by accepting the style prop inside of the button component. This now allows us to set some dedicated styles here in Manage Expense, a button style to be precise, where I set a width or a min width, let's say, of 120 pixels and a margin horizontal of 8 pixels. And now this button style can be applied to these two buttons. So here on both buttons, I will set the style prop, which I'm accepting in there, and I will set this to style.button. And this is this extra configurability, which we enabled by accepting this style prop inside of our custom button component. Now with all that, we can save this, and now we have these buttons, and that doesn't look too bad, I'd say. Now what I can see is that we have no feedback when we press the buttons, and therefore we should go back to the button component and of course make sure that on pressable we add the style prop, add this function, which we added many times before already, pull out the pressed property out of this object which we're getting here, and that we then use this to conditionally add the pressed style. With that added, with that done, we can save everything. And now we get some nice feedback when we press those buttons. So therefore, the next step is to add some logic, and we'll start with closing this modal before we then make sure that we can actually add and edit and delete some dummy expenses. So let's start with adding some logic to manage expense. We got these three functions, and at the moment they are all doing nothing. Now the first thing with which I want to start is that all these functions should actually close this modal. No matter if we're canceling, updating, so confirming a change, or deleting, thereafter this screen should be closed. We want to do some additional things if we confirm or delete, but closing the modal is always something we want to do. And closing is pretty simple. We can start in the cancel handler. We can again use this navigation prop, which we are receiving, this prop here. And besides the navigate method, which we already used, this also has a go back method, which is basically the equivalent to pressing a back button if there is one. Go back in the context of this screen means that we go back to the screen that opened that screen, which means that we close this screen, we close the modal. So in all three functions, we want to execute go back in the end, like this. Therefore, that's the first thing we want to do. And if we do this, we can click cancel to close this, we can click add or update to close this, and we can click delete to close this. And it's the same on Android. There we also have a back button which we could use. And of course that is fine, but we can also use cancel, update, or delete. or in case of adding, of course, also add, since this is the same button as updating. So that's how we can close the modal, and that's the first important step. The next step now is that in case that we did click add or update, we want to add or update a new or an existing expense, and if we clicked the delete button, we want to delete an expense. For this, however, we first of all need to shift away from the dummy data that's managed in expenses output to still some dummy data for the moment, but some dummy data that is managed in a more central place of the app. A place which we can access from inside the Manage Expense screen, but which we can then also use in all expenses or recent expenses. And if you have such app-wide data, app-wide state, that always screams for React Context or Redux. And you can use either of the two approaches in the end. Here in this section, we will use context, but you did learn how to work with Redux as well, and therefore if you want to use that approach, that of course would also be perfectly fine, and you can use your knowledge you gained earlier in the course to implement this feature with Redux or context. In the next lectures, we will add this app-wide expense management with context, but again, definitely feel free to also practice this with Redux. So how can we manage expenses with the context API that's built into React? Well, for this, I'll first of all create a new store folder in my project folder, and in there I'll add my expenses-context.js file in which I want to manage the context for these expenses. Then in this file, we can create a new context by importing the create context function from React and executing it. And this will be my expenses context. And I'll store it in a constant named such, starting with an uppercase character, since this object will expose a React component to us, which we will use later. I will also export this so that we can import this in other files, which we will need to do in order to access and use this context from inside other components. So that's now the first step. As a second step, I'll pass an initial value to create context, which is not really used as an initial value here, but which will help us with auto-completion later. Here I basically define the shape of my context object, my context data. And here it's a pretty simple shape. I want to have an expenses array, and then a couple of functions or methods for updating this array. An add expense function, which we'll configure soon, a delete expense function, which we will configure soon, and an update expense function, which we will also configure soon. Now, in case of adding an expense, I expect to get an object as an argument, which should have a description, an amount, and a date field. Here I'm using object destructuring to get properties out of this incoming object. I'm not using them in here though, because this is just a dummy definition for better auto-completion later. But that is the kind of data grouped together into an object which I expect to get as a parameter value in this add expense function, and will implement the actual function later. For delete expense, I expect to get the ID of the expense that should be deleted. And we also won't do anything here. Again, the actual implementation will follow. And if we update, I want the combination of these two functions. I want the ID of the expense that should be updated, and then the data with which it should be updated. So I expect to get two parameter values, the ID and an object with these properties. Now with that defined, we can add a function which I like to call expenses context provider. And that is the actual provider function which will hold the actual logic later. I will also export this function as a default already, and that will be a React component function. In this function, we return some JSX code therefore, and we return expenses context, so using this object, dot provider. This is wrapped around the content that is wrapped by this component's tags. So I use the children prop here to wrap anything we pass into this component with this provider component here. And then inside of this expenses context provider function, we can add the actual context logic, so the state management logic. For this, we can use state to register some state, but to mix things up, I will use another hook, which you probably know, which you should know, and that's the use reducer hook provided by React. It's another hook built into React, nothing Expo or React Native specific, which is also used for state management, but which can be very useful if you have more complex state management with different scenarios, which we kind of do here. Now, how does use reducer work? Well, in the end, you have to define another function outside of this component function here, which is the so-called reducer function for this hook. Therefore, I will name it expenses reducer. And this is a regular JavaScript function which will receive the current state and an action object automatically. Both values will be provided by React because we will connect this function to this hook in a couple of minutes. Now, inside of this reducer function, we can then check the type of action that we received. And it will be us who dispatch an action later. So we will be able to set different action types. So here we can then switch on the action type. Switch, of course, is a standard JavaScript control flow statement. You could use if statements alternatively. But here I use switch, and we can define different cases like add and update and delete, and also a default case here like this. In the default case, I want to return the existing state without changes. In the other cases, we will add more logic in a second. But how are these cases triggered now? Well, for this, before we add any logic here, let's connect the expenses reducer function with use reducer. This connection is established by simply passing expenses reducer as a first argument to use reducer. Then thereafter, use reducer, like use state, returns an array with exactly two elements. The first element is our expenses state, so the state that will be managed by this reducer, now made available in this component function. And the second element here will be a dispatch function, which we can execute to dispatch a new action to the reducer function, which is then able to manipulate the state, which we then get as a new state in this component function, which will be re-evaluated if the state changes automatically, all thanks to React and this hook. Now, to show you how dispatch could be used, let's add a function inside of this component function that could be called addExpense. We will need this function later because this is the function that should be triggered when a user clicks add here in the modal. Now, in addExpense, I then expect to get my expense data, which will have the shape defined up here. So an object with description, amount, and date. And what we can then do in here in addExpense is we can call dispatch. So use this dispatch function provided by use reducer. To dispatch, you can pass an action. So you can pass a value to dispatch, which will be made available by React inside of the reducer function as the second parameter. So this action is the value you dispatch here. Now you can dispatch anything, a number, a string. Here I will dispatch an object with a type property of add. But that's just my choice. I could have also named this kind or mode or whatever. But here I'll name it type, also because I'm already checking for type here. If I named this kind here, I would have to check for kind here in my reducer function. But I will go for type. Because this then allows me to identify the kind, the type of action that I want to handle now in the reducer function. So the type is add here, and I can then set a payload. This property name is also up to you though. could also be named data, whatever you want, but payload is kind of common. And I will forward my expense data, which is received here in add expense, to payload. And as a side note, expense data should not be pulled out with object destructuring here. Instead, the parameter itself should be named expense data. So we then forward the incoming expense data to our reducer function by dispatching this action. And we can then dispatch a different action if we, for example, delete an expense. If we delete an expense, we get the ID of that expense here, and then we also call dispatch, and we dispatch an object still, but here the type then is delete, for example. It should be one of the identifiers you have here, so that we can execute different code for different actions later. And here it could therefore be type delete, and the payload could then be the ID itself. And last but not least, we can add another function, update expense, where we get the ID and the expense data. And here we therefore also dispatch an object where the type is update, or whatever you defined up here, as mentioned before, and where the payload then is an object, for example, which has an ID property, which is the ID we're getting here, and the data property, which is the expense data we're getting here. So now I'm dispatching different actions, and these different actions will lead to different state changes inside of expenses reducer. Because the job of the reducer function is to always return a new state value. Either the existing state if we have no action that we know in the default case, or if we make it into one of these cases, a state that is manipulated as defined by us. And for example here, if we're in the add case, if the add action was dispatched, we could return a new state, which is an array, because for expenses it makes sense that our state is an array. A new array where I copy in my existing state, which also was an array, so where I spread my existing array items into this new array, and in front of the existing items, I could then add a new object for my new expense that is being added, where I spread in my action payload. So that data, the expense data that I received here. Expense data is an object, that's an expectation I have, and since I'm the developer here, I can make sure that it works like this. And this object data is spread into a new object here. And I'm using a new object and a new array here to update the state in an immutable way. So to make sure that we don't mutate original data in memory, but we create a brand new state snapshot, which then will be used by React to update the old state snapshot. Now when adding an expense, I also want to generate an ID though. And here I will generate a pseudo unique ID, which is good enough for those demo purposes, by using the current date and converting this to a string and concatenating this with a random number, which is also converted to a string. This should be random enough and unique enough, and we can then add this ID field here with this ID value to this object, to this expense object that we are adding to this array. But there's one important question. How can we assume that state will be an array? Well, it's our reducer, so it's up to us what we return, but for the first time this component renders, when we have no expenses yet, for example, when the app just started up, we can also pass a second value to use reducer where we set our initial values. And here we could use the initial expenses, the dummy expenses, which we defined before in expenses output.js. We could grab our dummy expenses and cut them from that file. We will update the file down here later where we used dummy expenses, but cut the dummy expenses for now. And in expenses context, we can add them, maybe here at the very top. Here I will add my dummy expenses, my dummy data, and I will set this as an initial value by passing my dummy expenses as a second parameter value to use reducer. And that second parameter value will be used as an initial state value before the reducer executed the first time. And then when it executes the next time, because a action was dispatched, we get the existing state, which is that array full of dummy expenses in this case, and we then know therefore that in this case it will be an array of which we can pull out the existing elements and merge them into a new array here. So that's how use reducer and this reducer function here generally works. Now, of course, we cannot just add expenses, we can also update expenses if we are editing an existing expense. For this, we first of all need to find the expense which we want to update by ID. For this, I'll get my updatable item or updatable expense index by using my state, which we know will be an array, and calling findIndex on it, which is a built-in method in JavaScript, which we can use to find an element in an array. This takes a function which will be executed on every element in the array, and we will get every element, every expense, as an argument automatically. And we have to return true if it's the element we were looking for, and false otherwise. Here I want to return true if the ID of the expense we're currently looking at in this array of expenses is equal to my action.payload.id. I know that I can look into action payload ID because I know that in the update case, I will have dispatched an action with a payload that is an object that has an ID. Therefore, in the update case, we can dive into action payload ID and make this comparison. This gives us the index of the item that should be updated. And I'm getting the index instead of the item itself to again update everything immutably thereafter. Because now we can get the updatable expense itself by using state and then access this updatable expense index. We can then create our updated item here by generating a new item to update it in an immutable way, where we spread all our updatable expense properties, so of this object that we got from the original array, and where we then also merge in our action payload data properties, so all the updated properties for the expense. Because the data we're setting here is the expense data we received here as a second argument in update expense. And that should be an object that has this shape in the end, description amount date. So we merge the updated description amount and date into this object, and we will therefore override the existing values for description amount and date. We will keep the original ID though. Now that's the updated item. Next, we can get the updated expenses, so the overall array that should be updated, and construct a new array here, again, to keep everything immutable, and spread in our existing array by using the spread operator. And then we can use these updated expenses, access the updatable expense index, which we got here in line 73. And then we set this equal, and therefore we overwrite the item at this index equal to updated item. By the way, here where I spread update expense, that should be spreading updatable expense. That was a typo. So here in line 77, we should spread in updatable expense. But then we can overwrite the element in the index with the updated item. And therefore then, thereafter, we can return this updated expenses array. So now that's a new array based on the old array with one item updated. Now deleting is simpler thereafter. There we just have to return state filter and basically filter out the item that should be deleted. For this, we can pass in this arrow function, which gets the expense automatically. And we want to return true for all the items where the ID is not equal to action payload, because if it is equal, that's the item we want to delete, and in that case, we want to return false to drop that item. So that's the delete case. And with that, the reducer is complete. That logic should do the trick. It's hopefully clear how this works. Make sure you have the same code, the same cases, and you dispatch the same actions for this to work properly. And with all of that, we should be able to then start using this context in the different parts of this application to achieve our goal of really managing our expenses. Now for this, we first of all have to finish work in this context file, and then we'll start consuming it in the different parts of this app in the next lectures. So let's now finish our work related to this context here. In the expense context provider component here, we added all these functions which dispatch our actions. Now we also need to construct a value object here, which bundles all our data and these functions together to expose them to all the interested components through that provider component down there. For this, in this value object, I'll add an expenses key and point at my expenses state, which is returned by useReducer and which is recreated whenever an action is dispatched. And I then add the addExpense function and point at the addExpense function here. So the right side of the colon is referring to the different functions we defined here. And therefore I also add a deleteExpense function here and point at deleteExpense, and add an updateExpense method and point at updateExpense. And now that value is made available to all interested components by setting the value prop on this context provider component down there and setting this equal to this value. Now this custom provider component can be wrapped around all the components that are interested in this context. And in this case, I need the context in different parts of the app. Therefore, indeed, I will go to app.js and in there wrap my overall navigation container with my custom context. So here, I will wrap my expenses context provider around my navigation container in app.js. And for this, expenses context provider must be imported in this file. So here, you should make sure that you add this import. Now with that, I'm getting an error here that I can't find the variable dummy expenses. And this is coming from expenses output where I'm using that value here. Now we no longer have the dummy expenses constant available in this file. And therefore, instead, I will fall back to using the expenses prop value here, which should be passed in from inside the component that is using the expenses output component. And in our case, that component is being used in two places, all expenses and recent expenses. So therefore, as a next step, we can continue working directly in those components and make sure that we tap into our context here and that we get our expenses from context in those components where we need our expenses. For this, let's start in all expenses, and there we can use the useContext hook, which is made available by React, to tap into one of our contexts, and in this case that's the expenses context, which must be imported and which should be passed as a value to useContext. And make sure it's the expenses context, not the expenses context provider, which we also defined in this file, but instead really the context itself, this object here in the end. That is what we consume here with useContext in all expenses, and this gives us our expenses context, which we can now use in there. Now, how do we want to use it? Well, on expenses output, we want to set this expenses prop, which is required by that component. So this prop, which we forward to expenses summary and expenses list. And we want to set this equal to all the expenses that are managed in our context. So here I'll set this equal to expenses context dot expenses, which is our array of expenses. Now in recent expenses, it's pretty similar, but not quite the same. There we also want to use context and tap into the expenses context and import everything, and then store this in a constant or variable, like this. But since these are our recent expenses, since this component, this screen, should deal with displaying our recent expenses, this is not enough. We don't want to just forward all expenses here. Instead, we only want to forward our recent expenses. So therefore, we have to derive our recent expenses here. And we can do this by using expenses context.expenses and filtering those expenses. And we want to filter such that we only keep expenses that occurred in the last 7 days. Now, How can we do that? Well, first of all, we pass our filtering function, which receives those individual expenses as an argument. And then in there, I want to get today with new date. This is a way of getting today's date in JavaScript. And I want to find all the expenses that occurred in the last 7 days seen from today. For this, I'll add another utility function to date.js in the util folder. I will export another function in there, which I call getDate minus days. And I expect to get a date and the number of days as input here, so as parameters, and that should be a function. And we can then return the result of calling new date. So we construct a new date here, and we construct it by getting the full year of the date we receive as a first parameter, getting the month, and getting the date, so the day, minus the number of days here. With this helper function, we can get a date that is X number of days, so days number of days in the past. We can now use this in recent expenses inside of our filter method here, in this function which we passed to filter, to be precise, to get the date 7 days ago, if you want to call it like this, by calling getDate minus days. Of course, we have to import it from the util folder for that, and passing today and 7 as arguments. So this gives us the date 7 days ago. We want to return true if an expense has its date in that range of dates. For this, we can simply return the result of comparing expense date to date 7 days ago. If the date of an expense is greater than that, it means that it's younger than that, it's more recent than that. It is somewhere within those last 7 days. If it's not greater than that, that means that the expense date would be older than 7 days. So this will give us our recent expenses here, and now it's the recent expenses that are set as a value on the expenses prop on expenses output. So we can forward recent expenses here. Now with that, if we save that and reload everything, this should work again. And now we see a couple of recent expenses, which are all having dates that occurred in the last 7 days. We have duplicate expenses here because I duplicated some dummy expenses earlier. If I click on all expenses, we see more expenses, including older expenses which did not occur in the last 7 days. So that is working. Now, of course, we want to make sure that clicking the delete button does actually delete an expense, or that clicking add or update actually does add or update an expense. And that's therefore what we will do next. So to make the delete button and the update and add buttons work, we have to go to manage expense, because that is where we have those buttons and the functions that are triggered upon those button tabs. Now let's start with delete expense handler. There I want to trigger that delete expense function that I defined in my context. I want to trigger this function. To trigger it, we need to get access to context. That means that in manage expense, we can again use the context hook provided by React and therefore import it from React. And we pass our expenses context to this hook to tap into this context. Then we can store this in a constant or variable. And we can then use this context, for example, here in the delete expense handler. In there, on expenses context, we can call delete expense. Maybe do that before going back, though it doesn't matter here because this runs synchronously anyways. But still, I'll swap this. But most importantly, to delete expense, we should pass the ID of the expense that should be deleted. Thankfully, we have that available here. It's this edited expense ID. So we pass this as a value to delete expense. With that, if we save this, if I click on a book, on this first instance of a book here, and I click delete, it's gone thereafter. I can also delete another book and delete all the books. We might want to add some message here in case everything was deleted, but it works. Also note how the total updates here as we delete items. If I delete one book, the total goes down by that amount. If I delete another book, the total goes down by that amount. So this works. Now what about updating or adding? What about these buttons here when we tap those? Well, it's not that different. For that, we have the confirm handler function, which is triggered whenever this button, the update or add button, depending on which mode we are, will be tapped. So this function is executed when this button here is tapped. Therefore, in here, we want to use the expenses context and now either call add or update expense depending on the mode. So actually in confirm handler, we first of all want to check the value in our isEditing constant here. We want to check if we are editing, in which case we want to call expenses context update expense. Else, if we are not editing, then we are adding, then we want to call expense context add expense. Either way thereafter, we want to go back and close the modal. Of course, we need to pass some data to update and add expense. If we are adding an expense, we need to pass the entered description, date, and amount. We will take care about this in the next course section, but for the moment, we have no way of entering values because we will add those inputs in the next section as mentioned. Therefore, what we'll do instead here for the moment is set up some dummy object where the description is always set to test, where the amount is always set to 1999, for example, and where the date is always set to new date, and then some dummy date like 2022, May 19th, something like this. And I will use the same dummy object for updating. Actually, here I will add a couple of exclamation marks to test and change the amount to 29.99 and the date to May 20th. But besides that, it's an object with the same properties. And we also have to provide the ID here. Because in the context, you might recall that in case of updating, the first parameter we receive is actually the ID of the expense that should be updated. So therefore now here, in update expense and manage expense, we pass the ID, to be precise, the edited expense ID as a first value. So now we should also be able to confirm this modal. If we save this now, if I added another book here by clicking on it and click update, you see it was overwritten with test and that test amount. If I add a new expense by clicking add here, we see this expense here as well. It's in the recent expenses here because in my case this is actually in the future and therefore it is of course greater than that date 7 days ago. If you wanted to rule out that you can get dates in the future, typically you would probably not enter expenses in the future, but if you would want to rule that out, you can update your return expression here in this filter function and make sure that you return true if expense date is greater than date 7 days ago and expense date also is smaller or equal than today. Here you also might want to use greater or equal to include that date 7 days ago, depending on how you define 7 days ago. With that, that would be gone from the recent dates, but we would have it here in all expenses. So that is also working now. And of course, we can still delete all those expenses if we want to, update them as I showed you, and add new expenses whenever we want. So therefore, this is looking pretty good. We are, of course, missing those actual inputs, but we will add them soon. For this section, we are almost done, and I just want to make sure that we have some fallback text in case that we have no expenses. And I also want to make sure that the status bar here isn't black, because that's a bit hard to see. So to finish up this course section here, let's work on the status bar and on some fallback text in case that we don't have any expenses. For the fallback text, we can go to expenses output, where we output our summary and our list. And I actually want to keep the summary even if we have no expenses, because I think it is okay to say that we have no expenses here and show that zero sum. But I want to have some text below that that tells us that there are no expenses yet. And therefore, I don't always want to render this list. I only want to render it if we have expenses. Otherwise, I want to render some fallback content. To achieve this, I'll add a new variable, content here, which actually holds a text component, which must be imported from React Native. And in there, I want to output some fallback text, which should be different for the recent expenses and all expenses. Therefore, that fallback text should actually be received as a prop and can then be output here, fallback text. This text also should be styled, and therefore I will add some styling down here, a little info text styling object, which I want to add here. And I want to make it white, so add a color of white. Set the font size to 16 maybe, and text align to center it in the middle horizontally, and add a margin to the top of, margin to the top of 32. This info text style object is then added here, styles.infotext. And now this content should be rendered instead of the list if we have no expenses. Therefore, we can simply check if expenses length, so the length of this expenses array, is greater than 0. And if that is the case, content will be set equal to this expenses list here. And then down here, we output content. So now we either output this text, or if we make it into this if statement, this list of items. And with that, we will now see this text, but for this, we of course also have to set this fallback text here. So in recent expenses, on expenses output, we can add a fallback text of no expenses registered for the last 7 days, something like this. And for all expenses, we can also set a fallback text. And we can set this to a value like no registered expenses found. Something like this. With that, we can see this fallback text here. And on Android, of course, or on iOS, it's the same. I'm just showing it here on Android to mix things up. We also see that on the all expenses screen. So we have the different texts on the different screens. Okay, so that's working. That's the fallback text output conditionally like this. Now we can work on the status bar, and that's super simple. In app.js, I already have this status bar component, which is provided by Expo status bar. And we can set the style to dark here to force it to be black, or relevant for our case, we can set it to light to force it to be white, which looks better in this kind of app here. And with that, this app is finished. We will continue working on it in the next sections, because in the next section, we will add some input elements here with validation and error feedback. And in the section thereafter, we will make sure that all these expenses get stored on a real server instead of in memory, as it's the case at the moment. But for this moment, we are done, and we had a chance of practicing a lot of these core concepts that you'll learn about throughout this course. In this course section, we are going to build up on this practice app we built in the previous course section. Because in this course section, we will work on this screen here where we can add or edit expenses. And in general, in this section, we'll dig a bit deeper into handling user input. We did already fetch and work with user input before in the course for example, in our game app where users were able to enter a number. But in this module, we're going to dig a bit deeper. We'll explore how we can use the text input component and how we can configure it. And we will also dive into input validation and see how we could provide feedback about validation errors directly as part of the user interface and the form that we're building. Last but not least, we will explore how we could split a more complex user interface into multiple components and how we can embrace the components concept when working with text inputs and with user input in general. So, therefore, let's not waste any time, let's dive right in. Now, as mentioned in the previous lecture, we are going to build up on this app that we built in the previous course section. In case you skipped that section, that's no problem. You find my code snapshot attached to this lecture, so you can download it, npm install all the dependencies, and npm start your Expo development process here so that we can all work with the same starting project. Now, in this project, I now want to focus on the manage expense.js file, which holds this manage expense screen component. In that component, we at the moment only display a couple of buttons. And that is, of course, not the final state of this component, because this component should actually allow users to enter values, either when they're adding a new expense or when they're editing an existing expense. We should be able to enter the description, the amount, and the date of an expense, and in this module we're going to add all these things. And speaking of that, we can start right away. How can we add a bunch of input fields that allow users to enter values? Well, here in manage expense.js, we can use the text input component, which we can import from React Native. This text input component is exposed by React Native. We can therefore import it from that library, and we can then use it in our JSX code to display a text input element where users can enter text. However, here, since I will build a form with multiple text input components, and I want to keep this component relatively lean, especially the JSX code of that component, I will add a separate component that will deal with that form, or that will handle that form. And for that, in the components folder, I'll add a new subfolder, manage expense, where I add my expense form.js file, where I want to store the component that will actually hold the form. As always, this is not a must do, but it allows us to keep our manage expense.js file a bit leaner. So here we can add an expense form function in that file, and of course also export that function thereafter to expose this component function to other files. And then in there, we want to return some JSX code that holds our text inputs and our form. Now for that, we could start with a view as a wrapper. This will allow us to wrap all our text inputs with a view, which could be helpful for laying things out and styling things, and which is a great generic container in general. Now inside that view, I then want to have multiple text inputs. One for the description of an expense, one for the amount, and one for the date. However, I don't just want to have the text input elements in here, I also want to have a label for every text input element so that we give the user a hint about the value that should be entered. And therefore, I will actually add yet another component here in the manage expense folder, in the components folder, and that's my input.js file, where I basically want to manage my own custom input component, again to keep this expense form component a bit leaner thereafter. So therefore, we can also create this component, this input component here in the input.js file, and this is also optional. And in here, I want to return another view, which will be a wrapper around the label and the text input that belongs to a label, so that we can later use this custom input component multiple times for different inputs. So in here, my idea is that I have a text component, which will hold the label of an input. So where we say something like description or amount, though that of course should be configurable from outside, and we will take care about this soon. And below that text element here, I want to have my text input component, which is also imported from React Native. This text input component here will then actually fetch the user input. So that's the general structure of an input element as I want to have it here in my form, and we will use this input component multiple times. Now, as mentioned, the label should be configurable, and therefore actually I want to destructure some props here, which I expect to get. And I do expect to get a label prop, for example, so that we can actually set that label text from inside the place where we later use this custom input component. The text input itself also needs some configurability from outside. For example, on text input, we can set the keyboard type, as you learned earlier in the course already. Now, there are a bunch of keyboard types supported here. And as also shown earlier in the course already, if you dive into the official docs about this text input component, you can learn more about its usage there, and you also learn about all its props there, including this key input type prop here. Here it is. And you learn that there are some values that are supported for both or for all platforms. And then you also have platform-specific values like iOS or Android only specific values, which you could also set, but where you might want to use that platform API I showed you earlier in the course to set different values depending on the platform the app is running on. But that's this keyboard type, and we could hard code a value here like number pad, but of course that would mean that whenever we use our custom input component, we would always display a number pad keyboard when a user taps into this text input. This could be right for some apps where we only work with numbers, but here I actually want to make this configurable, and therefore I will accept a type prop here, which I then forward to keyboard type. So the values we later use for type should of course be values that are accepted for keyboard type as well. Now, chances are that we actually want to make a bunch of other default text input props configurable as well. We might want to add max length and make that settable from inside the place where we use input. So we could accept a max length prop as well and forward that to the max length prop of text input. But by doing it like this, we will keep on adding more and more custom props to our custom component just to forward them to the text input component. Therefore, a better approach here is to not do it like this, but to instead take one generic prop like text input config and simply spread that onto our text input. We then expect that text input config will be an object, and the property names used in that object should match the prop names supported by text input, and the values for those properties then are simply values accepted by the props we can set on text input. This allows us to basically merge all the configuration we want to apply to the text input into one object, and in our custom component, we then spread all these properties as props onto this text input. And by doing it like this, we can build our custom component that adds this extra label, and we still maintain the full configurability of text input from outside. And therefore, that is the approach I will use here. Now, with that, we built our custom input component. Now, let's switch back to Expense Form and use it there. So how can we use this custom input component in Expense Form? Well, as we always use custom components. We can simply add our input component here, add an import to it, of course, and then use it in the JSX code like a custom component, as we always do. And we can add 3 custom components here for these 3 inputs that we need. Now, with them added, we can configure them. We can, for example, set the labels. And the first input could be dealing with the amount, so I will give it a label of amount. The second input could be dealing with the date, so I will give it a label of date. And the third input could be dealing with the description of the expense, so I will give it an appropriate label. With that, if we now use the expense form in manage expense, so if we go there and we add our expense form here, our custom component in the manage expense component, so if we add it here in the JSX code like this, and we of course also import it from our expense form file in the manage expense folder in the components folder, if we do all that and we save everything, we should therefore be able to open the screen, and even though it's a bit hard to read because we haven't added any styling yet, we can see our 3 labels here. The text input elements are actually also here, as you can see if you try to click in them, but you can't see them because they have no styling. Still, this is being rendered, and we can therefore of course also work on the styling, but before we do that, I want to finish the configuration of my different inputs, because of course they don't just need a label. Instead, if the first input here is the amount, we also want to set up our text input config here and set this to an object, as you learned, which will then be transformed into props on the text input inside of that custom component. And here we can then set all the prop values that are supported by our text input component by React Native. For example, here on this first text input, which deals with the amount, we could set the keyboard type here to decimal pad. Decimal pad is one of the values that is supported on both platforms, and this will ensure that when a user taps into the keyboard, we open up a keyboard on the device that makes entering decimal numbers easier and makes entering text pretty much impossible. We can also add another property here, another prop value therefore, and that could be the onChangeText property. This will add the onChangeText prop to the underlying text input, and this allows us to point at a function that should be executed whenever a user enters a value here. If we could add such a function here, the amount changed handler, for example, and point at this function here. The amount changed handler. This would allow us to register keystrokes and store them in some state later. Now for the moment, I'll just keep this as an empty function around. We will work on handling user input a little bit later. But that's how we could add props here. Now we also got more inputs that need to be configured though. For example, the date. There, I also want to add my text input config prop here and pass an object to it. Now here, I don't want to set the keyboard type because there is no date specific keyboard type we could use here. Instead, I will keep the default keyboard type, which allows us to enter both text and numbers, but I do want to add the placeholder prop because that is another prop supported by text input, placeholder, which shows a short text which is visible before the user starts entering values. And here I want to give the user a hint about the format I expect to get for the date. Because I want the user to enter the year with 4 characters, then the month separated from the year by a dash, then another dash, and then the day. I expect this kind of input, and therefore that's the placeholder value I will set here to get this extra hint. In addition, I want to make sure that the user can't enter anything longer, so we can add the max length property, because max length is another prop that is supported here, max length, and this restricts the number of characters that can be entered here. And I want to set max length to a number of 10, because we only need 10 characters to enter this state in this format. We have 4 characters for the year, 2 for the month, 2 for the day, and then 1 each for the dashes. Now we also might want to add onChangeText here, but for the moment I'll set this to an empty function and add the actual function for handling input changes later. But that's it for the date input for me here, though of course, feel free to browse through all these props and add more configuration if you want to. Now we also have the description here, and on that description, I also want to add my text input config, and here on the description, I actually want to set a couple of other values, or at least discuss a couple of other config values. Which kind of configuration could we add to this description? We could set the keyboard type, but actually I'm fine with the default because the description should allow all kinds of characters, so opening that default keyboard, which makes entering text very easy, sounds like a good idea. But there is one other key property that I do want to set, and that's the multi-line property. Multi-line is a prop supported on text input, and multi-line does what the name suggests. It allows users to enter multiple lines of text, or to be precise, it makes that a bit easier. On Android, we could then also add number of lines to restrict how many lines can be entered basically. Though I don't want to add that here, but you could add this prop in addition. But it's not just multi-line which I want to add, and which I want to set to true, to turn this into a multi-line text input, but I also want to talk about some auto-correction props here. To be precise, we got auto-capitalize and auto-correct. And these can be very useful, but also very annoying props as well. At least they can be annoying if you don't know them. Because by default, for example, autocorrect is set to true. Now, when having a text input where users enter text, this can be annoying, for example, if you're building an input for entering email addresses. In that case, you don't want to have autocorrection turned on, because we probably all know those text input fields where we have to enter an email address, where it keeps correcting our email address whilst we're entering it. It's super annoying and can lead to a lot of errors. But here for the description here, it actually makes sense to add autocorrection and to ensure that users are corrected and that we have some nice input here. Or at least that is my opinion for this app here. You could turn it off by simply setting autocorrect here to false. The default is true and therefore doesn't need to be set. Here I will comment it out because I want to keep that default, but you could turn it off by setting it to false. Though it's autocorrect with a capital C, that's important. We also have auto-capitalize, which can also be annoying if we're, for example, dealing with email addresses. But here you could control if the input entered by the user should be auto-capitalized. And you actually don't set this to true or false, but instead auto-capitalize wants a string value where you use one of these values to control whether characters should be auto-capitalized, entire words, or just sentences. And sentences, as you can see, is the default. Now here I want to stick to that default and ensure that sentences are auto-capitalized, but you could control this as well by setting the auto-capitalize prop here. And then on this auto-capitalize prop, you, as mentioned, could set this to characters or words or sentences, which is the default, or none if you want to turn it off. But here I'll keep it set to the default of sentences, but you could change it, of course. And that's it for me and the description input for the moment. So actually there is only one piece of configuration I want to add here, but I did want to talk about auto-capitalize and auto-correct as well, because these are also very important props which you should know in order to configure your inputs correctly. And with that, we added a bunch of inputs with some basic configuration. Now, as a next step, let's explore how we can style them so that we can finally also see something here when we open this, or see it a bit better, to be precise. So let's dive into styling these inputs. And for that, we can go to the input component, of course, and add this styles constant where we use the React Native style sheet, which is imported from React Native, to set up our style definitions. Now, there are millions of ways of styling this, of course. Here's just one style suggestion which I will use in this app. And there I want to style the view that wraps the text, so the label and the text input, and I also want to style the label and the text input itself. Later in the module, we will also add some error styles to make it easier to show the user if an incorrect value was entered. But for the moment, we'll start with a base set of styles. So for this, I'll add my input container style here, which will be applied to that view. And then also a label style object, which is added to the text, of course. And then the actual input style, which is added to text input. Now on the container, I want to make sure that we have some horizontal margin, so to the left and right of 4, and very important, that we have some vertical margin of 16 pixels. Also to ensure that multiple inputs that are above each other, as we have it here, have some spacing between them. That's why I add this vertical margin. Now we can fine-tune these values later, but for the start, that is what I want to start with. Now on the label, I want to set the font size to 12, which is a bit smaller than the default, that would be 14, but I want to have a little bit of a smaller text here. And I will set the color here to global styles, imported from my styles file here in the constants folder, which we added in the previous course section. So to global styles dot colors dot primary 100. I also want to add a margin to the bottom here so that there is some spacing between the label and the text input, some vertical spacing, and that margin to the bottom could be 4 pixels. And then for the input itself, I want to give it a background color so that the input is a bit easier to see compared to the background we have on this screen. And I want to give it a background color that is also taken from my global styles. And there I want to dive into colors and use primary 100. So the same color I'm using for the label. Next, I also want to add some padding here so that we have more spacing inside of the text input, more space around the text entered by the user. And there I'll use 6 pixels. And also give this a border radius of 6 to have some rounded corners on those input elements. I also want to add a font size of 18 to make the text in the input elements bigger, so that it is easier to see and takes the focus of the user. Last but not least, I'll also add some text color, so the color of the text that is being entered, by diving into colors of our global styles and using primary 700, which is a dark shade of our primary purple color. With that, we have a start, a first set of styles. We can now apply them. So now we can add this style here to this view, so the input container style, and then add a style here to this label, and that of course would be the label style. And then here on text input, we want to add a style that is our input style. With all that set, if we save this, that is what we have. Now I think the spacing is a little bit too much between these inputs, so I will actually decrease the margin vertical here to 8. So I half it, and by doing that, that looks better. I also want to ensure that this multi-line input has multiple lines right from the start so that it's clear to the user that longer texts can be entered here. So I want to have some specific styles for the multi-line input. Now to make this work, I will make 2 changes. First, I will add the styling, input multi-line, where we can simply give this a min height of 100 pixels, let's say, to give this a minimum height, which is applied even if nothing has been entered yet. And I will also add text align vertical top here, because that is a hint that we actually get from the official docs. If we have a look at multi-line, there we learn that we should use text align vertical set to top for the same behavior in both platforms, so for the same look on both platforms. That's why I'm adding text align vertical here as well. But that's only step number 1. Now we want to apply this to the input if it is multi-line. Now to find out if it is, we need to have a look at the text input configuration. For that, I'll add a variable, input styles, which is an array which has one element by default, and that would be our input styles, our standard input styles. And I want to use input styles down here for setting the styles on the text input. And I'm doing it like this now with a variable so that we can then also dive into text input config and check if it's truthy. And if it does exist, check if it has a multi-line property, which also is truthy, so which is set to true, for example. And if that's the case, if we received a configuration object and that object has a multi-line property that contains a truthy value, then I want to actually go to my input styles and push another style onto input styles, and that would now be input multi-line. So that then our array of styles does not just contain one style, but the standard style and the multi-line style, so 2 styles overall. And actually this could be a constant as well, because we can push even if this is a constant, because it is a reference value. In case it's not clear what reference values are and why we can use const here, even though we push onto this array, you find a link attached that dives a bit deeper into this topic. It has nothing to do with React Native though. So with that, we should be able to set a different style if it is multi-line. And indeed, we now got this different look here, which I think looks pretty good. So that is a start. And we can now enter values here. We can also bring up that keyboard here to see which keyboard we get when we go through these different inputs. So that is looking good. But I'm not 100% happy with the final layout. And therefore, that is what we will explore in the next lecture. Now, with some default styles set up, it's now time to talk about the general layout. Now, the layout is of course not controlled inside of the input component, but inside of the expense form component instead, because now it is about positioning those inputs and also position them in relation to each other. Now, it is of course, as always, up to you how inputs should be positioned, but I think it would look quite nice if the amount and the date inputs would be next to each other, because both input fields don't need to be that wide, and then the description input field can be beneath each other. We can also add a little bit of margin to the top of this form to push this overall form down a little bit. We could also add some text above it if we wanted to. So I will start with positioning these 2 input elements next to each other, and we can do that by wrapping them in a view that only holds these 2 elements that should sit next to each other, so date and amount. And then after adding that view here, we want to give this view a flex direction of row to make sure that its child items, so these 2 input elements, are positioned next to each other. For that, in expense form, we can also add a styles object with style sheet, which of course must be imported from React Native, as you know. And here in this style sheet, we can add our inputs row, for example, where we set flex direction to row and justify content to space between to push them away from each other, to add some distance between them. So now this inputs row style can be added to this view, which we just added. So we set this to styles.inputsRow. And with that added, these inputs are next to each other. But with that, I now also want to make sure that they have the same size. For that, what we could do is we could go back to input.js and make sure that the input container receives flex 1, so that it takes all the space it can get. If we do that, it kind of works, but it breaks for the multi-line input. So that is not a good solution, because this does break the overall layout we have here. So I only want to apply this for these 2 inputs that are in a row. And to achieve this, we can make our input.js file a bit more configurable, or make this input component and its styles a bit more configurable. We could accept a style prop on our input component here and merge that incoming style with that input container style we define as a default for the view in this input component. You learned before how that works. We can turn this into an array of styles here and also merge in that incoming style value, so that style prop value. By doing it like this, we can pass the style prop to the input component if we want to, and therefore control the styling of the input from inside the place where we are using it. So here we could then add a row input style object where we set flex1, and we add that style object here to these two inputs that are in a row by simply adding style here and pointing at styles.row input, and doing this for both these inputs, for amount and date. And with that, they have the same size again, but the multi-line input below them is not affected. So that is looking quite good, I would say. Now I also want to move down these inputs a little bit, and I want to do that here in expense form where I control all these inputs. To move them down, we can add a style to this overall view that holds all the inputs. We can set up this style down here and have our form style, for example. That sounds like a fitting name. And add a margin to the top of, let's say, 80. You can, of course, play around with that value to find a value that best suits your needs. But now with that, we can add this form here to this view by adding the style prop and pointing at form like this. Now this is pushed down a little bit, maybe a little bit too much, and I think a title would be nice here. So therefore, in this form, we can add a text component, which is imported from React Native, and add a title. And the title here could be your expense or anything like this. And of course, now also want to style this title. So going down, I first of all will decrease the margin to the top to 40, and I'll add a title style where I want to give this title a font size of, let's say, 18, a font weight of bold to make it bold, and a color of white to make it white. And then we can add this title style here to this text. So therefore now here we can add styles.title here, save this, and here's our title. Now some spacing around the title would be nice as well, and it should be centered. So therefore I'll go down here again, and on that title we can add a margin vertical of, let's say, 24, and also set text align to center, and I will also actually ramp up the text size to 24 as well. With that, that is our title here, and on Android we also have that title. Now it is up to you whether you want to have that title and if you like the look, but I do like it, and therefore that is the layout I want to go with. Now we got some styling, we got these configurable inputs, and we got the title and the layout, of course. And therefore, the next step is to actually handle the entered values and make sure that we consider them when the user does click add. Because at the moment, we're still always adding some dummy data, and the plan is to change this. So let's now make sure we actually use those entered values. Now, this all starts in the input component, where we accept the text input config, which allows us, in the expense form component, to, for example, add the onChangeText property, which allows us to connect the inputs to functions that will be executed whenever the entered values change. And then we could use the expense form component here to handle those entered values. Now for that, we can start with a couple of state slices by using useState, provided by React, and by then registering state for the different input values. So here we could then get our amount value, for example, and a function to update it, set amount value, and initially it's an empty string. And that is important. I did mention it before in the course already. I want to mention it here again. Whenever you fetch an input value, you will get it as a string. Even if the input provides a number, it is still some text technically. So it's text that contains a number. Therefore, if we talk about the data type, it is a string. You can, of course, convert it to a number later to work with it as a number, but initially it's a string. That's why I set an empty string here as a default value for the amount value. And then here in the amount changed handler, we can, of course, set the amount value to the text that was entered, which we conveniently get automatically. React Native gives us the entered text or the entered amount. If we connect this function to onChangeText, then React Native will make sure that this parameter value is provided automatically, and this will be the amount or the value in general entered into the text input to which this function is connected. So then we can update the amount value in our state with the entered amount, and we can also set up two-way binding so that we could change this from somewhere else in our component as well and reflect the changed value in the input by also adding the value property here to the text input config. So therefore we add the value prop to the text input component, and by connecting this to amount value. Now whenever we change the state, for example by pressing some reset button, which we don't have here but which we could add, we also reflect that changed input state in the input component. So that's how we could set up such two-way binding. And now we're keeping track of the entered value, and we could then use that somewhere else in our application, for example when the form is submitted. Now before we deal with form submission and with working with these state values, we have a little problem to solve though. And that problem is that we don't just have one input, but multiple inputs. Therefore, we might need multiple state slices, which is no problem, but we also need multiple such handler functions, one for each input. That's also not necessarily a problem, but we can maybe find a solution that is a bit more elegant and scalable, at least to a certain extent. And therefore, what I will do here, which is not required, but which I will do here to show you that you could use this approach, is I will move away from using multiple state slices, one for every input, to using one state slice that actually stores an object. And there I will have my input values and a set input values function. And initially I have three properties here. That's amount, which is an empty string, date, which is an empty string, and also description, which is an empty string. So one property for each input. And then I will make this function more generic as well. This will be the input changed handler. And I do expect to get the entered value because that is provided automatically by React Native. But I also expect to get another parameter, which will be the first parameter we get here, which is the input identifier. And then my idea is that in here, I can call set input values and update this state such that we keep all the input values that haven't changed, but we overwrite the one value for the one input that has been changed. Therefore, since I will also need parts of the old state, I want to keep all the state that hasn't changed, I will pass a function to this state updating function, following that best practice that if you update state based on the previous state, you use this function form of the state updating function. And here we get the current input values object. And we then return the updated object, which is a new object here, where I spread all my current input values, but I then overwrite the one value for which we received a new value. So the one input for which we received a new value. And we should be able to identify this input by this input identifier. And now the expectation is that input identifier is amount, date, description. One of these three values. So we can dynamically set this property and target a specific property by using square brackets here and passing input identifier between the square brackets, and then setting the entered value as a value for this dynamically accessed property. In case this syntax doesn't tell you anything, this is standard JavaScript. It allows us to set and target a property dynamically. Now the property name we're setting is not input identifier, but the value stored in input identifier. So if we receive an argument of amount, so a value for this argument of amount, we would target the amount property in this object with this code here. And we would set the amount property equal to entered value. So this allows us to dynamically target and set property names. And that is the syntax we're using here. Now with all of that, we have a reusable generic input changed handler function, and we have one state object that manages all the input values. Now we just also, of course, need to connect this function to all our inputs. And for this, let's start here with the amount input. Here we point at the input changed handler, but now since this is a generic function, we must make sure that this input identifier is passed into this function when it's executed. You learned that the entered value is passed in automatically by React Native, but this identifier isn't, because that's my own idea that I want to get this identifier. React Native doesn't know about this idea. But thankfully in JavaScript, we can pre-configure a function for future execution with help of the bind method. We can execute this on a function, and then bind takes a couple of arguments. The first argument defines what the this keyword in the to be executed function will refer to. But we're not working with this here, therefore it doesn't matter, and I'll just set it to this, but again, this does not matter. The second argument you pass to bind will be the first argument received by this function though. And that should be my input identifier. So therefore here, I want to pass amount to target the amount property in my state for this input. Now we don't need to set this value here because that will still be provided by React Native, and by default that will be added as a second parameter. So that is the setup we need to pre-configure the first parameter value for this function. The second value will then still be passed in automatically by React Native. So we will still get that entered value. And here for the value, I don't want to target amount value because this state doesn't exist anymore. Instead, I want to target input values here, and then there the amount property. Or of course, we can also just use the dot notation here. And now we can apply this same logic to all the inputs. Here for the date, the identifier should be date, and we access input values.date. And for the description, we of course also add description here as an identifier and target or access description down here. With that, if we reload everything, the app should still work fine. And we can still enter our values here. So this all works without any issues. But now we have this generic approach for handling the inputs, which is not a must use, but allows us to avoid some redundant code. So that's step number one. Next, we will deal with the submission of the form, where we then actually need those values. So let's now deal with form submission. Now, as always, there of course are multiple ways of handling that. At the moment, it is worth noting that we actually handle the form submission in Manage Expense. There I have this confirm button. Now, we could keep it here and simply manage our form state in this component instead of expense form. So we move that state management up, and we then pass the event of entered text around with props. But actually, to me, it makes more sense to manage the form state here in expense form and to also manage the form submission there, because the form submission belongs to the form, at least in my opinion. Therefore, what I will do is I will grab this here, this view from Manage Expense, this view which holds my buttons, and I will move it here into the expense form component. There we can add it below all our inputs, for example here. Now, of course, we also need to bring over the styles and imports to our custom button component. I'll start with the import so that I don't forget it, and I'll import button from going up one level UI button like this. Now, to also migrate the styles, here I need the buttons and button style. So these are the styles I will cut from manage expense. The other styles are still needed here, but I will cut those styles. And now in expense form, we can add those styles here, maybe at the bottom, doesn't matter. And with that, that should still work, though of course we won't find these functions that should be executed. Now therefore we might want to re-add those functions, but actually that's not quite the case. I do want to handle the submission here in this component, so I will add this confirm handler, though I will name it submit handler, but that is optional. But regarding the cancel handler, that doesn't have to be handled in this component, because in the cancel handler, we are in the end only closing that overlay modal. We're just going back. And I still want to do this here in the manage expense component because it makes sense to manage the overall screen that opened up in that screen component. Therefore, in expense form, I simply expect to get props here in my custom component, and I do expect to get an on cancel prop. I also expect to get an on submit prop here, and the on cancel prop will be important now because down here on this cancel button, I will just use on cancel. So I expect to get a function as a value on this on cancel prop, and I will then connect this function to this button. Now for the other button, I will point at my newly added submit handler, and we will work with the on submit prop, which I also added a little bit later. In manage expense, we now just have to make sure that we pass on cancel to the expense form, and that we point at our cancel handler here. With that, if we save everything and reload everything, it should work again, except for the fact that I'm relying on isEditing, which I'm not getting. So we actually, of course, need to pass this down as well, because here I'm using isEditing to control whether we are updating or adding. And actually here, I expect to get my submit button label as a prop. So I will use submit button label as a prop on my expense form and add this as a prop here. And in manage expense, I will therefore then set my submit button label. And then here we can use the same logic as before, where we check isEditing. If we are, I say update, otherwise I say add. So that's a way of making sure that we still set the right label, but I still want to have the logic for that in managed expense, though we could have also passed isEditing to expense form. That would have been fine as well. And with that, now we should be able to open this. Here we go. And I can still close it and cancel it. This works as before. Of course, also on Android. But now we also actually will be able to do a bit more once the form is submitted. And that is therefore what we will do next. So let's now start with the actual form submission in expense form, where we did add this submit handler. Now we are managing all the input states here. So when we talk about form submission, this primarily means that we want to collect all the entered values, and maybe we also want to validate them and show some feedback to the user. And that is something we will also do soon. For the moment, we'll start with collecting the entered values, and I will also start transforming some of the values. To be precise, the amount. I want to transform it from a string to a number. So here in submit handler, we could add an expense data object, where we in the end just want to have all the values entered here, but we also might want to transform the values. Therefore, I will re-add an amount property here. and simply set this equal to plus input values.amount. The plus here converts this string to a number. Now for the date, I want to convert this from text to an actual date object. So actually we can create such a date object with new date and pass input values.date as a value to new date. And therefore this string, which represents a date, is passed as a value to the date constructor function. And that indeed is working such that it is able to convert date strings into date objects. If the string is formatted properly, which the string we are expecting here, which has this format, will be. So a date entered as text like this will be convertible to a date object like this with JavaScript. Now for the description, I will just set this to input values.description because I don't need to change this. Now we are not validating any user input here. We are not checking whether this date conversion worked or if the user entered some incorrect values. We are not checking whether the amount is valid. We will do this later, but we are collecting the input values now. And now, of course, in the end, we don't need the input values here in expense form, but we need them in manage expense, where we have this confirm handler, where we are then triggering different context methods. Therefore, we can go back here to expense form and call onSubmit, which is that other prop we're getting, this onSubmit prop here, which should hold a value that is a function that can be executed, and that should be a function that wants this expense data, which has this format, amount, date, and description as keys. And since we are the developer, we can make sure that onSubmit in expense form receives such a function. In manage expense, we have confirm handler, and here we could expect to get our expense data. And then there we could just forward expense data to our context functions instead of setting our dummy objects. Because in those dummy objects we had description, amount, and date, and these are exactly the same fields we have in our expense data here, just in a different order, but that doesn't matter. So therefore, if the expense data is formatted like this, we can pass that to our context, and we will therefore pass proper data to the context, real user-entered data to the context. Now we just have to connect confirm handler to expense form, and we do that through the onSubmit prop, where we now point at confirm handler. And with that, the validation is missing, but as long as we enter correct data, our app should work. If I now give this a try, let's say here on iOS, and I enter 89.99, and I pick some date, like a date in June, this is a test, we should be able to add this and find this under all expenses. Here it is with the proper date, with the proper amount, and this is a test. And if I open this, I now of course can also edit this, though we will soon make sure that these inputs are pre-filled when we edit this. Because at the moment we have to manually re-enter everything, which is of course not a great user experience. But if I do update it, indeed we see that it was updated with all the new data. So that is generally working. Of course, we still want to add some validation, and we want to make sure that we pre-fill those inputs in case we are editing, so that we don't have to re-enter everything. And that is actually the next step. I want to make sure that this is pre-filled. So how can we make sure that this is pre-filled with the correct data when we are editing an expense? Well, in the end, in manage expense, we do get the ID of the expense we are editing. We can now use this ID to fetch the data of that expense, so the amount, description, and the date. And then we could pass that data into the expense form to set that data as an initial state for our form state. Because we must not forget that we're managing the input values here with state, and I set all these input values to empty strings initially. Since I set up two-way binding, providing the value prop to all these inputs though, we could set the initial states to different values, and that would then be reflected in the input values. And therefore, that is what we can do here. We can go to manage expense and first of all fetch all the data we need, so the entire expense in the end. For this, the selected expense constant could be added here, and we could reach out to expenses context to all the expenses there, and then we can use the find method to find a specific expense. We pass a function to find that will be executed for all the expenses, and where we get the expense for every execution. And we return true if it is the expense we're looking for, which we can tell by looking at the ID. If the ID of the expense we are currently looking at is the same as the edited expense ID, we know that this is the expense we want to edit, so that then gives us the appropriate selected expense. Now this can be passed to the expense form. There we could maybe expect to get a default values prop. The name is up to you. And we pass the selected expense as a value for that prop. In expense form, we then need to work with that default values prop. And we want to set our state values to those default values if we get them. Now, default values could be undefined. If we are in add mode, in that case, default values will be undefined, because then we got no selected expense. And therefore, we should take care that we also handle this case. Therefore, here for the amount, what we can do is we can check if default values is truthy, if it exists. If it is, we know that we are getting an existing expense. And then for the amount, we can drill into default values.amount and actually convert this to a string, because in the expense it will be a number, but for this form we want a string, because for all the text inputs we have strings, as you learned. And therefore I will call toString on that default value on this amount. But if default values is falsy, if it's not set, I want to switch back to my empty string as an initial value. And that's how we could deal with that for the amount. And if we save that, and I tap on an existing expense, you see the amount is pre-filled with that expense value. So that's working. And we can therefore do similar things for the other fields here. For date, we also want to check if default values exists. And if this is the case, I want to drill into default values.date, but here date is an object, and we want a string that has this format. Year, 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 dash, month, month, dash, day, day. Conveniently, we can easily get this format by calling toISOString on the date object, which is a built-in method on date objects, which has a standardized form of outputting such a date. And there we then need to slice this to only get the first 10 characters, because that will be exactly that part that we need, with the year, the dash, the month, and so on. And alternatively, we set this to an empty string if default values is falsy. As a little side note, since that is now how I do get my properly transformed and formatted date, we could use that same approach in our utility date.js file. There, for getting the formatted date, instead of building it like this, which also works, we can use date toISOString slice 010 to let JavaScript do more of the work, or to utilize this built-in method, to be precise. That is totally optional, but now we have a consistent way of formatting the date. Of course, if I do have this logic in getFormattedDate now, we can also call this method in our expense form though. So in expense form, instead of reinventing the wheel, we could simply call getFormattedDate here now and pass our default values.date to that function. Of course, for that, this function also must be imported. So that will now give us a properly formatted date, which then also is a string instead of a date object. And for the description, we also check if default values is truthy. If it is, we just use default values description because that already is a string. Otherwise, we use an empty string. So with all that out of the way, if we now save that, we can see that if I tap on an item, it has this proper format. And therefore, of course, if I added this, and I added the description a little bit, and the price, and let's say the date here, I can click update, and this is all reflected here, as you can see. So that is working, and now we are pre-filling this if we're editing. If we're adding, we still, of course, get this empty form here, and we can still manually enter everything we want to enter then. So this also still works, and this still also does add a new item here, just as it did before. If we then update this item, we utilize the fact that this was pre-filled. So that is all working the way it should. And now we can therefore turn to the next step and add some validation. Because at the moment, we can also confirm an empty form, and that crashes our app and is in general not something we want. So let's now add validation. Validation simply means that we want to check the entered values before we use them. Now we could add validation that validates the user input with every keystroke. We could do that, but that is not what I want to do here. Instead, I want to add validation that validates the user input once the form is submitted. So here in Submit Handler, before we forward the collected data, I want to validate it. And if it's incorrect, we won't forward it. Instead, we want to show an error. We want to give the user some feedback. So how can we do that? Well, we can add a couple of helper constants here to make the code a bit more readable for determining whether those individual inputs are valid. I will name the first one amount is valid, and that should hold true if expense data.amount, so this amount converted to a number, is, let's say, greater than 0, because the amount entered should be greater than 0 to be valid, I would argue. And I want to make sure that it's a number in the first place. So I will make sure that it's not a number with that built-in is not a number function. I pass expense data.amount to that, and then I combine these two conditions. So if it is not a number, if this would be true, or if it is an amount smaller or equal than 0, this would hold false. If it's not a number and it is greater than 0, it is valid. Now for the date, I will also add a date is valid constant, and the date should be valid if we could successfully convert it to such a date object. Now to find out if that worked, there is an approach that looks a bit strange but works really well. And to understand this approach, I'll go to the browser and open the DevTools just so that I can show you something here in regular JavaScript. Imagine that you create a new date, and to this constructor you pass a valid date, like this. In that case, we get a valid date object. Now, if you do pass something invalid, like hello, you get invalid date as a text output. You get that if you call toString on that created date. Then you get invalid date written like this as a string. We can utilize this fact here and simply check if expense data.date toString is equal to invalid date written like this, and make sure you got the casing correct. If this is the case, we know it's invalid. Since I want to store true here if it is valid, I need to check for the opposite though. So now this will be true if this is not invalid date, so if it is valid. If it is invalid date though, date is valid will store false as a value. Now for the description, we can add description is valid, and that should be valid if expense data dot description, once we trim it, so once we remove excess white space at the start or end of the string, has a length that's greater than 0, so it's not empty. This allows us to check that the description is not empty, which is the only validation I want to perform here. Now we got those 3 helper constants, we can now add an if check where we use them. I want to submit if amount is valid, date is valid, and description is valid is true. That means that I want to stop and I don't want to continue if one of them is not true. If the others are true but one of them isn't, that's enough for me to stop the submission. So here I will check if not amount is valid, or not date is valid, or not description is valid. If one of these 3 scenarios is the case, then I want to return here so that this line of code isn't executed. We return and therefore we stop the function execution. In addition, I want to show some feedback to the user here to inform the user that the validation failed. For a start, we could do this with the alert API. From React Native, we can import alert, and we used that before in the course already. And we could use that to show an alert where we say invalid input as a title. Please check your input values as a text. And we could then also configure a button if we wanted to. Otherwise, we'll use the default button that is provided to us. With this logic added, if we saved it all and reload, if we try to submit an empty form, we get this alert. If I enter a negative amount here, I get this alert. So even if the rest should be valid, if I enter valid data here, I get an alert because the amount is invalid. The same is true if I enter hello here, because this can't be converted to a number. If everything is correct though, we can submit this. We can also check the other inputs here. If the amount is correct and the description is correct, but the date is empty, we get this alert. And if I enter something like 2021-1-1, I also get this alert. So that works. If I do enter a correct value here, but I leave the description empty, I get an alert. And if I add a bunch of blanks in there, I also get this because the trim method that we added in our check removes those. So that works, but I actually don't want to use this alert here for the feedback. We could use it, but I want to show you how we can provide feedback to the user directly inside of this user interface here. So how could we provide feedback to the user? Well, I would like to highlight the inputs that are problematic. I would like to highlight their labels and the input elements themselves by changing their styles. In addition, I want to output an error message directly in the user interface. Now, to achieve this, we can change our input values state a little bit. Instead of just storing the values here as values, so just the entered values as values for our different identifiers, we could store objects here. Objects that have a value property, but objects that also have a isValid property. Now, this isValid property could be true or false, and it actually also depends on the initial value. Therefore, we can basically repeat this check here. And if default values are provided, so if we are editing an existing expense, we know that we will have a valid value right from the start. Otherwise, we will have an invalid value right from the start because we start with an empty string. So therefore here, we can do that for all these values here, for all our inputs, and also split this into a value and the isValid property, where isValid also takes the default value into account and is either true or false based on it. And we also do this for the description, where we have the value and then is valid. And we use the same approach as before. And actually, we can shorten this. Instead of having this ternary expression, we can just use this approach, which will convert a truthy or falsy value into a real Boolean, into true or false. So if we have no default values, this will yield false. If we have default values, this will yield true. With that, we don't just have the values, but also the validities. And therefore, I'll change the state name to inputs and set inputs, because now it's not just the values, but the values plus more information. In this case, the more information, the extra information, is the validity. This, of course, means that we need to update a couple of places in our code. Here, for example, we update set inputs, or we call set inputs now. We get our current inputs, and we want to distribute our current input data into this new object. But when we update one specific identifier, we actually want to update the value of that identifier and set it to the entered value. I will also always set the validity to true then, because when I'm entering something, I actually do assume that it's valid, and we will change it back to false later if we detect that it was invalid after submission. So that's why I will always set is valid to true if some value was entered, even if it should be invalid, just so that I assume that it is correct and we then do revalidate it later. There would be alternative ways of handling this, but that is an approach that I want to use here. Now we also need to update more places in our code though. For example here, where we collect the entered data, we now have to use inputs, that's our new state name, inputs instead of input values. And for the amount, we are interested in the value. For the date, we are now interested in the value, and for the description as well. And then we also need to update our two-way binding. Here we now use inputs.amount.value. That is what we want to bind here. And we have to make the same changes down here. It is inputs.date.value, and it is inputs.description.value. And that should be all. Now, why am I doing that? Because now, when we determine that something is invalid, instead of using this alert, I want to update the validity. Here, in my if check, where I detected that at least one input is invalid, I want to call setInputs and use this function form of updating it to get my current inputs, but to then return a new object where I update the data stored for all my inputs. For the amount, for example, I will keep the entered value. I don't want to change this. So I will access currentInputs.amount.value and keep that. But I will set isValid to the result of amount is valid. So to the result stored in this constant here. I will use that down here. And we use the same approach for the other inputs. For the date, we keep the entered value. So we keep current inputs date.value, but the validity is set to date is valid. And for the description, we keep current inputs.description.value, but we set is valid to description is valid. So now we update this state if we determine that something invalid was entered. And now we can use that information in our JSX code to update the look of these inputs, to, for example, change the label to red. I will do that soon, but before I do that, I want to start with a simple error message that I will output below my inputs. Here I'll add a new text, like this. And I only want to show this text if we have an invalid input. So I will render this text conditionally by checking inputs.amount is valid. And if that is not valid, or if one of the other inputs is not valid, I want to show this text. Now, instead of checking this all inline here, I will add a little helper constant before we return the JSX code, which I will name form is invalid. And here I will simply check if inputs.amount is valid is false by adding this exclamation mark, or if inputs.date is valid, is false by adding this exclamation mark, or if inputs.description is not valid. If one of those conditions should be true, so if one of those inputs is not valid, then I know that the overall form is not valid, that it is invalid. And we can use this helper constant down there to conditionally show some text. And the text could be invalid input values. Please check your entered data. Whatever you want. You can output whatever text you want. Now we'll take care about styling this in a second, but with that all, if we do try to submit this, I get my text here. I actually get this text right from the start when I add. If I'm editing, I don't get it right from the start, but there I get it as soon as I try to submit an invalid input. It's hard to see, but we do get this text. Now I actually don't want to get this right from the start when I'm adding an expense, and therefore we need to make a change that ensures that we don't set this or that we don't get this initially. And the change we can make for this is that an expense form for the initial validity, we actually switch this from true or false, depending on the fact whether we have default values or not, to true. This is technically not correct because initially an empty string, of course, is not valid. But it helps us ensure that we initially don't show this error message, and it doesn't have any negative effect to set this to true. Because we still validate in our submission function, and we still overwrite is valid to the actual validity after running our validity checks. But this change ensures that if we save this and we set is valid to true as a default for all inputs, we don't see this warning right from the start here when we add an expense, but we still will see it if we do actually try to submit invalid data. So that is working. And with that we got some feedback, but of course now we want to enhance the styling, and I want to make sure that I also highlight the invalid inputs. And that's therefore the next and last step for this course section. So let's work on the styling. And I'll start with this error text in expense form. Right now, this is just some black text, which is almost impossible to see, and it's not formatted nicely. To change this, in expense form, we can add a new style object. Error text could be the name. And there, I want to make sure that we set text align to center. I do want to change the color to some color in my global styles. And there in the colors, I define some error styles which we can use. For example, we can try error 500 and see how that looks like. And I want to add some margin around the text, and I'll add a margin of 8. Now we can apply this style property here to this text and add the style prop and set this to styles.error text. With that, if we add this style, this now looks nicer. But as I mentioned, I also now want to highlight the invalid inputs. Now to make this work, we need to let the inputs know that they are invalid by passing some data to them through props. And then we need to add some styling in the input components to reflect that invalid state. Now to achieve this, we can pass a new prop into the input that could be named invalid. Sounds like a fitting name to me. And here, the value I do want to pass in is simply inputs.amount. In this case, since this is the amount input, dot is valid. Or to be precise, since I named the prop invalid, I add an exclamation mark to invert this, to pass true if is valid is false, and pass false if it is true, so that invalid is true if the amount is not valid. And now we can pass the same prop into all our other inputs here for the date, and for the last input here for the description. And then we can utilize this in input.js. There I want to add some styles conditionally based on the validity. Now for that we need to define those styles first, and I will add an invalid label style object here for giving the label an updated style if it's invalid, and an invalid input style for updating the input itself. Now for the label, we can set the color to that global styles error color that we used for the error text as well. For the input itself, I want to change the background color of the input to global styles .colors.error 50, which is a lighter shade of this error red color. And now we can apply this conditionally. Here for the label, we turn our style prop value into an array. We always add the default label styles, but I then check if this invalid prop, which we are also getting now, if this is true. If it is true, then we also add styles.invalid label. Otherwise, we don't add any extra styling. And here for the input, it's the same. We already got our input styles array here, and we want to add one more item to it if the input is invalid. So we can check if invalid is true, in which case I will push another style object onto my array of styles, and that would then be the invalid input style. With that out of the way, if we save that, we can see everything is red here. If I restart, this is a valid input. And if I now leave the amount empty, we see that is highlighted. The other inputs aren't. If I turn the date into an invalid input, that is updated. If I then enter something valid here, that is updated as well. So it's not marked as invalid anymore. And here, this can also become invalid. Please note that because of how we set up our code, as soon as I start typing, it's marked as valid again, trusting me that I did enter something valid. If it's still invalid, it will be marked as such again once I try submitting it again. So this all works. This all allows us to enter values, and it shows us some nice feedback if we are entering invalid values. Now that's it for this course section. In this course section, we worked a lot on those inputs here. We added validation in the last lectures, and we made sure that this validation highlights the invalid inputs and that this works the way it should. It ensures that we can't enter invalid values. But before all of that, we made sure that we have some inputs in general, that they are pre-filled if we are updating an item, and empty if we are adding a new one. And we learned how we can split our form into multiple components, how we can build reusable and configurable custom input components based on the built-in text input component. We learned about the props supported by that built-in text input component and how you can use these different props to configure the text input. And we of course had a detailed look at styling and building nice layouts again. With all of that, you gained more crucial knowledge about fetching and handling user input, which is something you probably need to do in almost any app you're building, and that's why it's so important. With that, we are now well prepared to continue, and in the next lecture, we will actually build up on this app here again, because then we will actually connect it to a backend and make sure that all that data is not just stored in our device memory, where it will be wiped whenever the app restarts, but that we instead store it on a backend and fetch it from there. In this course section, we are again going to build up on the app we worked on in the last sections. You'll find my snapshot attached to the next lecture, by the way, so that we can start with the same snapshot. But in this course section, we will build up on this app to learn how we can connect a backend and send HTTP requests. Because of course, that is also something that a lot of apps need to do. You don't just work offline, just on the user's device. but instead you might have a backend, some database running on a server and an API that belongs to that server, where you need to send and store data, where you want to fetch data, do any kinds of calculations, run algorithms, anything like that. In this course section, we are going to set up a dummy backend. We are going to use Firebase as that backend because I don't want to write any backend code because this is a React Native course, not a Node.js or PHP course. And we will use that dummy backend, though I want to emphasize right away that what you learn would apply no matter to which backend API you're talking. No matter if that API is written in Node or PHP or .NET, this works no matter which backend you have, but you need such a backend API, a REST API for example, to send requests to it. Because we don't need a backend that serves back HTML files, because we're not building a website, we're building a mobile app, and therefore we need such an API that is only about exchanging data. So we're going to set up such a dummy backend in this course section, and then we are of course going to learn how we can send HTTP requests to that API to store data, update data, delete data, and of course also fetch data from it. Last but not least, we will also learn how we can deal with different states whilst our requests are underway. So different loading and error states, how we can show a loading spinner, for example, and so on. So again, plenty of things to learn and cover, and therefore we'll dive right into it. So let's get started. And as mentioned in the previous lecture, we will use Firebase as a dummy backend so that we don't have to build our own backend. Firebase allows us to work with its API, its REST API, to store, delete, update, and fetch data. And as mentioned in the last lecture, we need such an API that is about exchanging data because we don't need a backend that serves HTML files because we can't handle those files. We don't want to get finished websites, we just want to get and send data. And for that, we could use a GraphQL API or, as we're doing it here, a REST API. And Firebase will give us such an easy-to-use REST API. Now, Firebase can be used for free. You can get started with it for free, and you can visit firebase.google.com and then simply get started. Now, you will need a Google account for that, but you can create one for free, of course. And here I will quickly log in with mine. And once you did log in with your account, you can create a new project, which is what I will do here. Now you can give this project any name you want, like React Native course, name is up to you, and then simply click continue. You don't need to add analytics, and then create that project. Now Firebase actually is a service provided by Google that offers more than that dummy backend we are going to use. You can integrate it into your app to do way more with it, and we will see it again later when we dive into user authentication, but you can also just use it as a basic backend, and that is what we will do. If you are interested in learning more about Firebase, definitely check out their official docs and website, of course. Now, what we will use here is the real-time database. They got two databases. The real-time database is the one that's a bit easier to use though, and the one that gives us an easy-to-use REST API. So we click on real-time database, and then on that page, we can create a database. Now, behind the scenes, Firebase will also create a REST API that sits in front of that database, but for us, it will look like we directly send requests to the database, but we will actually send requests to an API, and then Google Firebase will translate that to database requests behind the scenes. That's just a little side note though. So when we create that, we can choose a region, and the default is okay here. And for the security rules, we should start in test mode, which makes sure that we can read and write without being authenticated, which is the mode I want to use here. So we can click enable and create this. So we can create this database, and we will then be able to see our saved data here in the future. Now, this URL, which you see here, will be the URL or a part of the URL to which we will later send our requests. So this will become important later. For the moment, that's all we have to do here. And we can now switch back to our code here to start working on sending HTTP requests. And that is what we will do next. So before we start with sending HTTP requests, let's decide when we want to send requests. And there are a couple of places in the app where we probably want to do that. For example, in Manage Expense, when we save a new expense or update an existing expense. Then we don't just want to store that in our context. We still might want to do that so that we store a local copy in memory as well. But we also want to send the expense to the backend. We want to fetch expenses when we view our expenses, for example, on the recent expenses.js file. When we delete an expense in Manage Expense, we also want to send a request. So that's where we want to do that. Now, how do we send such requests though? Well, in React Native, you can use the fetch API that's also available in the browser. You can use this fetch function, which you might know from the browser. But React Native also supports XML HTTP requests, and that means that you can also use libraries that build up on XML HTTP request. And a very popular library that does that is Axios. Axios is a promise-based HTTP client which you can use in the browser and also in React Native. You might know this package already. I like it a lot because it makes sending HTTP requests really easy, and you could use the fetch API as I mentioned, but here I will use Axios also to show you how you can use that third-party API for sending such requests. We need to install Axios as a first step, and therefore here in a new terminal window, I will run npm install Axios in this project. And once it is installed, we can start using it for sending HTTP requests. And that is therefore what we will do next. We will get started sending HTTP requests to Firebase, and then we will add more and more features step by step. So how should we get started? What is the first kind of request we want to send? Well, I would argue that it makes sense that we start with adding expenses. Besides storing them in our local context, which we, as mentioned before, still might want to do so that we still have an offline copy, which we can view, for example, without having an internet connection. So despite doing that, we also want to send it to this Firebase backend API, which we set up. And to do all of that, I will create another utility helper file, which I will name http.js. And it is in that file where I want to create a couple of helper functions that help with sending requests. For example, here in http.js, we could create a function called store expense. And we could expect to get our expense data here. And then here, the goal is to create such a HTTP request and send it to Firebase. Now this can be done with this Axios package. So we can import Axios from Axios. So use this third-party package. And Axios makes sending requests super simple. We can just call a couple of helper methods on this Axios object, for example, post to send a post request. And we want to send a post request here for adding a new expense, so for saving a new piece of data on the backend, because the Firebase API here wants us to send a post request if we want to create a new piece of data. You can check the official docs of Firebase to learn which request is expected for which kind of action, but it is a post request for creating new data. So the post method of Axios helps us send such a request, and now we need to pass the URL to which the request should be sent as a string as a first argument to post. And the URL is this URL. You can copy this URL here and paste that here. Or to be precise, that's only a part of the URL. Actually, this is the root URL. Now we can add more segments after this root, for example, expenses, And we have to add .json here. Now, this .json part is Firebase specific, has nothing to do with React Native or React or anything like this. Firebase just wants this .json at the end here to understand that we're targeting a specific node in the database, so to say. Now you can add any segments you want here, and those segments will be translated as nodes or to folders, you could say, in the database. So this will create an expenses node in this database, which we will see soon once we added our first expense. And under that expenses node, we will find the newly added expense. So that's the URL to which we want to send a request. Now, as a second argument to the post method, we have to define the value that should be sent. And in my case here, that is this expense data, which I expect to be an object that holds the amount, description, and date. Not the ID, because an ID, a unique ID, will be auto-generated by Firebase, which is pretty convenient because that allows us to get rid of our custom pseudo-unique ID generation, which we have here in the context. But that will be one of the later steps. So that will send such a post request. And for a start, that is all we have to do. That will send such a request. So now we can actually export this function to make it available outside of this utility HTTP file. And in manage expense, we can use it to send a request. Here in confirm handler, if we are not editing but adding, we can use this store expense function and execute it. Of course, you must import store expense from util HTTP. I can also get rid of some imports that I don't need here anymore, by the way. But with store expense imported like this, inside of the manage expense file, we can call it to send this request. Now we need to provide our expense data to store expense because that is expected as a parameter. So therefore in manage expense, I do forward my expense data, which is an object with description, amount, and date. Now we will improve this later, but for a start, that is all we have to do. If we now save that and we do enter some values here, like a first request question mark, and click add, nothing changes here. Here we still see our data because it still was stored in context. But if we go to this backend, we now see this expenses node, and in there we got this item with this cryptic text. That is this automatically generated unique ID I mentioned before. And if we expand this, we see the data we submitted. And that, of course, is awesome because that proves that sending our data worked. Now that's the first step. We still got more work to do on the front end though. We might want to add some feedback whilst the request is on its way. We also might want to handle errors that could occur. And we also might want to utilize this unique ID that is generated on the backend. Because at the moment, I still also generate my own ID. And that, for example, means that if we would want to edit or delete this item, we would have different IDs on the front end and backend, which could also lead to problems. So these are more things we can tackle. But before we do any of that, let's make sure we actually utilize the backend to fetch our expenses from there as well. And that is the actual next thing we will do in the next lecture. So as a next step, let's fetch some data from the backend. And for this, we can add another utility function here in HTTP.js and maybe name it fetch expenses or get expenses. The name, of course, is up to you. Export it to make it available outside of this file. And now we want to set a get request by using Axios get method. Now the URL to which we send the request should be the same URL as here where we actually stored an expense because we want to get all those expenses, so the URL is the same. But with that, we already got some copy and pasting going on, and we got this long URL everywhere, And if we ever need to change it, for example, to switch from a development backend to a production backend, we need to change it in multiple places, at least the start of that URL. And therefore, I will actually add a little constant here, the backend URL constant, where I want to store this URL root, like this. And then here we can construct the string dynamically by using backend URL plus, and then just change the path at the end, because that path at the end might be different for different types of requests, even though it is the same here. But later we will send other requests where this path at the end will be different. But with that, we now manage this in a central place, and we're now sending this GET request to get our expenses. GET doesn't need a second argument. We could pass extra config, but we don't need to pass any data because we're not sending any data, we're just getting data. Now, fetch expenses can be called in recent expenses, for example, because that is where we want to get our expenses. Now, to call it there, we can use useEffect, because that allows us to execute some code that should execute whenever the component re-renders, for example. So here we can use useEffect in recent expenses, and of course also import this hook therefore. And in useEffect, in this effect function here, we can call fetch expenses. Of course, for that you must import this function and then it can be executed here. However, now we're facing a problem. Sending an HTTP request is an asynchronous task. That means it doesn't complete immediately. That's why post and get return promises. Now you should know what promises are. It's not React Native specific, it's a JavaScript concept. Definitely explore dedicated JavaScript resources like my JavaScript The Complete Guide course if you don't know what promises are and if you don't have these fundamentals. In short, a promise is an object that will eventually give you access to some other data. And here, get, for example, will eventually give us access to the data fetched from the backend. Now, to work with promises, we can add then on the promise object and then pass a function to then, which will be called once the eventual data is there. Or alternatively, we can use async await, which is a more modern JavaScript feature. And that is what I will use here. I will turn this into an async function here. And then we can await this promise and store the eventually returned data, which in this case will be a response object with more details about the response in a constant. So that's how we can use async await here. And then the next line will only execute once the response is there. So once we have the response from the server, and then we can use this response. Now, when it comes to using the response, for Firebase, the response we get back will actually be an object where these unique IDs will be keys, so property names in that object. And if we had multiple expenses, we would have multiple property names that have this format. And then we would have nested objects for these keys, for these unique IDs that hold the actual data. And I want to transform that data into an array of objects where every object has the ID in an ID field and the amount, date, and description in other separate fields. For this, we can create an expenses helper constant which holds an array. And we can use a for loop to go through all our response keys. So we can go for all the keys in response.data. Axios gives us a data property on this response object, which holds the actual data that was sent back by the server. So now we go through all the keys in that object, because as I just said, we will get back an object, and those keys will therefore be those IDs. Now for every key, I want to create a new expense object, which should be an object, a JavaScript object, that has an ID field, which is that key I got here, and that also has an amount field, which is response.data for the given key .amount, I also want to set my date field, which should be response.data key.date. And I want to set my description field here to response.data key description. Now this syntax here simply means that we dynamically access a property which's name is stored in that key constant. So we access these different IDs basically in our data, so in that object that is returned by Firebase. And then we dive into amount, date, and description to get that data and store it in our own equally named keys. Now I want to transform the date to a date object by passing it to the date constructor, because Firebase stores the date as a string, and I want to convert it back into a date object because we work with that date object on the front end. And therefore this will now give us properly formatted data. Now we can push this expense object onto this expenses helper array. So we push expense object onto it. And then at the end here, outside of the for loop, we can return our expenses. And this code will simply transform the data sent back from Firebase into an array of objects that have the format we want them to have. You can, of course, look into the data you get back from Firebase with console log before you transform it so that you understand what you're getting back and why we are transforming this. I'm not doing this here, but this might be something you want to do if it's not clear why we are performing this transformation. So with that, we will get our transformed data, and we now have async await on this fetch expenses function, which means, because of the way async await works, that this function will also yield a promise. So in recent expenses, fetch expenses now yields a promise. And that means that we can now wait for this promise to resolve to get hold of the actual data that was returned, which we of course want here in recent expenses. To get hold of the data, we can use async await here as well, though we should not turn this effect function into an async function. That is discouraged by the React team, and therefore I will add another helper function in this effect function, which I name getExpenses, and I will turn this function into an async function and move fetchExpenses into getExpenses, and then in here we can await, and we can then call getExpenses inside of the effect function like this. So this is a workaround so that we can still use async await without turning the effect function itself into an async function, because the effect function itself should not return a promise, and if we would turn it into an async function, it would return a promise, because adding async in front of a function ensures makes that function return a promise. So now we wait for our expenses, and I know that I get back my transformed expenses here because of the code we added here in fetch expenses. And therefore here we are getting the expenses which we can now use in recent expenses. Now, how can we use the expenses here though? That is the next question. So we are fetching the expenses, we are getting them here, but how can we now use them in recent expenses? Well, we could, for example, say that we are no longer interested in the context here. Hence, I will comment this out. I will not delete it because we will use it again later, but for the moment I will comment it out. And that instead, whenever we visit recent expenses, we want to actually trigger this code here and fetch our expenses. And therefore, since we get our expenses here, we could manage some state here in recent expenses. And we would have our fetched expenses here and set fetched expenses. And initially this could be an empty array. And then here, once we got our expenses, we call set fetched expenses and set this equal to the expenses we got here. And then this state will be updated after we fetched our expenses. So therefore we can then use these fetched expenses in this component. So instead of expense context expenses, we work with our fetched expenses here, and we filter those, and we therefore generate our recent expenses based on the fetched expenses. Now, if we do all of that and we save this, and we make sure that we here have an expense that is recent, and therefore I will edit it here on Firebase, which we can do to ensure that it is recent, that it is within the last 7 days for me here. If we do all of that and we force a reload, we will notice that initially there is this message that we have no expenses for a very short duration. That is the duration where the request is on its way and we are waiting for the response. And thereafter we can see the fetched data here. So fetching does work. However, one problem we will have is that if I add a new expense, so let's say this expense, which is also recent here, it's not showing up here. Now, it is stored on the backend. We can see this newly added expense here, but it's not available on the front end. I need to reload my app to refetch it. And then it is here, but that is of course not optimal. Now, why is this happening? This is happening because the recent expenses component actually wasn't removed. When I manage a new expense, this recent expense component is still in the background. It's not destroyed because we use the stack navigator, and there, if we push a new screen onto that stack, as we're doing it here with the manage expense screen, the old screen, so the recent expenses screen here, still runs in the background. No matter if we are on iOS or Android. On Android, we don't see the old screen anymore, but it's also still running in the background. That means that when we close the Manage Expense screen, we don't recreate recent expenses. Instead, it was always there. Hence, useEffect doesn't execute again, and therefore we don't fetch again. Now, you might be able to find a workaround to listen to changes in the navigator. React Navigation does give you ways of listening to such changes, but I have a better solution here. We keep on using context because that has the advantage that we can update the context once we fetched our expenses. And it means that we don't have to change all the code in all our app because we can keep on working with context. As an additional benefit, we have to send less HTTP requests because we, for example, don't have to fetch new data from the backend just because we added a new expense. Because when we add a new expense, we already have all the data we entered here on the device, so fetching it again from the backend is a bit redundant. If we keep on using context, we utilize the data we already have on the device, and we just update everything offline in addition to sending the data to the backend. But this saves us this extra request where we fetch the data again, because we would only fetch the data again we already had. And that doesn't make a lot of sense. So, for all these reasons, I want to switch back to using context again. And instead of managing my expenses here with state in recent expenses, we can get rid of that. And we simply add a new method to our context. A new method that allows us to set our expenses so that we don't just add a new expense, but we also set expenses when we initially fetch them. So that when we get expenses from the backend, we can set them to our context, and then we work on these fetched and set expenses thereafter in the app. So in expenses context, I will finally get rid of all that dummy data now, because we don't need that anymore. And I will add a new method here, set expenses, where I actually expect to get my expenses as an array. And I will add a new reducer case here, set could be a fitting name, where I return my new state. And my new state that I want to return here should simply be my action payload, because I expect my action payload to be that array of expenses which I want to use here. And then here in the expenses context provider, we can add a new function, set expenses, and we get our expenses here, and we then dispatch a new object of type set, which is the type I used in the reducer, and our payload is equal to those expenses here, which we get as a parameter. Now we add this function to our object here, our value object. So we add set expenses here and point at the newly added set expenses function. And then thereafter, as a final step, in recent expenses, we want to use our expenses context and execute set expenses here and forward our expenses, which we fetched, like this. With that done, if we save everything, I get an error. Yeah, of course, we still have the dummy expenses here in the context. We need to get rid of those. Our initial value for the state is no longer dummy expenses. Instead, it's an empty array here. Now with that, if we save this and reload, I also get another error. Can't find variable fetched expenses, which makes sense because I removed my state here in recent expenses, and instead here we switch back to expenses context.expenses. So now with that, if we reload, this works. And again, if I reload and I switch back quickly, you see initially there's nothing, but then the data is fetched. And now if I add another new expense here, another test, this also shows up immediately here because we store it in our local context and we send it to the backend, which means it's available locally immediately, which of course also makes a lot of sense and makes the app better because we don't have to wait for fetching that data again from the backend. Instead, we use the data we already have. So that is another major step forward. Now let's see what else we can tweak and improve about this. Now, one thing I want to improve about this app is the way I do fetch my expenses. For example, I added a new expense and it's added at the top here. That's how we built our app. That is the logic we set up in our expenses context. When we add a new expense, we add it at the beginning of this array. However, if I force a reload here and I switch back, you see that latest expense is now at the bottom. The reason for that is that on Firebase, they are stored in chronological order, so the newer expenses come at the end, and we have the older expenses at the beginning. So here it's not the date that matters, but simply the time at which we added the expense, no matter which date we set. So it's the opposite logic of what we had before. Now I would like to make sure that we keep the order we set up before. And we could do this in this set reducer case where we do set our expenses to the fetched expenses. Instead of just taking the fetched expenses like this, we could transform them and we could change the order. Now, changing the order is rather straightforward. We can get our inverted array by taking the original array, which will be in our action payload, and calling the reverse method on it, which is built into JavaScript and which can be executed on arrays. And then it's this inverted array here. With that, if we save that and reload, our data is fetched again, but now it has the same order as it had when we started to add our expenses. Now, another change I want to make is also here in this reducer, and that is related to this ID. We did generate our own ID in the past, but please remember that I mentioned that Firebase builds real unique IDs for us. And of course we should use these IDs because we also will need them later when we delete or update items. We need to be able to target the correct expenses on the backend then. Now if we build our own IDs here, when we add an expense, that will be a problem because this code is still relevant because we do still add expenses to the context when we do add them, and we do still use our context in the app for all the reasons explained in the previous lectures. Therefore, instead of creating our own ID here, we should get rid of that and use the ID returned by Firebase. So actually, I expect my action payload to be the full expense object that already contains a good ID. And with good ID, I mean the ID generated by Firebase. That implies that we need to get hold of that ID when we send a request to Firebase, when we send an expense to Firebase, to be precise. So here, when we post a new expense, we need to get the ID that was generated by Firebase. Now, thankfully, Firebase gives us that ID in the response to this request. So therefore, we need to work with that response, and hence I will again use async await here to get that response. And then it's in this response data where we find the generated ID. Now, the property in the data object that holds the auto-generated ID is not called ID. Firebase didn't decide to use that name. Instead, there will be a name property that holds the auto-generated ID. You can find information like this in the official docs or simply take it from me here. So that's the ID generated by Firebase. We get it as part of the response when sending data to Firebase. We can then use this ID, of course, because now we can return this ID here so that our store expense function returns a promise, because it's async, which will then resolve to that ID in the end. That means that in manage expense, where we do actually call this function, this store expense function, we will get back the ID here. For this, I will transform confirm handler into an async function so that we can await this here as well, because store expense will return a promise, as I just said before. And then eventually we will get that ID to which that promise resolves. And when we then call add expense, we pass an object to add expense that gets all the expense data we got from the input fields, but where we also add an extra ID field which holds that ID we got back from the backend. So this ID is now also part of the object that we send to the context. So that is now another important step for using the right ID. And with that, if we save this, we are still able to add something here. And here I will now pick a different date so that it shows up under all expenses. And this will now have gotten the proper ID, the ID managed by Firebase. So that's another important step forward. As a next step, we can now make sure that we can also update and delete our data on Firebase. So let's now work on updating and deleting our items on Firebase. Now, for this, we need more functions here in HTTP.js. And to be precise, besides fetch and store, we also need a function that could be called update expense, and another function that could be called delete expense, because that is what those functions will do. Now, both functions will be exported and will be async, since we will be working with promises in there, and I want to use async await. Now let's start with updating. Here the expectation would be to get the ID of the expense that should be updated on Firebase, and then the updated expense data. And to update data on Firebase, we need to send a put request. So we can use Axis and the put method to do that. And then we use our backend URL as we did before. But now the URL which we target, or the segment that comes after this root URL that we target, is slightly different. It's no longer just expenses.json, because now we actually want to target one specific expense. And when working with Firebase and the REST API exposed by it, we bake the ID of the expense we target into this URL. So actually here I'll use a template literal and target expenses / and then the ID.json. And ID, of course, should not be the word ID, but instead the actual ID we're getting, which we can inject into this string, into this template literal like this. Please note that we use backticks for creating such a template literal in JavaScript, not regular single quotes. So this will now send a request to /expenses / the ID of a specific expense.json. And as a second argument, we still provide our expense data with which the expense should be updated. This should be an object with date, amount, and description, not with the ID. Otherwise, we would add the ID as another nested field inside of that element here. And on Firebase, the ID already is the key here. So we only need amount, date, and description in that data that we're sending to this specific ID. That's where the ID is on Firebase. And that is already all, actually. I don't even need to do anything with the response here, and therefore we can actually just return this and get rid of async, so that we return the promise returned by put, so that if we would need to work it, for example to show a loading spinner, which we will do later, we could get hold of the underlying promise in the component that wants to show the loading spinner. Here for the moment that's all. That's why we could remove async, because we're not using the await keyword, and I'm just returning the promise like this. And actually for delete expense it will be the same. We don't need the async keyword there either, because I will also just return the result of calling some Axios method here. And here it's the delete method, which will send a delete request to a given URL. And that is what Firebase wants to delete a certain item. Now here the URL to which this request should be sent is the same URL as for updating, because we want to target one specific expense by ID. Therefore, of course, we must get the ID as a parameter here. And we don't need a second argument here, because deleting is just about deleting. There is no extra data that needs to be sent along. And therefore those update and delete helper functions can be very simple, as you see. Now we can use them in the manage expense screen component here. Here, when we update an expense in our context, we still want to do that, but in addition, we also do want to send a request. So I will actually call update expense here as well, which is a function that is imported from my util HTTP file. We can also already import delete expense here as well, because we will need that in a second as well. But now we get update expense here, and I will execute this after updating it in my context, so that I immediately update it locally, and I then also send it to the backend, so that I got my updated data there as well. So you could say that we're doing some optimistic updating here, because we updated locally first, and then we send the updated data to the backend. For adding, we can't choose that reversed order, because there we rely on the response of our request to get the auto-created ID. But for updating, we can update locally first and then send the request. We could also await this here, but it doesn't matter too much in this place, because at the moment we're not doing anything once we're done sending the request. Still, for completeness sake, I will await, so that we actually only close the modal and we only go back after the update request succeeded. I guess that is the one thing we are doing after sending the request, so awaiting for the response does make sense here. Now, as a last step down here, we just need to pass our expense data to update expense, so that we do have that data that needs to be sent. And as a first argument, we actually must provide the ID, because that is what we do expect here in this update expense function in HTTP.js. And therefore, I actually do pass my edited expense ID as a first parameter value to this update expense function here as well. And now we can go to the delete expenses handler, and there we can also call delete expense from that HTTP helper file, pass our edited expense ID to it, and maybe turn this into an async function, so that we can await this before we continue with the local updating and with closing the modal, though here we could also update locally first before we send a request. It's up to you which order you want. Now with all of that out of the way, if we save that and reload, we do load our data. Now I could select the test here, add a couple of exclamation marks and increase the amount and click update. And then this is updated here, but it's also updated on Firebase, as you will see. Here it is. We have the exclamation marks and we have the higher amount. So that worked. Now we can also delete it select it, click the trash bin, it's removed here, and on Firebase, it's also gone. We just got the other expenses here, but the one we just edited with the 199.99, that is gone. So updating and deleting also works. As a last step, we can now work on the feedback that we give to the user whilst a request is on its way. We might want to show a little loading spinner whilst the request is on its way, and we also might want to show some error feedback if something goes wrong. So let's show the user some feedback when a request is on its way, some loading spinner, for example. And we can start in recent expenses. There, at the moment, we start fetching expenses, but you see that if you reload the apps, initially you see that text that there are no expenses briefly before the data was loaded, and that's not the best user experience. I would rather show some loading spinner or some loading overlay whilst we are fetching, and then show the results once we are done fetching. To achieve this, we can build a new component, maybe in the UI folder, which I will name loading overlay. So in the loading overlay.js file, I will add a new function, loading overlay, and I will export this function here as a default, loading overlay. Now in this function here, I want to return a view imported from React Native. And in that view, I want to show a little loading spinner. That loading spinner is also already built into React Native, and that is the activity indicator, which gives us a platform adapting loading spinner. So we can use that as a component here, and then set a size prop, which wants large or small as a value, and here I'll go with large, and give this a color, and here I'll just use white. There are more configuration options, and as always, the official docs are the best place to learn all about it. But this will render a loading spinner that automatically has the appropriate look based on the platform on which you are using it. Now I also want to add some styles here, so we can use style sheet from React Native and create a style sheet here. And then I just want to set up a little container style for this view that holds my loading spinner. And I want to set flex 1 here so that this view takes all the space it can get. And then set justify content to center and align items to center this loading spinner horizontally and vertically. I will also add some padding in all directions and give this a background color of global styles.colors.primary 700, a dark purple color. Of course, global styles is my own styles file and is coming from my own styles file, and I'm importing it from there, therefore. Now on this view, we can add the style prop and set this to styles container. And now we can use this loading overlay to show it whilst we are loading data. We can do this in recent expenses. Now to know whether we want to show that or not, we now do need some state there. Because even though we're managing the expenses, still with context, I want to have some local state in this component to find out whether we are currently loading data in that component or not. So I will re-add use state, which is imported from React. And here I have my isFetching state and a setIsFetching state updating function. And initially that can be true because we know that when this component is loaded for the first time, we will be fetching. Therefore here in useEffect, we actually also can of course set isFetching to true as soon as we start, though technically this wouldn't be needed because we have set it to true as a default. But then, and that's the important part, once we're done fetching, so after this line of code, once we have our expenses, we can set isFetching to false because we're not fetching anymore. And this, of course, this line here might take a bit longer because that is where the actual request is sent and the response is received. So now we have this isFetching state, and we can use this state to show our loading overlay. We can simply check if isFetching is true somewhere in our component function outside of the effect. And if this is true, I will return different JSX code. Not the JSX code down there, not the expenses output, but instead my loading overlay. So this component we created a couple of minutes ago. Loading overlay, of course, must be imported from our loading overlay component file. And then I return that here. With that done, if we save this and we reload, now initially we see that loading spinner for a fraction of a second, because Firebase and my network here is really quick. But we initially see that loading spinner, and if you watch closely, you see different spinners for the different platforms. So that's how we can add such a loading spinner here. And I also want to add that when we send a request. Of course, you can also try adding this on your own. Here's a short pause which I give you to pause the video and try this on your own. And thereafter, we will implement this loading overlay in this manage expense component as well. Did you succeed? Let's add the loading overlay together now. In manage expense, we got a couple of different actions that send requests. We can add or update an expense, and we can delete an expense. And in all those scenarios, I want to show my loading spinner. For that, we manage some state here in this manage expense component, and hence we use the use state hook, which is imported from React. And then I have my is submitting state. The name, of course, is up to you, but here I am submitting data or sending some kind of request. And initially this is false, because initially we're not sending data. Initially we're gathering data from the user through the user inputs. But I want to set this to true if we do start sending an expense or updating an expense, or if we are sending a delete request. So therefore, in the delete handler here, for example, I want to call set is submitting and set this to true before we start sending the request with this line of code. And then after this line of code, we can set it back to false, though we don't need to do that actually, because we are closing this screen anyways by going back. So there's no need to update this state then. But we do want to set it to true initially here. Now we can then use this is submitting state in exactly the same way as we did it in recent expenses. Instead of returning the regular JSX code, I check if is submitting is true, and if it is, I return my loading overlay, just as before. And just as before, loading overlay, of course, also is imported. That import must be added. So now when we delete, we should see this loading overlay. Before we check this, let's also add the logic for updating and adding. And in short, this only means that when the confirm handler starts to execute, that we then want to set is submitting to true, because we will be sending either this update or this adding request here. Now again, we can set it back to false thereafter, but since we closed the screen anyways, we don't have to do that. Now with all of that done, if we save that, if I now add a new expense for 29.99, this is new. We see the loading spinner here. We see the item here. If I update this, we see the loading spinner before this closes. And if I delete this, we also see the loading spinner briefly before it closes. And of course, the requests are still sent to Firebase as they were before. So that all works as before, but now we reflect that loading state in our user interface. And that is how we can add such a loading state to React Native. In the end, it works just as in a regular React app. We're just also embracing native features and components like this activity indicator here. Now, adding a loading state is nice, but things can also go wrong. To simulate this, we could, for example, add a typo in the URL. Of course, that is an error we typically would fix as a developer, but I can do this to simulate that sending a request fails. It could fail because of internet connectivity, because of a problem with Firebase itself, or a couple of other reasons. Therefore, I deleted the dot here to make this URL invalid. And if I do that, and if I reload, you will notice that now we have this loading spinner forever because, well, fetching the data fails. I also get a warning that we have an error, a promise rejection, which wasn't handled. And indeed, that is exactly what I want to do. We should handle this promise rejection, and we should show more meaningful feedback to the user when things go wrong. And to achieve this, we can add another overlay as a first step. We could name this error overlay. And of course, using these overlays is just one way of giving the user some feedback. You can manipulate the UI in whichever way you want. This is just an example. Here, however, I want to use this error overlay, and for this I'll copy the code from loading overlay and copy it in here. We could also create a shared base component, but to keep things simple, I'll just copy and paste. And then we have the error overlay component here, where I don't want to have an activity indicator, but instead some text. So using React's text components, React Native's text components. There I want to say an error occurred, like this. And I want to have another text component where I then also output a specific message. For this, I expect to get a message prop here. And then we can output this message here so that we can use the same error overlay for different messages. And I want to give the user a button using my own custom button to confirm this and close this overlay so that the user is still able to interact with the UI and maybe use other features of the app even though one specific HTTP request failed. For this, I expect to get a onConfirm prop here, and I will bind this to my button. So that could be my error overlay. Now I also want to add some styling for the text, so we'll add a text style object here, and actually text align it to the center, and add a margin to the bottom of 8. This will be applied to both texts. Then I want to have a specific style object for the title and one for the message. For the title, I simply want to set the font size to, let's say, 20 and the font weight to bold and set the color to white, though that should be the case for both texts, so I will actually add this to my text base style object here. For message, I will set the font size to 14, though that is the default anyways, and actually therefore message doesn't need any specific styles. But now we can add these styles, and the first text here will receive an array of style objects where I have my text base style and then the title style, and the second text, the message, receives just the base style. So now we got this error overlay which we can use. And we can now use that in the places where things can go wrong, like in recent expenses. But how can we use this overlay there now? Well, just as we used the loading overlay in the end. We need to manage some extra state, some state that tells us whether we have a problem or not. And therefore, I will name this state here error, and setError is the state updating function. Initially, it's undefined because initially we have no error, but we can set this to some message, for example, some error message, if things go wrong. Now, the place where things can go wrong is here. There we can use try-catch now, since we're using async await. This works together with try-catch to try executing this code, and if it fails, we will end up in the catch block. I want to set is fetching to false outside of this catch block, by the way, because even if things fail, I still want to leave my loading state thereafter. That's why I'm setting this outside of the try catch block either way, no matter if we have an error or not. But here in the catch block, we can then set our error to an error message, and that could be a message we get from the backend or a hard-coded message like could not fetch expenses. And now we can use this error state to show the error overlay. As a side note, by the way, I only want to set my expenses in the context if I fetched them successfully, so that code, where we set expenses in the context, should go into the try block. But now with that, we can use the error state to show the error overlay, and therefore, we can check if we have an error and we are not fetching, let's say, then I want to return my error overlay here. Now for that, the error overlay also needs to be imported, just as the loading overlay was imported. And then on that error overlay, we can set our message, which is my error state, because I do save my message here in my error state. And I will add this on confirm prop to be able to close this error overlay. For that, we could add a function here, error handler, where I basically set error back to null to clear the error, and that will remove the error overlay. Like this. If you want to have this button or not is up to you, but here I will add that. We could, for example, also try to fetch again when this is pressed. So we could then again call fetch expenses. This is all up to you. If I save this now and reload, we get this error overlay, and I can click OK to close it. Now the app doesn't really work then, and therefore we might want to refetch expenses when that button is clicked, or get rid of that button entirely if the overall app doesn't make any sense in case of an error, but I wanted to show you how you can control this overlay and which features you could add to it. So that's the first place where this can be used. Of course, we can also use it in Manage Expense. You can also try implementing it there on your own first. In a few seconds, we'll do it together. So let's now add error handling to Manage Expense together, and it works, as you learned, pretty much as managing the loading state worked. In Manage Expense, we add our new state here, the error state, with the set error state updating function. And initially it's an undefined state because we have no error initially, but then we want to add error handling in the different places where we are sending requests. Like here with deleting. We can again try catch here, and then set our error to could not delete expense, please try again later, for example. Now, very important, we only want to close the screen and delete the expense in the context if this succeeded, so we want to move this code into the try block, because this won't execute if this line of code failed then. I now also do want to set is submitting back to false here in the catch block, because in that case we stay on this page, and if we then clicked the OK button on the error overlay, I don't want to show the loading overlay instead. So now with that added, we can of course also check if error and not is submitting, let's say. And in that case, just as on the other screen, we return our error overlay, where we set the message to our error, and on confirm can be used to clear this error. So again, we can add our error handler function here, where I set error to null, like this. And we point at the error handler here. So with that, we're handling errors in case of deletion. Now to handle errors for updating and adding as well, we also want to add try catch here. And for this, we can wrap this overall if check with try, and then catch any errors that might have been caused from there. And of course, only go back if we are still in the try block, so if we did succeed. And in the catch block, I want to set error and set this to could not save data. Please try again later. And here I then also want to set is submitting back to false so that we don't show the loading spinner thereafter. So that's how we could handle error handling in case of saving or updating data. Now, to see whether that works, we can go here and try adding a new expense with our problematic URL. So this should actually fail. And indeed, I get this error here. I can confirm this and I could try again thereafter, but I got the error. Now my input data was cleared in between here, as you could see, because this manage expense component function was re-evaluated here, and therefore it wiped all the entered data. Now you could save that entered data in some state that is then used once this error handler function executes here to keep things simpler. And since this OK button doesn't make a lot of sense in this app anyways, I will get rid of that error handler and this onConfirm prop and the OK button on the error overlay. I just wanted to show you that you could add something like this. Here we will get rid of it and get rid of the OK button in the error overlay therefore, and also get rid of the onConfirm prop and the button import. But with that, you now see and saw how you can also handle errors and show error messages to users, just as we did it with the loading spinner before. And with that, I will actually fix this URL again so that this app works again. And now we can again fetch our data and also update our data and do all these things we did before. So that's it for this application here. We now did add HTTP requests, and you learned how you can send HTTP requests, in this case with a third-party library. Though, as mentioned, you could have also used the fetch function, which you might know from the browser. And you did learn how you can send different kinds of requests, how you can use and transform response data, how you can talk to a dummy backend, like in this case, Firebase, but of course the same approach would be used no matter which backend you're using. And you learned how you can trigger those HTTP requests from inside your components, how you can handle loading and error states, and how you can therefore overall build an app that does not just work locally on the device, but that instead also utilizes a backend API. Throughout this course, we of course did learn a lot about React Native and about building React Native apps. But one key feature which you might need in many React Native apps or apps in general is missing, and that would be user authentication. Adding login, sign up, and in general the management of the authentication status of a user to a React Native app. And that's therefore exactly what we're going to explore throughout this course section. You are going to learn how you can add user sign up and log in to an app, and I will provide an example app to you which we'll use as a starting point to then add all these login and sign up and other functionalities to it. You will find that starting code snapshot attached to the next course lecture. And then in this section, we're also going to see how we can manage that user's authentication status. So checking whether a user is logged in or not, how we can manage that in our app, and how we can also use that to communicate with protected resources that might be exposed by some backend, by some API. You're also going to learn how the user authentication status can not just be managed in memory, but also how it can be stored on the device, how it can be retrieved from there, and how that can be used to automatically log a user in if he or she visits the app again after having closed the app before. That's what we're going to dive in throughout the discourse section. As mentioned, we're going to start with a provided demo project, which you'll find attached to the next lecture, and therefore let's dive right in. So here I am with that provided demo app, and as a first step, I want to quickly walk you through the provided application. In app.js, I'm setting up some navigation. That is the most important thing, I would argue. And to be precise, I'm setting up some stack-based navigation. And actually, I have multiple navigators. One that holds my screens that are for unauthenticated users, so the screens that allow users to create accounts or log in. And one stack that only holds one screen, but could hold multiple screens, that should only be accessible by authenticated users, so users who have logged in. And we will work with that stack later in the course section. For a start, in my navigation container, I only use the auth stack, so I only activated the stack navigator that has these screens for unauthenticated users, but later we will learn how we can blend in the authenticated stack as well. If you have a look at those screens, the welcome screen is that screen that should only be accessible to authenticated users later, and it's a super simple dummy screen with nothing special on it. And the login and sign up screens are also super simple, though we're going to add some logic to them throughout the discourse section. But in both screens, I am just rendering the auth content. In the login screen, I am passing an extra prop to auth content, though, the isLogin prop. Now, if we have a look at the auth content, we can find this component in the auth folder, in the components folder. And in there, it's a regular functional component that in the end renders this auth form and then also a button below the form that allows us to switch between the login and the sign up screen. At the moment, this button does not work, but that is a functionality we are going to add throughout this course section. Now, if you have a look at this auth content.js file, you see that I am doing some credentials management there. I am checking whether the entered credentials are valid, so the data entered here. And for example, if I submit this in an invalid mode, I get this warning and I get some highlighted inputs here in this authentication form. And in the end, this is of course comparable to what you learned in the user input handling course section earlier in the course. Now you can dive into the auth form.js file if you want to. There I have a bunch of custom inputs, which are basically wrapped text inputs here with multiple props accepted for configuring them. And you could also build those inputs slightly differently, as I did it in the course section about handling user input, for example. But in the end, this is a form with multiple inputs. Then we're handling the form state, here in this case with multiple state slices for the entered values. And there isn't really anything fancy in here if you go through this component. It's not the focus of this course section. In the UI folder, you also find some buttons and a loading overlay, which I prepared so that we can use that to show a loading message and a loading spinner whilst we are sending some HTTP requests, which we are going to do later in this course section. Because for logging in and signing up, we will have to talk to a backend that validates the authentication status of a user. And that actually is a good transition to the next lecture. How exactly does authentication work, and which parts do we need to add authentication here? So, how does authentication work? Well, you have your app running on a mobile device, and for authentication, you also need a backend API like the Firebase dummy API we used before in the course, or any other API. You need a backend because on that backend, we want to validate the credentials, the email and password entered by the user. We can't do this on the phone because the user data is stored in a database that is not part of the phone, but instead on some backend. Therefore, once a user fills out a form, an authentication form, and enters his or her email and password, those credentials are sent to the backend API with a HTTP request, and then on the backend, those credentials are validated. So on the backend checks whether that is a valid email address that was registered and whether a valid password was entered. Or if a user is created for the first time, the email will be validated if it is a valid email address, and the password will be validated if it is long enough, and so on. And then a user is created, or if it was created before, we simply confirm that the credentials are correct. In addition, once the backend determined that the credentials are correct, it also typically generates an authentication token. Now, this token is in the end just a string, just a bunch of text, which is created and signed by the backend and which can't be faked. And this token is sent back to the phone. So this string, which can't be faked, which can only be verified by the backend because it was created by the backend, is sent back to the phone. This token is important because on the phone we know that if we have a token, that validation succeeded, and this token will be required for future HTTP requests that might be sent to the same backend to other resources on that backend, to other endpoints of that API that might require authentication. If a request would be sent to a protected API endpoint, this token would be added to the request by the phone, and the backend could then verify that it's a valid token and grant access for those future HTTP requests. Therefore, this token is stored on the device because then we have something that proves that the user is logged in, and we have that token for future HTTP requests to potentially secured resources, so secured API endpoints. That's the theory, and we're going to see all these different aspects in action throughout this course section now. So as we learned in the previous lecture, to implement authentication, we need a backend because the user details will be stored on that backend, and the backend will then be used to verify and validate entered credentials and generate that token, which then might be needed for future requests to other resources provided by the backend. Now, earlier in the course, we used Firebase as a dummy backend, and I'm going to use it again here because Firebase also helps us with implementing authentication without writing any backend code. You could build your own backend and write your own backend code, and I do have courses that teach you how to do that. For example, my Node.js course, if you want to write your own backend applications, but this course is about React Native. So we're not going to dive into writing our own backend code. Instead, we're going to use this dummy backend here, which does all the heavy lifting for us, and we're going to use Firebase. Now, earlier in the course, we used the real-time database for talking to routes that give us access to data and that allow us to store data. Now we're going to use authentication. As a side note, authentication can work together with the database because we could protect the resources in the database and only grant access to them if a user is authenticated. That would require this token I mentioned before. But as a first step, we therefore have to enable authentication and implement authentication so that users can be created and can be logged in so that we can get such a token. Otherwise, we can't do anything else with potentially protected resources. So we go to the authentication area here on Firebase and we get started with authentication there. And I'm working in the same Firebase project I created earlier in the course. You could also create a new Firebase project here. Now, here you get various authentication providers because you could also implement authentication that utilizes Apple or Facebook authentication under the hood. And if that is something you're interested in, you should definitely check out the official docs provided by Firebase. Here, we're going to use a basic email password flow, which means that users are created with an email and a password, and that we log in with the email password combination. So I clicked on that, and then I enable this flow. We don't need that other option here, and then I click Save. Now this is enabled, and now we can use Firebase to create users and also to log users in thereafter. Now, when it comes to working with Firebase and with this authentication feature that we enabled, there are two main options. You could use the Firebase SDK, which is a third-party library you can add to your code, and that might be more convenient, but you can also use the Firebase REST API for sending requests to certain API endpoints provided by Firebase for creating users and logging users in. And I will use this approach instead of the Firebase specific third-party library Because if you're bringing your own backend, you will also probably be sending HTTP requests to that backend yourself. You're not going to use some third-party library that hides the difficult parts from you. Therefore, we're going to build everything here from scratch ourselves, but if you would really be working with Firebase only, using the SDK might be more convenient. That's just a side note. But to show you a more generic approach, we're going to use this REST API. And here, if you search for Firebase Auth REST API, you should find this documentation page. And there you find various ways of using the API. And we will need to sign up with email and password and sign in with email and password. So these two parts, these two ways of using the API will be important for us. And if we, for example, click on sign up with email and password, since that will be the first feature we implement, since that will allow us to create new users, we see that we need to send the HTTP request to this URL, that we need to provide some data to this request, so that we need to set this as a request body, and that we will get back some data. And here we can already see this token, which I mentioned on the slides. This is this token which will prove that a user was created and authenticated successfully. And later for signing in, we're going to use this URL here. We're going to also attach some data to the outgoing request, and we also will get back some data, including this ID token here. So that's the API we're going to use. And as a next step, I want to make sure that we can sign up. But in order to be able to do this, we first of all need to work on our app a little bit. Because there we actually start on the login screen. And at the moment, we have no way of getting to that sign up screen. And therefore, that is the actual first step we're going to work on before we thereafter start sending those requests to create users and log users in with help of our backend. So as a first step, let's make sure that we can actually switch to the sign up page here. Now, to make sure that we can do that, we need to go back to our code and actually work in the auth content.js file. Auth content.js, because in that file we get this flat button, so this custom button, which says create a new user or log in instead. And that is this button we see here below the form. Now I want to make sure that when this button is clicked, we switch to the sign up form, and if it's clicked on the sign up form, we switch back to the login form. Now, to implement this, we already have a switch auth mode handler, which is triggered when this button is pressed, but this switch auth mode handler has no code in it. Now, thankfully, switching is pretty easy though. We are getting a isLogin prop in this auth content component, and you might remember that this isLogin prop is set here in the login screen component, but not in the sign up screen component. So it's false for the sign up screen, but true for the login screen. And therefore this isLogin prop is true or false, and it can be used here to find out to which page we want to navigate, to the sign up or login page. So here we can check if isLogin is true, and if it is true, we know that we want to go to the sign up page instead. Now to get to the sign up page, we can use the navigation API from the React Navigation package. Now we don't get the navigation prop here in this auth content component because this is not a screen component. It's used in a screen, but it's not loaded as a screen. But you learned how you can still get access to the navigation object in components when working with React Navigation, which we are in this app here. You can use a special hook provided by React Navigation. So from @React Navigation /native, we can import the use navigation hook. And then this hook can be executed here, and we get hold of the navigation object. And this navigation object is important because this navigation object gives us methods for navigating around. For example, earlier in the course already, we saw that we can use the navigate method here. Now, if we have a brief look at app.js, we see the names of our pages, of our screens, and we see that the login screen is named login and the sign up screen is named sign up. So if I want to navigate to the sign up screen here, I can navigate to sign up like this. And in the else case, if isLogin is false, so if we are on the sign up screen, we can simply call navigation navigate login to go to the login screen. If we do that and we save this, this button will work now and we can switch between screens. So that is working, but I also want to show you an alternative. There is nothing wrong with this flow, which we have here, where we go forth and back, which is nice. But maybe you also just want to replace the current screen with the other screen. So you don't want to have this back button here, even though there is nothing wrong with it. If you would want to do something like this, you can also call replace instead of navigate. It also navigates to a different screen, but it doesn't give you a back button. That's the difference. It doesn't add the new screen to the stack of screens, but instead it replaces the current screen with the new screen. So there is no going forth and back. If you use replace instead of navigate, you still get the animation, but there is no back button. It's up to you what you prefer, which mode you will prefer, but I just wanted to show you this replace method as well, which you can use with the stack navigator here. And with that, we are able to switch between pages. Therefore, we can now reach this sign up page, and therefore we can now make sure that we actually do something if we entered valid data and that we do send a request to our backend to create a new user there. So now we want to make sure that once valid data has been entered here, we send a request to Firebase, and we want to send a request to this sign up endpoint, so to this URL. Now to do that, I will go back to my code, and just as in the HTTP section, I'll add a util folder in which I add an auth.js file. This is not mandatory, but I want to use that file for sending requests simply so that we have that request logic out of our components. Now here in this auth.js file, we can add a function create user. The name, of course, is up to you. And the goal of this function is to send a request to Firebase to this URL here to create a new user. By the way, we see that it must be a post request, so that will be important. Now to send this request, I want to install Axios, this third-party package, which I also used before in the course in the HTTP section. And with that installed, we can use Axios here in this auth.js file, in our util file here. And then here in create user, we can call Axios post to send a post request. And we can grab this URL here, like that, and send our request to that URL. Now you might notice that in this URL we have this API key part. And this is actually a part in the URL that you should replace with your API key. But what is your API key? Well, it's part of your Firebase project. If you go to your Firebase project and you click on this gear icon, you can go to your project settings. And there you get this web API key. We're not building a web app here, but still this is the key we need. So we can grab this key here, and you should of course grab your key, not mine. And then with that key grabbed, you can replace it here in the URL. Now, since we're going to send another request to another URL later anyways, I will already create a little helper constant here, which I name API key, where I store the key, and I will then add it dynamically here to this URL like this, so that I have $key equals and then my API key. That's not required, but it makes the overall URL a bit shorter. So that is the URL we need for sending this post request. If we have another look at the official documentation, we also see that we need to add some data to this post request. We need to add an email, a password, and this return secure token field. Though the latter is simply a Boolean that should always be true. So therefore, we add a second argument to this post method, and that argument is an object. It should be an object because it will then be converted to JSON, which is a data format, automatically by Axios. And here we want to provide email, password, and this return secure token field. Now it's fair to assume that we get email and password as parameters in this create user function, so that we pass this data into this function from wherever we're calling it, and therefore we can then set email to email and password to password to have that data available. We also should set this return secure token field and make sure that you don't introduce any typo here, otherwise you will get strange errors and behaviors later. And you can simply copy that to be super safe and simply set this to true. Now we will send a correctly formatted post request to our backend. Now, just as before in the course, in the HTTP section, we also might want to do something with the response, and in the component where we actually trigger this create user function, we also might want to show a loading overlay, and so on. For those reasons, I will convert this into an async function so that create user will always return a promise that will resolve once we're done in here, and I will await this post request, so that we can store the response here in a constant or variable, and then we can extract data from that response. Now the data will become important later because that will be that token. For the moment I won't extract anything, I will just do nothing here. But by using async await, we make sure that this function overall returns a promise that will resolve once the request is done. And that in turn allows us to display our loading overlay in the component where this function is triggered. And that is therefore the next step. We want to trigger this function, and I want to do that in the sign up screen. There I want to trigger this create user function. For this here in the sign up screen, we can add a new function, the sign up handler, let's say. And in that function, we want to call create user. Of course, for that, we actually need to export this create user function as a first step. So export create user here in the auth.js file, and then here in the sign up handler in the sign up screen, you can call create user and import it from the util auth file. Now the sign up handler should be connected to the auth content because that is where we gather all the user input. Actually here in auth content, we do expect to get an onAuthenticateProp. And that onAuthenticateProp will be triggered whenever the form is submitted with valid data. And then an object with email and password will be passed to onAuthentiCate, so to the function received on that onAuthenticateProp. We can utilize that fact by going back to the sign up screen and adding the onAuthenticateProp to auth content and pointing at our sign up handler here, so at this function here. This function will therefore receive an object that contains email and password, as we just saw, and we can therefore use object destructuring to pull that email and password out of this object here. And the email and password we get here will have been validated already because we have that validation code in auth content.js. As a brief side note, Firebase requires passwords that are at least 6 characters long. That is why I have this validation here in auth content. Now, with that said, back in sign up screen, we got the email and the password, and we can now forward this to create user. Now, as we learned, create user returns a promise because we're using async await there, and therefore we might also want to await that promise to resolve so that we can show a loading spinner. Therefore, I'll convert this into an async function as well and await my create user call here. And then we can manage some loading state here in sign up screen with help of useState, which is imported from React. Now here I want to manage some loading state, so I will name this is authenticating and set is authenticating because that's what we're doing. We are authenticating once the form was submitted. And initially that is false, because when the screen first loads, we are not authenticating yet. But once the signup handler is executed, as a first step, we can set is authenticating to true. And once we're done creating the user, we can set is authenticating to false here. Now we also might want to add some error handling, but we'll do this in a second step. For a first step, I just want to send this request and add some loading state management. Now we can use this loading state right here before we return our JSX content to check if is authenticating is true. And if it is, we don't want to return this auth content, but instead I will return my loading overlay component here, which is defined in the loading overlay file. And we need to import this component for that. So import loading overlay from the components folder, from the UI folder, and then the loading overlay file. And this loading overlay component wants a message prop, which is shown on the screen. Therefore, actually here, we want to set this message prop and set it to any message of your choice, like for example, creating user ... Now with that, we should have the basics we need for sending a request to this create a user endpoint and for showing a loading spinner whilst the request is on its way. If I now save everything, I get an error. Yeah, because UI should actually be lowercase here. Alternatively, you rename this to an uppercase folder. But with that, if I now save this and I force a reload, this reloads successfully. And now if we create a user, we want to enter a valid email address here. You can of course also test if invalid data is caught, but it should be. And enter a valid password that is at least 7 characters long, so more than 6 characters. And if you then click sign up, you see this loading spinner, and then we go back to this screen. That is the behavior we have at the moment. But now let's check our backend and see if a user was created. For this here, we can go back to the authentication area in Firebase, and you should now see a new user entry here with the email address you chose. It also has an ID, which was automatically generated and assigned by Firebase, and the existence of this user now proves that our general authentication flow, or the user creation flow to be precise, works. Therefore, as a next step, we can work on logging users in and sending a request to that API endpoint. So let's now work on the login screen and on this part of the application so that we can also log our created users in. For this here with Firebase, we have to send a request to this sign in endpoint, which looks very similar to the sign up endpoint, but is slightly different in the URL, but which wants the same data as the sign up endpoint. Now, because we have all those similarities, I will go to auth.js in the util folder, and I will actually add a new function here, which I name authenticate. So not create user or login, but just authenticate. And here I expect to get the mode, the email, and the password. And mode should be sign up or sign in with password. So it should be this segment here, sign in with password, or sign up, because that is the only difference between these two URLs. And by accepting this as a parameter, we can construct the URL dynamically and use one function for sending a request to 2 different URLs. So therefore here we can generate our URL, and the URL is now generated or created here as a template literal, which always starts with this part here, because that part is equal for the 2 URLs. But then we dynamically inject the mode, which should be sign up or that sign in with password part I showed you before. And then thereafter we have question mark key equals, and then our API key. That is also always the same key. So now we have this dynamically generated URL here. And with that, we can send a post request to that URL like this, because we need to send a post request for both signing in as you see here, and for signing up, as you see here. So it's really just that one segment that is different. Therefore, we are sending this request to this URL, and we need to add some data, but we learned that the request body is the same for both URLs, so for signing up and signing in. So we can grab this data object here and add this here. Now we can turn this into an async await function as well and get our response here so that we can use it later. And that is it for the moment. That is all we have to do here. Now in create user, we can simply await calling authenticate, and we pass sign up written like this and email and password to this authenticate method. Sign up must be written like this because it must be written just as it is here in this URL segment. And for sign in, we therefore want to pass sign in with password as a mode. So we can also create async function login, which gets an email and a password as well, because that is the function that will be called from inside a component. And here we also await calling authenticate, but here the first argument, the mode, is this sign in with password, and then we also pass our email and password to this function. And we also want to export login. So I still have two separate functions for creating and logging in, but we have one shared function that has the main logic in it. With that, we can go to the login screen and call our new login function here. And the general approach is pretty similar to what we had in the sign up screen. So actually, we can copy the code from there, and we could also create a shared reusable component instead. Here, I'm just going to copy it to keep things a bit shorter. And I'm going to paste it here into login screen. We now, of course, need to import use state from React, since we're using that here now. And we need to import the loading overlay from the UI folder with lowercase UI, as we learned. And I also want to call login here, which is imported from the auth file in the util folder. And this can be named login handler here. And on auth content, we add on authenticate and point at our login handler. But with that, we should send such a login request. Here as a message, we might want to say logging you in, which is a bit more fitting. But with that, we should be sending such a request now. We are showing a loading screen, and, well, we should be able to log users in. At the moment, though, we don't really have a way of telling whether it worked, because we can't see it on the backend. No new user will be created. So in order to see that it worked, in auth.js, I actually want to console log my response data here in the authenticate function, so that we see something here in the terminal and we can tell that the request was sent successfully. Therefore, if we now save everything again, we can switch to the login screen and enter our credentials. And for the moment, you should double check that you enter the correct credentials, because we have no error handling for incorrect credentials yet. But with the correct credentials entered, if you click login, you actually see here that we get back a response with some data, for example, with that token, which is this long cryptic string which was generated and signed on the backend. We also got some other data, and we will work with that data later, but for the moment, this proves that our login flow is also working. And with that, I think it's a good idea to add some error handling to show the user an error if he or she entered an incorrect password, for example, before we then continue working on the app and we switch to a different screen after a successful login. So it's time for some error handling. For example, here when we're logging in, I could enter an email address which is technically correct, but which wasn't registered on the backend before. Here I have no user on the backend with that email address, but if I try this, well, I get stuck here on this loading screen because we do get an error response actually, and that's why we get this warning here at the bottom. But we don't handle that here on the front end. And that is, of course, something I want to change. We want to handle such errors properly. For this, we can wrap this login function call with try-catch, as we did it earlier in the course in the HTTP course section already. Now we can catch a potential error, and now it's up to you what you want to do with such an error. You could add an error overlay, you could change the user interface, you can do whatever you want. Here, I will simply call alert, so the alert API built into React Native, which we also used before in the course already. And on this alert API, I'm going to use the alert method. This allows me to show an alert dialog, and there we can set a title, for example, authentication failed, and a message that could say, could not log you in, please check your credentials. Or try again later in case it's a technical error. Now you can be more elaborate than that. You could look into the error response data and see which kind of error you got back, because Firebase will be sending back different error codes, as you can learn here in the official docs. So you can show more meaningful error messages depending on the error you got back. But here I'll show this generic error message. And with that, if we save this and we restart, now if I try to log in with an invalid email address, so technically valid but not known on the backend, I get this alert and I can try again. The same happens if I actually enter an invalid password. I get this alert and I can try again. Again, you can improve this error handling, you can handle errors differently, but this shows you how you can in general handle errors and that you should handle them, because unlike before in the HTTP section, here it's not just about technical errors or missing internet connectivity, though that could happen as well, but here it's also about handling invalid credentials. Now you might want to add that same error handling on the sign up screen and wrap create user with try catch here, so that if something goes wrong here, we also show an alert. So for that, I'm also going to import alert here, call that alert method, and then I also say authentication failed, could not create user, please check your input and try again later. Anything like this could be used here to show an error message if signup fails. And that's some basic error handling which I want to add here before we now move on and we now make sure that we do something with that token and with that information that a user was authenticated successfully in case we have no error. Now let's say a user does log in with valid credentials. In that case, at the moment, nothing happens. Sure, we log that response data to the console, but that's just for us during development. That's not really helpful to the user. Now what should happen once a user logged in successfully? Well, for example, I would like to switch from the login or sign up screens to that welcome screen here. So I want to switch to this other stack here, to the stack of screens that are meant to be used by authenticated users. Now, in order to do that, we need to store the information that a user was logged in somewhere in our application. And whenever you want to store data that might be needed in different parts of the app, which could be the case here, Redux or React Context is a good choice. And here I will use React Context for managing this authentication status. Therefore, we can add a store folder, though the name of course is up to you. And in that store folder, we can add a auth-context.js file. And in here, I want to create and manage my auth context, so my app-wide auth state. For that, as we learned before in the course, we can call create context, which is provided by React, to create our auth context. And I will export this because we need this auth context object here in other parts of the app in order to use the context. Now, you learned before that you can set a default value here, which will help a lot with auto-completion. And for me here, in my context, I want to store the token that I get. We haven't used that token yet, but we will soon use it. So I want to store it here. And I also want to add a little helper variable that simply tells me instantly if I am logged in or not. So if the user of this app is logged in or not. And therefore I will name it is authenticated. We could also derive this information from the token, but with that helper Boolean variable here, or property in our context object, we have a quick and easy way of finding out. We also need methods for changing the state, and here I want to add an authenticate method, which I want to trigger whenever a user did authenticate successfully. So when a user signed up successfully or logged in successfully. And we'll need a logout method, which should clear the authentication status, so which should erase the token and so on. Now we will come back to these methods later. For the moment, I just want to set up this base context object here. And now we can add our function here, the auth context provider function, which will be responsible for managing the actual auth context state and which will be used as a wrapper around our app components that want to interact with the context. Therefore, this function will also be exported as a default here, and that is the same pattern as we saw it before in other parts of the course. This component function here will get the children prop because we will return auth context.provider here and wrap this around our children like this. And then we can manage the auth related state here in this function. For that to start simple, I will simply manage this token because this token is a clear indicator that a user did log in or sign up successfully because we only get a token in these two cases. Therefore, we can manage some state here. Of course, that's imported from React. And I will name my state auth token, and the updating function is named setAuth token therefore. And initially it's undefined. I have no initial value because initially we have no token. But now we can add a function here, the authenticate function, which should be triggered whenever a user did log in or sign up successfully. Here I actually expect to get that token then. So I also expect it up here to get better auto completion. And inside of authenticate, we can call setAuth token and set this equal to this token that we're getting. That's the first basic step that we want to perform here. I will also already add a logout function, even though we can't really do anything with it yet. But in this logout function, I simply want to clear the token, so I will set my auth token back to null here. So I will get rid of the token here. And with that done, we can now construct our value object here, which will be passed to all context users. And there we can set the token key, which I defined up here, to auth token, so to our state. And the isAuthenticated helper property here is simply set equal to not auth token, which converts a truthy or falsy value into true or false, which is exactly what we need here. Now we also want to make these two functions available. So here I will add authenticate and point at my authenticate function, and add logout and point at my logout function here, so that these two functions are exposed through context. And then here we can set the value prop on the auth context provider and set this equal to this value object. And with that, we expose our auth context to any part of the app that wants to work with it. Now, to truly expose it, we of course now need to wrap our auth context provider function here, our component, around the root component of our application. And therefore here in app.js, I will actually wrap my entire navigation container with auth context provider, so with this custom component function we just worked on, like this. And of course, for that to work, auth context provider, this component, must also be imported. Now we can use this context, and I want to use it from inside signup and login screen to set the token, so to call this authenticate function in my context in the end. And I then want to use it in other parts of the app to update the UI based on the authentication status. And that is indeed what we will do next. So let's now work with that context. And for this, we can start in the sign up screen. There, once the sign up succeeded, I want to call the authenticate function in the context to pass the token that we received from Firebase to the context, so that we set the authentication status to authenticated in the end. For this, in sign up screen, we of course want to tap into the context with help of the use context hook provided by React, which is imported from React. And we pass our auth context object to use context to tap into our context here, store that in a constant or a variable. And then here in the sign up handler, after calling create user, I want to call auth context authenticate. Now to authenticate, I need to pass the token that was returned by Firebase. In order to do that, we must make sure that we get the token here in this component function. And for that, in auth.js in util, we must make sure that we extract the token from the response we're getting. So here in the authenticate function, in the auth file in the util folder, we get this response. And here we want to get the token, which we can get by diving into response.data. Data is a field provided by Axios on this response object, which is also provided by Axios. And this data will be the parsed response data sent back by Firebase, and that will be an object with the ID token field. How do I know? Because we logged it to the console before, and here we can see ID token. But of course also because we can have a look at the official docs, and we learn that in the response payload, we have an ID token field. So therefore, I know that I get back my ID token here. And we can now return that token as part of this authenticate function. So now in create and login user, where we call this function, we of course also get this token in the end. Here we get the token, and here we get the token. And we can therefore also return the token here. Though that is actually unnecessarily complex, what we can do instead is we simply don't use async await here, and we instead just return this promise, which is returned by authenticate, and that promise will yield that token in the end anyways. So we can simplify this code and just return the authenticate promise, which will yield the token. With that in the place where we call create user or login, we get hold of that token in the end by simply awaiting create user or login, and then in the end here we get our token. And that token can then be passed to authenticate. And the same thing can be done in the login screen. Here we can also use context for our auth context and import both things, get our auth context here, and when we then call login here, we get the token, and that token can be passed to auth context authenticate, like this. Now with that, we're getting the token and we're setting it in our context, and therefore we now know in our context, in our state there, that we have a valid token and that the user therefore is authenticated. Now we can use that information to then update the UI accordingly. And what I want to do is I want to switch my routes here, my screens. I want to switch away from the login sign up screens to the welcome screen. And that is what we will do in the next lecture. So how can we switch screens based on the authentication status? This switching of screens, or to be precise, of entire screen setups and navigators in this case, is sometimes also called route protection or screen protection. It's called screen protection because we want to make sure that under no circumstances certain screens can be reached if a certain condition is not met. For example, we want to make sure that under no circumstances the welcome screen can be reached if the user is not logged in. How is this achieved? By simply putting this screen into its own screen setup, into its own navigator in this case, and only rendering this navigator if a certain condition is met. Please note that initially in our root app component, we only render the auth stack. We don't render the authenticated stack at all. And in our app component, it is this navigation component, this one here, that only renders the auth stack that is being rendered. So initially, there is no way of reaching the welcome screen because this entire component that renders this navigator with that screen is not considered. Now we basically want to use state, our context state, to make sure that we basically swap this auth stack with the auth related routes, the auth related screens, for this authenticated stack, which holds the screens that are for authenticated users. And therefore, once we switched to that different stack, to this different screen setup, there won't be any way of going back to the login or sign up screens, which makes sense because an authenticated user shouldn't be able to go there. He or she is already authenticated. To achieve this, we want to conditionally use the auth or authenticated stack here. To do that, we want to use the context here in the navigation component, and in order to use it here, we actually should move our auth context provider wrapper out of this component, otherwise we can't use the context in this component, and wrap it here around navigation in the app component instead. Now inside of the navigation component, we can now use context, so we can use the use context hook, and we can tap into the auth context here now. So now we imported use context from React here, and we import auth context from the auth context file. And now we can use the context here in the navigation component, get our auth context here, and now conditionally render different stacks. Right here, we can wrap auth stack in curly braces to render it dynamically, and I want to check if not auth context is authenticated, is true. So if we're not authenticated, then I want to render the auth stack, which holds the login and sign up screen. On the other hand, if auth context is authenticated is true, I want to use my authenticated stack. So that other component that is defined in this file that is responsible for rendering the welcome screen. And of course, we could have more screens registered in here that require user authentication. You can have any kind of navigator or screen setup in here. But we're now rendering totally different screen setups and navigators based on the authentication status of a user. And that makes sure that we protect screens against unauthorized access. And with all of that, if we now save everything and we reload all of that, if I go back and I enter correct credentials here, you see we end up on this welcome screen. We also got a warning down here about which we'll take care in a second, but we end up on this welcome screen here. Now regarding this warning, we are getting this because in login screen, I'm setting is authenticating to false here to exit this loading state, but actually I do this at the same time where this screen is removed from the screen because we changed the navigation stacks, and therefore a state update is performed for a component that's not rendered anymore, which React doesn't like. The solution is to only set is authenticating to false in the error case where we don't leave the screen, and that should get rid of the error. We want to do the same thing here for signing up. only do this in the error case and move it into this catch block, therefore. With that, if we reload, if we try this again, we now switch to this page without any error. And please note that this screen switching happens automatically when we switch the navigation stacks. We don't need to call navigate or replace. We shouldn't call it, actually. Instead, by simply swapping the navigation stacks here, we automatically switch to the main screen of the new stack, so of the stack that is now active. And I'm saying stack all the time. The same would be true if you would be using other navigators here. So this is not exclusive to the stack navigator. The idea just is that we swap screens as needed. We also don't have to swap entire navigators, as we're doing it here. We could also just be swapping some individual screens or protecting some individual screens by rendering individual screens dynamically. Here I'm just switching entire navigators to drive home that point that you can do that. Now with that, we are logged in here, and of course the same flow works if we are creating a new user. So if we create a new user with an unused email address, if we would use the same email address as before, we would get an error. Actually, we can check this real quick and use a used email address. Now we get an error. But now if we do sign up here with a new email address, so if we create a new user, we also end up on the welcome screen. And that is how we can protect screens and how we can update the UI based on the authentication status. But with that, we're only getting started. Okay, so now we can log in, or we can authenticate by signing up or logging in, to be precise. What would also be useful would be logging out if we are logged in. And for this here in my authenticated stack, if we are in this stack, I want to show a logout button. I want to show a logout button here in the header, to be precise, and we could therefore add this here in our screen options, either for all screens or for a single screen. Since we only have one screen here, it doesn't really matter. But here I will add a button to this welcome screen by adding the options prop and setting this to an object, where I then add header right. And then, as we did it multiple times before in the course, we can render a button here or an item in general that will be part of the header. For example, the icon button, which is a component I prepared in advance, which can be imported here, icon button from /components UI icon button. And this icon button is displayed here. Now on this icon button, we can set an icon prop, which I will set to exit, which is an icon we can use to have a nice exit icon that signals that we can exit the app, so to say, by clicking on it. I want to set the color to the tint color that should be used. And conveniently, we get this tint color prop here as part of this prop object that we receive in this function. So we can use the tint color here. And we can also set a size, which I'll set to 24 pixels. And then we can add the onPress prop to define what should happen when this button is pressed. And when the button is pressed, I want to log out. Now in the auth context file, we did define this logout function, and we do expose it through our context. And therefore, in app.js, in this authenticated stack, we can of course also use context and use this auth context to get hold of the auth context object. And we can then add a function here where we call auth context logout. Or to make it a bit shorter, we simply point at auth context logout like this, so that this logout function will be called when this button is pressed. And with that, we should be able to switch back to the login and sign up screens after logging in by simply pressing this button. If I reload and I do log in again, we end up on the welcome screen and we see this logout button. If we now press this button, We clear the token, therefore our context updates, and we load that other page stack again, that other stack of screens that is responsible for login and sign up, and we switch to the main screen of that stack since we swapped the navigators in our app.js file. So it's the inverse logic of what we had before, so to say. So that's how we can also log out. And with that, we got this flow implemented. Now we can see what else we can do with this token and how we can manage the user authentication status in more detail. Now, what can we do with this token that we manage in our context? At the moment, we're only using it to find out whether a user is authenticated or not. And that is one of the main use cases, or at least it's a very important use case, but the token also plays another role. This token is generated by our Firebase project here, so to say. And we can also use this token to get access to protected resources we might have on our backend. Now, at the moment, we have no protected resources, but we can change this now. For that, let's go to the real-time database and let's add a new node there. You can also delete the expenses node if you still have that from earlier in the course, or you can keep it, it doesn't matter, we're not going to use it here. But we will create a new node by adding a child here in our database, and I will name this node message and enter hello world here as a string between double quotes. So now I entered this extra data into my database, and this is now not a node with nested data, but instead it is a node that directly holds a string as data. Now I want to fetch that string from inside my welcome screen, simply as a demo, of course. That's not a super useful functionality, but it is a nice demo. In order to do that, we can send a HTTP request in the welcome screen to Firebase to get that node here, to get that value. Now we could create a utility helper file for that, but to keep things simple, I'll send that request from directly inside this component here by using Axios inside of the welcome screen component. Then we can add the use effect hook to execute an effect right when the component is first loaded, so that we send the request when the component is first loaded. And in here, we can then send a GET request to that node, so to that database and then that node we set up here. For that, you can click on message and then grab this URL here. And that's the URL we want to send a request to, though here on Firebase, we also have to add .json at the end. This will now send a GET request. And then I want to use that data to output it here as text. For that, we can manage some state here in the welcome screen component and get our fetched message and update it with set fetched message. And initially that's an empty string. But then here I want to update this once I got back my message. Now for this we could use async await and wrap this into an extra function, because this function, this effect function, should not be turned into an async function. Or we use promises in the good old way by adding then. And then here we get our response in this function, which we pass to the then block. And in this response, we will have a data object, which should hold our message, or which should be our message. So to see whether that works, let's simply quickly console log response data here and not do anything with the state for now. And if we do this and we reload and we then log in again, we should see something here in the console, and indeed we see hello world here. So therefore now we can then call setFetchedMessage and set this equal to response data, so equal to that text we're fetching. And then here in this text, we can output fetched message. If we do all of that and we reload again, what you will see is that it crashed on Android, but we can ignore this for now. If I test this here, we get hello world. And it loads a little bit after the rest of this page because it has to be fetched first. But ultimately, hello world arrives here as well. And of course, this would also work on Android. If we give this a try here and we enter our details there, it also loads. So that's loading this text. But why am I showing this to you? There is nothing new about this. Well, indeed, there is nothing new about this yet. At the moment, we can send this request and get this data just like that because this API, this database API, is not protected. If you have a look at the rules here, where you can control the protection, in the end, we have no rules here that would lock down this database. Even if you don't fully understand this, I can tell you that this grants us access to the database, or to the API to be precise. And if you would be building your own API, you also might have URLs that are accessible to everyone. But you also might want to have certain routes, certain endpoints that are only accessible by authenticated users. Now we do log our users in, but at the moment here on the backend, there is no connection between a user being authenticated and our data here. Because backend APIs like this are stateless, Firebase doesn't store the information that a user did log in. That's why we are getting this token. We can use this token to grant access or to get access to protected endpoints. For that, we need to protect endpoints as a first step though. And here on Firebase, we can do this by changing those rules, for example, for reading. Here, you could add a rule where you say auth.uid is not equal to null. This means that now read requests are only allowed if we do have a valid user ID, so if a user is authenticated, if the incoming request can prove that a user is authenticated, and that UID will be part of that token which we get. We can do the same here for writing and also lock this down. If we now publish those rules, we won't be able to fetch our data without proving that we are authenticated. So now if we reload here, and we quickly try this again, we can log in, but now Hello World is not showing up because this request fails, as we can also tell by this warning which tells us that some error wasn't handled. And that's the problem we can now also solve with this token. Because if we attach the token to this outgoing request, we can prove to Firebase that we are authenticated. Firebase will then have a look at the token, validate the token, and extract information like the user ID from the token, and then grant us access if the token is valid. If it's not, we don't get access. And how can this be achieved? How can we add the token here? Well, in Firebase case, we simply have to add the auth query parameter here to the URL. For other APIs, it might be different. You might need to add a header, but here we just add the auth query parameter and set this equal to our token. Therefore, we need to get our token here with use context and auth context. So we have to import these things. We have to get this data here in the welcome screen, and then we can use our token here. We can get our token by accessing auth context.token, add it as a dependency here on useEffect because we're going to use it here. Here we're going to add it at the end of the URL by simply adding it to it like that. Now the token is added to the URL with that query parameter, this auth query parameter, and that token therefore is sent to Firebase, and that token will then prove that we are authenticated. If it's valid, which this token will be since we are storing and using the token provided by Firebase. If we now save this and reload, and we try this again, here if we log in, I got an error because this is not auth context, this should be auth context, not auth content. Auth content is a component. This should be auth context. So now we should be able to tap into the context. But now with that, if we save this and we try to log in here, this works, and now Hello World is fetched successfully again because now we're sending along that token that proves that we are authenticated. And that's another important role that token plays. It's not just used in our app to find out whether a user did log in or not. It is important for that as well, but it's not just that. Instead, it's also used on an API to find out if a request is coming from an authenticated user or not. Because typically, REST APIs don't store that information. They don't know if any random app's user is authenticated or not. Instead, you have to send the information that you are authenticated, that token, along with the request that is targeting a protected resource. Like our API here, which is protected because of these rules. Now, these rules are Firebase specific, but the general idea is the same for all APIs. The token is your ticket to get access, and that's why we are managing it on the front end, and why we don't just use it to find out whether a user is authenticated, but why we also attach it to outgoing HTTP requests. Okay. So now we can use this token to log in, to get protected data like this hello world text, which we used as a demo here. And we can also log out to clear all of that. With that, we're basically finished. We got the entire flow implemented, but we have a problem now. What if we did log in like this, and we then close the app? If I now close the app here on my iPhone simulator, and I then restart my app thereafter, I actually do start on the login screen again, like this. Because this token and this authentication status is only stored in our context and therefore in memory. Now this works while the app is running, but as soon as it's closed and reopened, the state will be lost. And of course, most users won't keep on using our app forever. They will quit using it at some point and come back later. Now, therefore, you might want to store that token on the device and not just in memory, so that you can load it when the app starts up again and you can auto log in the user, so to say, if a token was stored before. Now, how could this be achieved though? Well, the first step is to store the token when a user does log in. So here in the authenticate function, in our context, we don't just want to update our state here. We do want to do that, but not just. Instead, we also want to store the token on the device. Now, for storing the token on the device, we can use an extra third-party package. You can search for React Native Async Storage to find a third-party package which you can use. It's actually also still built into React Native at the point of time I'm recording this, but you should now use one of these third-party packages like the @React Native Async Storage package here. Now you can learn more about this package on its official page and the documentation, but in the end, this is a package which you can install, which allows you to store data on the device, and it will store it in different ways for Android and iOS. But most importantly, it will do all the heavy lifting for you. It's super simple to use thereafter, and you don't have to worry with interacting with the device storage itself. Therefore, we have to install this package here, and that is what I will do. I will run npm install here to install @React Native -async -storage and then the async storage package, so the package I just showed you. And with that installed here, in auth context, we can import async storage from that package like this. And once it is imported, we can use this package in the authenticate function here. There, besides setting our token, we can use async storage and call the setItem method on it. This will store a new item in the storage, and that's exactly what I want to do here. Now, when calling setItem, you need to give that item a key, for example, token, which you can then later use to retrieve or delete that item. The second argument you pass to setItem is the item you want to store, and that should always be a string. So if you have a non-string value like a number, you should convert it to a string first. An object could be converted to JSON, which is a string. Token, however, is a string already, so we can just store it like this. So now we store that token here in our async storage, and now we can also use it when the app loads up to see if we have a stored token. So for that, we of course also want to make sure we run some code whenever the app does start. And we can therefore simply run some code here in the auth context provider whenever this provider component is created. Because since we're using that directly in our app component, we know that the provider component will be initialized when the app is initialized. Therefore, to run some code here when this component is loaded, we can use useEffect, this useEffect hook provided by React. We provide an effect function and our dependencies array for that. Now, the dependencies array can be empty here for the moment, and in this function, I now want to use async storage to get an item by key. And the key should be the same key as before, so in my case it's token here because it was token down here. Now this will give us the token, but what's very important to understand now is that getItem will actually return a promise. Therefore, I will add a helper function here, which I'll name fetchToken, which is async, so that inside of this function we can use the await keyword in front of async storage getItem. And this will then eventually give us our token by fetching it. So our stored token to be precise. And then we can call fetchToken here in our effect function. So this will then eventually give us our stored token, which is retrieved from async storage. And if we did find such a token here, we can then update our state. So we can now check if stored token is truthy, and if we did find one, we set auth token to our stored token. If we did not find one, no token was stored, and therefore we of course also don't set our auth token to it. So we only auto log in the user if we did find a stored token here. Now with that, we should be able to save this and reload. And if we now log in again here, we of course switch the page, but if I now close my app here and I then restart it, we should be able to move forward to the welcome screen automatically because we are logged in automatically. Here we go. Now what you will notice, of course, is that briefly we saw the login screen because that was actually the first screen loaded before fetching the token finished. Now to avoid this flickering, to get rid of that, what we can do is prolong the loading screen of our app, the splash screen, until we tried to fetch a token. To achieve this, we can cut useEffect and remove it from auth context provider, and instead add it here in app.js in the app component. And of course, therefore, make sure that you import useEffect from React here, and that you also import async storage here in this component. And then here in the app component, we of course can't call setAuthToken like this, but instead we want to update our context here. Now, since I am in the component here where the context is provided, we can't tap into our context here though, and therefore a workaround here could be to add another component, which could be named root, where we actually have that code, and where we then actually return our navigation. So where I return navigation like this, and it's the root component which we render here between auth context provider. And therefore in the root component, we can use our auth context and get our auth context here. And now we just need to authenticate the user, which we can do by using auth context authenticate, to which we forward our stored token. Just as we did it for logging in manually. Now we're doing it with the token we fetched from async storage. Now, the advantage of this approach is now that we can now use the app loading component, which you saw earlier in the course already, to prolong the loading screen until we're done fetching this token. To do this, we need to install another package. We need to expo install or npm install expo-app-loading so that we can use this component and wait for this installation to finish here. And once this finished, once we installed this package, we can import app loading from Expo app loading and use that component in our root component. So here we now want to find out whether we're done loading or not. So if we did fetch our token or not. And to control that, we can add some state here with use state, which is imported from React. And we could name this is trying login and set is trying login. And initially this is true because we are trying to log the user in. But then here, once we're done fetching the token, no matter if we did find a token or not, either way we are done trying to log in. So we can set this to false then, because we are no longer trying to log the user in. And we can use this is trying to log in state here to return app loading whilst we are still trying it. And app loading, when returned, will ensure that the splash screen is prolonged. So if we switch to this approach, instead of using useEffect directly in the auth context, we can get rid of that flickering. Now if I close this app here, and I then restart it here on iOS, we should immediately end up on the welcome screen after this loading screen here, this screen. Here we go. And if I do log out, of course, and I then close this app, and I then restart, we should end up on the login screen after the loading screen. Because no token was found, and therefore we are not logged in automatically. However, actually, this failed here because we do still have a token stored. Because when I log out here, we do clear the token, but only in auth context. Just as before, we only set it in auth context. Now we also want to clear the token in async storage when we log out, so that automatically logging in again won't work. And to do this, we can use async storage and use the remove item method. And remove the token here in the logout function in our auth context provider component so that we clear the token once we logged out. With that, if we now reload this and I do log out, if we now close this app here and we then restart it, we will end up on the login screen again after the loading screen. Because now we don't have any tokens stored and therefore we are not logged in automatically. And that's how we can persist that token on the device so that we keep a user logged in. Now that's it for this course section. That is how you can build a basic authentication flow with user sign up and log in, and how you can then log in a user, and how you can then, for example, fetch data from protected resources. You learned how authentication generally works with mobile apps and decoupled backends, and that this auth token is important for knowing that a user is authenticated on the device and for getting access to protected resources thereafter. You learned how you can manage app-wide state here with auth context, as we are doing it here, and that you can also store the token on the device so that it is available the next time the app restarts. You did also learn that you can then use the token to attach it to outgoing HTTP requests to protected resources to fetch data from such resources with help of that token. Now, when it comes to authentication, you can always do more, and it will depend on the exact API you might be using. For example, a token could expire and you might want to manage this expiration and automatically refresh a token just before it expires. But those details, like the token lifetime, and if it has a lifetime, will depend on the API you're using. Now, when working with Firebase specifically, you also might consider using the Firebase SDK. Because if you're really using Firebase only as your main backend and not just for a demo, then using the SDK can make things simpler. It can make authentication and so on simpler because Firebase will manage a lot of things for you behind the scenes. But the idea behind this module was to show you this basic authentication flow, and that is what we did now with authentication added in this very simple demo app here. At this point in the course, we learned a lot about building native mobile apps with React Native, but there is one crucial feature that we haven't really used too much, or a set of features to be precise. In this course section, we are going to learn how we can use native device features, things like the camera or the location of the user, and you're going to see that using such features in your React Native apps is super simple. And for this section, or in this section, we are going to build another brand new app from the ground up, also to practice what we learned thus far. But we're then going to use features like the device camera to take photos. We're then going to learn how we can fetch the user's current location, and we're going to see how we can use maps in our application. So how we can, for example, use Google Maps there. And we're going to learn how we can store data on the device, including more complex data. Of course, your app might also need a backend, some API to which you send HTTP requests. And you did learn how that would work in this course already, but you might also want to store some data on the device sometimes, and that's therefore another crucial topic we will explore in this course section. Now, as mentioned, we're going to build another brand new app from the ground up, the Favorite Places app, which allows us to manage a list of our favorite places. It allows us to add new places that have a title, where we can take an image, a picture, and where we can then attach a location, either by getting our current location or by picking it on a map. And then once we added such a location, it will be stored on the device so that it persists, app reloads and restarts, and we can therefore add a list of favorite places as we're building this app. That's what we're going to build. And of course, as a practice, definitely feel free to get started with that on your own. Not the native device features, but the general user interface, the navigation. In the next lectures, we are going to build it together, and we're then going to add these native device features step by step. Now, for this section, as mentioned, we're going to start with a brand new application, and therefore here I am in a brand new Expo project where I'm simply outputting hello world in my app.js file. And besides that, there's nothing fancy in there, nothing special in there. And we're going to build up all the logic and add all the code together step by step. Now, as always, there are different ways of getting started, but I'd like to get started with the general user interface before we then add more and more native device features over time. And for this, if you recall the app I showed you in the last lecture, we will definitely need a couple of screens because we have multiple pages, multiple screens between which we will be able to navigate. And therefore, I'll add a screens folder in this project. And I will also already add a components folder, since we're also going to add some components. And in this screens folder here, I'm going to add a allplaces.js file, which will be responsible for displaying a list of all places and which will be the starting screen of this app. In addition, I'm going to add a place details.js file because we will also be able to tap on a place to view the details of this place thereafter. Then I also want to add a add_place.js file, which allows us to add new places. And of course, that will be the screen where most of our work will be done throughout this course section, because that's the screen where we work with most native device features. Now, there is one last screen which I will add already, and that's the map screen here. And I'll just name the file map.js. And that's the screen that will be responsible for showing a full screen map, which we, for example, will use for selecting a place on the map. Now, most of these files are empty for now, or at the moment all files are empty, of course, but most of these files will stay empty for now, and we will instead start building up the logic that goes into these files and the user interface that goes into these files step by step. And I think a good place to start is the allplaces.js file, because that is the first screen that should be displayed. So therefore in there we can add a component function, all places, which as always is of course exported like this. And the idea behind this screen or this component function really is to simply output a list of places, or if we don't have places yet, some fallback text. And to make this work, I will already add a new component in my components folder, and there in a places subfolder to keep my components organized. And in that places subfolder in the components folder, I will add my places list.js file, which should be responsible for actually outputting a list of places. And of course, at the moment we have no places, but that will change throughout this section. So in this component, we can add our places list component here. In this component file, we add this component, the places list component. And the job of this component will be to render a list of places or to show this fallback text. Therefore, it's fair to assume that in this places list component, we get a prop that could be named items or places, and that prop should give us an array of places, which then can be output in this component. Therefore, in this component, we might want to return the list, and since we can have an infinite amount of places, I will do that with help of the flat list component that's built into React Native, and that's therefore imported from React Native. Because as you learned, flat list is the component you want to use if you have a potentially very long list of items, because that component will give you a scrollable list of elements, and it will also help with performance. Now, for this list, or on this flat list component, we then need to add the data prop. And here I want to pass in my array that should be used as data. And in this case, that would be the places. Again, we have no places yet, but we will have an array of places in the future. So we can already pass it into data here. Now we also will need to make sure that keys can be extracted from that data. And of course, at the moment, we don't even know yet how our places are going to look like. Now to help us with that, I will add another new folder, the models folder, in which I add a place.js file. This is technically not required, but I want to define a blueprint for my place objects to ensure that they all have the same, similar, correct structure. And in JavaScript, you can define blueprints with classes. So here I will add the place class like this. And then in the constructor function of this class, we can accept different arguments, different parameters, and then initialize different properties for this class, and therefore for the objects that will be created based on this class. And here it's of course up to you how a place should look like, but for me, a place will get a title later. It will get an image URI, so a uniform resource identifier. So for example, a path to the image on the local device file system. I also want to get an address, so a human readable address, so some text in the end. And I want to get a location, which should be an object that's made up of a latitude and a longitude coordinate. And we will, of course, later add different inputs that allow users to provide values for these different fields. For the moment in this constructor, I will simply store my title in a title property like this. Like this. Store my image URI in an equally named property like this. And do the same for address, and then also for location, like this. And again, location itself should be an object that has a latitude property or a lat property, which is some number, and a longitude property, which is some number. So something like this, that's the goal here. With latitude and longitude, we will have different numbers here. Last but not least, and very important, also for our key here, which we need in the flat list for every list item, I also want to assign an ID to every location. And this ID could now be generated on some backend if we had one. But since we don't have a backend here, I will generate my own pseudo unique ID
by using the current date and converting it to a string like this, and concatenating some random number to that, also converted to a string. This should give us a unique ID because we would need to roll the exact same number at the exact same point of time to produce two items with the same ID. Technically not impossible, but good enough for this demo. And with that, every place will have an ID, and that brings us back to the places list. This array of places which we get here can be expected to be an array full of objects where every object has this shape. So where every object has these properties here. And therefore the ID, of course, is a good key, and hence on flatlist we can add the key extractor as you learned. Add this extractor function which receives every item as an input automatically, and then simply make it clear that the ID should be used as the key for every flatlist item. And that's a good start here. Now, as a last step, we also need to add the render item prop, which should point at a function that is executed for every list item, which will then determine which kind of element should be rendered for every list item. And we're going to work on that function and the list item component that belongs to it in the next lecture. So let's now work on this render item prop and pass in a function that controls which kind of component or JSX code in general will be used for every item that's passed into flatlist. Now for this, I'll write an extra function here. This is technically not required. We could also create an inline function here, for example, an arrow function. Now here I will use an arrow function, and this arrow function receives some item data, as you learned earlier in the course. To be precise, it receives an object that has, for example, an item property. And that will be the individual item for the items we pass into our flatlist. So this function is executed for all the items in our data array, and we get each individual item as an argument here, or as a property in this object, which we get as an argument. And then it's up to you which kind of code you want to return for every item. But here I will create a new component, the placeItem.js file, which will hold the placeItem component, because I want to outsource the logic and the JSX code for my individual place items. But before we work on this placeItem component, the goal here in places list will be to create instances of this placeItem component, like this, and to then pass some data into this component, which can be used in this component to render the appropriate JSX code and the appropriate user interface. Now, the data that is passed into our place item is basically the data we're also defining here in our model. So the title, the image URI, and so on. And therefore, we could pass in multiple props here, or we pass the place as a whole into place item. And that is what I will do. I will add a place prop and then pass in item as a whole into place item. And item will be an object that has this structure because item will be a place here since we pass in an array of places as data into the flat list. So with that, we got this general flat list logic in place. Now we can work on the place items. And here, of course, it's as always up to you which kind of JSX code you want to return for every place item. But here, I want to return a view, which must be imported from React Native, that then displays an image, which is also imported from React Native, and side by side to that image, another view which contains two pieces of text, where the first text should be the title and the second piece of text should be the human readable address. And that's just my structure, which I want to have here. You can, of course, come up with any structure. Now, actually, those place items later should also be pressable because we should be able to tap them to go to the place details page. And therefore, I will replace that outer view with the pressable component, which is also imported from React Native, so that we can listen to press events on those items. And then, of course, we should expect the place prop here on place item because I'm passing this prop into my place item component here. Therefore, we should expect it here, and then we can use the data that is stored in this place object in our JSX code. For example, on the image, there we need to set the source to an object where we set the URI property equal to place.imageURI. Place.image URI because our place objects will have an image URI property. So therefore we can use that here. For the title, we want to output place.title. For the address, we want to output place.address. And that is already it here. Now I also, as I said, want to make this pressable. So therefore I will expect another prop, let's say the onSelect prop, which should hold a function that should be executed when this item is pressed. And therefore I will add onPress here to pressable and simply point at onSelect or forward the value that we receive on the onSelect prop to the onPress prop of pressable. And that is it for the structure here. Now, of course, there is a bunch of styling that has to be done. And for this, we can add a styles constant here or a variable, which holds an object created with help of stylesheet, which is imported from React Native, where we call create. Now, regarding the exact styling, we will work on that later, because at the moment we can't really see it since we have no places yet, and we have no way of adding places. Therefore, we will style this component later in the course once we have more data. Hence, for the moment, I'll just create that dummy styles object, and we will use it later. For the moment, that's my place item. We will finish it later in this section. Back in places list, I now just want to make sure that we also show some fallback text if we have no places yet. For this here, we could check if places is null or undefined, or if places.length is equal to 0, which means that we have no places. And in those cases, I want to return a view, which is imported from React Native, which holds some text, which is also imported from React Native. And here we could say no places added yet, start adding some. Something like this. We can also style this and simply go down there, add a styles constant here, and use the style sheet and create a style sheet with the create method. And then here we could add a fallback container style object, which has a value of flex1 to take all the available space, and where we then set justify content to center and also align items to center the content inside of this container, so this text here in the end, horizontally and vertically. The text also will receive some styling, so here I have the fallback text style object. And for the moment, I'll just ramp up the font size to 16. Soon, we will also work with some colors. But for the moment, that's it. And now we can add a style to this view here. And that would be the fallback container style. And here to this text, we add the fallback text style. Now with that, we got these first two components in place. And we can now use them in the all places component. In there, I in the end want to return my places list component like this, which of course must be imported. So that's the component we just worked on. And later we will also provide a places prop here to pass in some places, but at the moment we have no places yet. So at the moment we'll just keep it like this. And that's all for the all places screen for the moment. Now with that out of the way, we can work on some other screens and then also set up some general navigation so that we can see something on the screen here or on the screens of our emulators. So let's now also take a look at the other screens. I'll ignore the map screen for now and also the place detail screen, because for the place detail screen and for the map screen, we need a place or a location respectively. But of course, adding places will be important because that will allow us to have some places which we need for all other parts of the app. Therefore, here in add place, we can add a add place component function and of course export this add place component function. And then in here, we can return an interface that allows us to add a new place. For this, I will again go to components and add a new component in there in my places folder, and that will be the placeform.js file. In there, I'll add the placeform component function, and as the name suggests, this is a component that will be responsible for, well, outputting a form with various input elements that allow us to define and finally add a new place in the end. Now, for the moment, I will just return a view here with some text inside of it, both imported from React Native, where I say the place form. And of course, that is just a placeholder. But now with that, we can use this placeform component in the add place component. And in there, I simply want to output my placeform component like this. Now we should at least be able to navigate to this screen, and that is indeed the next thing I want to do. The next step is to add navigation. Now, to add navigation, we will again use the React Navigation package about which we learned throughout the course. And therefore, we will install it as we did throughout the course with npm install @react-navigation/native. That's the core package which we need to install. And then also another package, React Navigation or @react-navigation/native stack, because I want to use this native stack navigator in this app as well. These two packages must be installed here, so we can install them with npm install and then hit enter so that we do install these packages here. And once they were installed, and you find their entries in the package.json file, we can use those packages. And I will use them as I did in the rest of this course. Here in app.js, I want to import the navigation container from @react-navigation/native. So import the navigation container and also import this stack creation function from @react-navigation/native stack, this create native stack navigator function. Then we can create this stack constant or variable here by calling create native stack navigator. And we can then get rid of our styles here and get rid of the style sheet import. And in the app component, get rid of the JSX code we had there and instead add this fragment tag so that we can still render the status bar component, which helps us with configuring the status bar. And here I'll set the style to dark for the moment. And then add the navigation container, which we also imported, between which we can set up our navigation. And now for the navigation I want to set up, I will of course use this stack navigator, which we created here. And get rid of the text and view imports here, by the way, because we don't need them anymore. And then in this stack navigator, we want to add various screens. Now every screen receives a name, and we will, for example, need the all places screen. The component that should be loaded for that screen is the all places component, which can be imported from this all places file in the screens folder. We can also add another screen already with stack screen, and that will be the screen for adding a new place. Hence, I will choose add place as a name. The component that should be used here is, of course, the add place component from the add place screen file. That's now the base navigation setup for the moment. We're going to improve and change it slightly later, but for the moment, that is it. And now with that, this screen here, since it is the topmost screen, should be loaded as a default if we save this and force a reload across all our platforms. And hence, if this does reload here, it actually got stuck for me. So what I will do here is I will close the app on both emulators, close the Expo Go app entirely, and then restart both the Android and iOS processes from inside my npm start terminal process by pressing A and I. Or if that doesn't do the trick, stop the npm start process altogether and close these applications here. And then restart the Android and the iOS processes by hitting A and I. And then this is looking better, at least here on iOS. And now also on Android. So now I got these screens in place. They are up and running, and we can see something on the screen. We see our fallback text because, of course, at the moment we have no screens yet. And therefore now, with that out of the way, we can start making sure that we can actually reach this add place screen. For this, I want to have a button here in the header, and we can work on some styling. As always, definitely feel free to try these steps on your own first before we're going to start implementing them together in the next lectures. So let's now make sure we can also switch between different screens. And for this, I want to make sure that I have a little plus button here in my headers. And that plus button should allow me to switch to the Add Place screen. Now for this, of course, in our navigation setup, it's the All Places screen where I want to have this button. So therefore, we can add some options to that screen with the Options prop as you learned it. And it's the header right option, which I want to set here because that allows me to add an item in the right corner or on the right side of the header. Now, header right, as you learned, takes a function which receives an object, which, for example, gets information like the tint color of the item that will be rendered, which helps us with coloring that item correctly. Now, the item which I do want to render here should be an icon that is clickable or tappable. Therefore, I will add a new component for this. In the components folder, I will add a new subfolder named UI. And in there, I'll add an icon button.js file. And we added a component like this multiple times before in this course already, but I still like doing this from scratch here to practice this. So here I will export my icon button. And in the end, that should be an icon that's pressable. Therefore, I will add pressable here as a wrapper and import pressable from React Native. And then I will import from @expo vector icons and import ionicons. And of course, you could use any other icon set as well. I just happen to like ionicons quite a bit. And then we can render an ionicon icon like this here in our pressable component. Now this icon button should be configurable from outside, hence I will accept multiple props here, and I want to get the exact icon name as a prop here through the icon prop. I want to get the size as a prop and the color, and also an onPress prop, which we can forward to the onPress prop of the pressable component. And then on the icon itself, we have to set the name. And I will set this to icon because I expect to get the name here. And we can set the size to size and the color to the color we're receiving. Now we also need some styles that are baked into this component. Hence we will use the style sheet here to create a new style sheet. And then for the styles that should be set up here, I will add a button style and a pressed style, which will be applied when this button is pressed. And for the general button style, I want to make sure that we have some padding in all directions and some margin in all directions here. And of course, you can play around with these styles to get exactly the look you want. And I will add justify content center and align items center to make sure that we center this icon in the middle of this button. Now for pressed, I just want to set the opacity to 0.7, let's say, to make it slightly transparent. And now these styles can be added, and to the container, so to the pressable component, I will add styles.button, and I also want to add the pressed style when this is pressed, hence I will actually wrap this into an array, into square brackets, and always add the button style, But as a second array element, I will sometimes add the pressed style if pressed is true. And pressed is a property we get if we turn this style value into a function, because then this function will be called for us by pressable, and we will receive an object that has a pressed property that indicates, by being true or false, whether this is currently being pressed. And if this is being pressed, I want to add the pressed style like this. We don't need to add any extra styling to the icon. So that is now my icon button, and this icon button can now be used in app.js here in header right. There I want to display such an icon button, so therefore it must be imported, of course. And then on this icon button we have to set all these props that are expected. For example, the icon prop, which I will set to add, which is one of the supported icon names supported by Ionicans. And you can always check this Expo Vector Icons page, which gives you an overview of all the supported icons. Now I'll set the size prop to 24 and the color prop to this tint color which we're getting, so that we use the color that is identified as the to be used color by the header and by React Navigation. And for onPress here, I will use another inline function here, which should make sure that we navigate to this add place screen when this button is pressed. And to make sure that this happens, we need to get access to the navigation object, which is provided by React Navigation. Now we get this as a prop in all screen components. We can get it with the use navigation hook, as you learned, but we can also get it by converting our options here from a static object to a function that returns such an object. For this, we should wrap the curly braces that define the object into brackets to make it clear that this is an object being returned, not the start of the function body. And then if we use such a function here for options instead of an object, this is a function that will be called by React Navigation, and we get some props here in this function. For example, we can extract the navigation property from the incoming object. And this navigation property can now be used here in the function that's executed for the onPress prop, so when the button is pressed, to call the navigate method and navigate to the add place screen like this. And this will then navigate us to this screen. Now with that, if we save this, we find this button here in the header, and if we tap it, we indeed go to add place, and we automatically get the back button that allows us to go back. So that is working, and with that we got this header button with the attached navigation logic, which we also saw earlier in the course already. Now as a next step, let's work on some general styling, the header titles, and so on, before we then thereafter start working on this form. Now before we start working on the looks, let's make sure we add titles to our different screens. And for this here, in app.js, I want to start with the all places screen. Besides setting the header right option here, we can also set the title option to give this a title that's not all places in one word, but for example, a title like your favorite places, something like this. Of course, if we set this property, we get this title here on our screen on the emulators. Now for this add place screen here, we can also set a title by setting the options here. And here we want to set an object where the title could be add a new place. Something like this. And of course, unsurprisingly, if you set this title here, we see it here on this screen. So that's of course not too fancy, but it is something that's also important. Now besides doing that, I also want to add some styles where I want to change the colors to be precise. And for this, I'll add a new folder in this project, the constants folder, where we can add a colors.js file. And in there, I want to export an object of colors that we can use in this application. For this, I'll export a constant named colors here, and attached you find this colors.js file so that you can use the same colors I predefined here. Of course, you can also set up your own colors, change those colors, add more colors, do whatever you want. But to save you the hassle of typing multiple hex codes and picking multiple colors, I provide this colors.js file with those colors to you. And now with that added, we can use those colors again in app.js to, for example, change the header background color, because that is something I want to do. And I also want to change the main background color of the screen content. Now, of course, the background color for the header should be changed for all screens. Hence, I'll go to the Stack Navigator and there add the screen options prop, which allows me to pass in an object that allows us to set some options for all the screens that belong to this navigator. And here we could add the header style option, which wants an object where we can set the background color to colors, importing colors from this constants colors file dot primary 500. Then, besides this header style, which sets the background, I will also set the header tint color to set some contrast. And here I want to use colors.gray 700. The content style, so the background for the screen content, should be set to an object where the background color can be set to colors gray 700 as well, let's say. If we save this, we get this style here, but of course, as always, feel free to adjust it to your requirements. But I'm quite happy with that look. Of course, that text is pretty hard to read on our screens now, and therefore we also want to apply some styling there. For example, in the places list.js file where we have this fallback text. Here, instead of having a black text, which is really hard to read, I want to use one of my colors here. So for the fallback text, I'll add a text color and import colors from the constants folder. So make sure you add this import here, of course. And then with that added, we can choose a color from that list of colors, like for example, primary 200, which makes that way easier to read. So now we also added some colors and we set those header titles. With that out of the way, we can work on the next steps. There's just one tiny thing I just recognized here on iOS. The positioning of the icon button here isn't that great. And that is actually coming from the margin I added there. If we remove that margin, now it looks way better. So that was just another tiny tweak I wanted to make. But now with that, we can continue and we can work on this place form and start adding some logic here so that we finally can get started adding places. And even more important, we finally can get started tapping into native device features, because that's what this section is all about in the end. So time to leave the practice area and learn some new things here. So let's now work on this place form. And on this place form, there are various things I want to do. I want to get a title for every place, which should be some text which is entered by the user. But then I also want to allow the user to take a photo. And I want to show a preview of that taken photo so that the user could also replace it with a different one if he or she wanted to do that. Therefore, here in place form, it's now time to replace this dummy placeholder code with the actual UI code. And for this, I'll start with a scroll view because we will actually add multiple elements to this screen, and I want to ensure that we can always reach all of them and that we therefore have a scrollable view. Hence, I'll wrap this with a scroll view. A scroll view instead of flat list, because we'll not have a super long list of multiple items. We'll just have a clearly defined UI that might be too big for small device screens. But now inside this scroll view, I'll add a view which wraps a text which will be used as a label, and then a text input to which that label belongs, which allows the user to enter something. And that something should be the title, hence I'll give this text a text of title to act as a label for this input. And on this input, I then want to listen to changes to the text so that we can store the entered text. I'll do that with help of state, as we did it before in this course as well. And here I, in the end, got my entered title and my set entered title state updating function. And I will add a helper function, change title handler, which should be executed on change text. So that's the function at which I'll point here. And there we will receive the entered text as an argument automatically passed in by React Native. And we can then call set entered title and pass this entered text as a new value for this state. Then I will also pass this value back into text input through the value prop. So here I will point at entered title. And now with that, we will be able to register keystrokes in this input. Now, if we save that, we will have this input here, but it's almost impossible to see because it has no styling, the label also is black, and that of course doesn't get us anywhere. Hence, we will need to take care about styling here in the place form component. And we can do this by adding this good old styles object with the style sheet object here, style sheet create to be precise. And then we can add some general styling for the overall form, so which will be added to this scroll view that holds the overall form. And then also set up some styling for labels like this title text and for the input that we have here. Now for the overall form, I'll set this to flex1 so that it takes all the available space if possible. And I'll add some padding so that we have some spacing to the edges of the device screen. And for the label, I'll give this a font weight of bold to make it bold, and add a margin to the bottom of 4 so that there is some space between the label and the actual input element. And we can then add a color, which is imported from the colors constant. Hence, of course, as always, this import must be added. And here I will use the primary 500 color and then work on the input. Now for the input, I want to add a margin vertical, so top and bottom of 8, and a padding horizontal, so an inner distance to the left and right of 4, and a padding vertical, so inner distance to top and bottom of 8. And then ramp up the font size a little bit and set it to 16. The default would be 14. And then add a border bottom color here and a border bottom width in a second step, where the color should be primary 700, let's say. And then the border bottom width is 2. And I'll give this a background color of, let's say, colors.primary 100, which is a light blue. Now we can assign those style objects that we define here to these elements here in our JSX code. So the outer scroll view receives a style prop, which is which points at the form style. This text here receives the style prop, where we use the label style object, and the text input, of course, uses the input style prop or style object. With all that set up and saved, this is what we should get here. So now we can enter a title here, and we can see that we can enter something there, which is quite useful. So now with that, that's the first step. But of course, that's not the only one, and it's also not new. In the next lecture, we're finally going to get started with taking pictures and showing a preview of the image taken. So it's finally time to start taking pictures. And for that, I want to add a new component which I will name image picker, because taking pictures is actually a process that consists of multiple steps. We will have to open the camera and show a button that allows the user to do so, but then I also want to show a preview of the image. And therefore, of course, we will have a UI that has multiple elements and also some logic attached to it. But before we get started working on that component, let's understand how we can actually use the device camera. And here, React Native makes it quite straightforward and easy for us to use native device features like this, especially when we're using Expo. We are using Expo here, so we can, for example, search for Expo camera. And that is generally a good approach. If you, for example, want to use the user location, you could search for Expo location. If you want to, let's say, store data on the device, you could search for Expo storage, and you would find different packages that might help you with that. Now here it's Expo camera, and we can go to the Expo documentation to learn more about this package. Now Expo camera actually is a package that does not just open the device camera, but instead it allows you to customize the camera screen. You can control autofocus, zoom, you can build your own camera-based UI. And for some apps where the camera plays a major role and is not just about taking some photo, that of course can be a very important feature. But for our app here, this would actually be overkill because I don't really need to configure the camera screen. Instead, I just want to use some default camera screen that simply allows me to take an image. Nonetheless, it's worth noting that you have packages like this, and what's really important is that whenever you are about to use a package like this, definitely have a look at the official documentation, like this documentation page here for the camera. There you learn where this package can be used, how it works, and how you can install and configure it. And it's really important that you go through these instructions to make sure that you use the package correctly. However, as I said, the camera package, the Expo camera package, is a bit overkill for what we're going to build here. Instead, another package, which is more useful to us here, is the image picker. Because this is a package that allows us to open the on-device photos or also launch the camera. Both is possible with this package. And therefore, that's the package we're going to use, and we're going to follow the installation instructions mentioned here, which in this case is this one command. So I will open a new terminal window and run expo install expo-image-picker. This will install this package into this project so that we can use it there. Now once that was done, we can close this extra terminal, and then as mentioned, we can learn how to use it here in this file. And there, for example, is some configuration that we should set up to manage permissions correctly, because that is an important topic when working with native device features, permissions. Many native device features need permissions to be granted by the device user. For example, if your app wants to use the camera, a user needs to give his or her permission for your app to do that. Now, you must register permissions your app will use ahead of time, and most packages exposed by Expo make registering such permissions quite easy and straightforward. By the way, you find different instructions here also for cases where you would not be using Expo and you still wanted to use this package. But here for us, what is important is actually this entry, which should be added to the app.json file. We should add this plugins entry here into our app.json file. So here, maybe at the bottom, we should add this plugins node, which holds this array, which in the end sets the permissions we want to use. Now we learn which permissions can be configured here, and in my case I want to open the camera, so I'm not interested in the photos permission, instead I'm interested in the camera permission. Therefore, I will change this node here to camera permission, And then you can enter some text here, which will be shown on iOS when the user is prompted to grant the permission. So here you can explain why you need the permission to convince the user to grant it to you. So here we could therefore say something like, the app needs access to your camera in order to take photos of your favorite places. Something like this. So this needs to be added here, and we know that this must be added because the documentation page of this plugin tells us to do that. Not all packages need this kind of configuration, but the image picker does, and that's why it's important to read the official documentation. Now, with that, we got this configured, and now in the next lecture, we can start working on our own image picker component, which should integrate that third-party image picker component to open a camera and show a preview of any taken images. So let's now work on this image picker component, and for this we can add the image picker component function here, of course, like this, and then return some JSX code that defines the user interface. And now, of course, as always, it's up to you how you want your image picker to look on this screen here. But I want to make sure that in the end we have a wrapper view here, which of course must be imported from React Native. And in that view, I want to have another view that will be responsible for displaying a preview of the picked image, and below that a button which allows us to open the camera. Now for the moment I'll use the built-in button. Soon we will add a custom button. But for the moment we can add the built-in button and give it a title of Take Image, and then add the onPress prop, and in our component function add a handler function, the takeImage handler, for example, that should be executed when that button is pressed. So that's the function we pass as a value for onPress. Now in this view we'll show the preview, but for the moment we'll not worry about that. We'll do this in a second step. For the moment I just want to make sure that we do open the camera with the takeImage handler here. And how can we now do this? Well, with help of this package we just installed. From there, we can import various things, so from Expo Image Picker. And we can, for example, import the launch camera async, which will launch the device camera and wait for us to take an image. Now we can execute this imported function here in takeImageHandler. There, we can execute it like this. But as the name async already suggests, this will return a promise because, of course, it doesn't finish immediately. Instead, it waits for the user to press the camera button to take a photo, and this function therefore won't finish execution before that photo was taken. So it will wait for the user to take a photo. Hence, we want to wait for this as well before we try to work with that photo, because the photo only exists after this function finished execution. And hence, we can convert our takeImageHandler into an async function so that we can use the await keyword here. And then we'll get this image once this is done. Now we will see what exactly this image is soon. For the moment, we can simply log it to the console here to see it as soon as we have it. But before we can see anything, I want to configure my camera a little bit. For this, we can pass a configuration object to launch camera async. And of course, that is also something you learn in the official docs of this package. There you find the launch camera async function here. And you learn that you can pass some options to it. And you can then click here to learn which options can be set. So it's this list of options that we could set for this launch camera async function. Now in my case here, I want to set some of these options. For example, I'll set allows editing to true to allow the user to edit the photo before confirming it. I will set the aspect ratio to an array of two numbers, which is 16:9 in my case. And I'll set the quality to 0.5 to make sure that we don't get super large images, but images that are slightly smaller. Because of course we got high resolution cameras on modern devices, and therefore images, if you don't restrict the quality, can become really large. Sometimes you want that. In this app we don't need it, hence I will lower the quality. Now definitely feel free to have a look at the other options here as well, but for me, this is the options that I want to go with. Now, if we save that, we can try using this image picker. And for this back in place form, we can add it below our input here. So below this view, I will add image picker, which is of course imported from our image picker file. And by adding this here, if we save everything, we should see this take image button. Now, if we press this button, nothing happens though. Instead, after some time, we get a warning here that we had some promise rejection, so an error in the end that was not handled. On Android, it's different. There we get this pop-up that asks us whether we want to grant permission or not. And we can press allow, and if we do that, then indeed the camera does open up. Now we'll take care about iOS in a second, but here on Android I can now confirm this. Then here we got this editing screen. We confirm it by clicking crop. And now the image was taken. We see no preview yet because we haven't added any logic for this. But in the terminal, where we log our taken image, we can see this object which describes the image. For example, we got a URI property which holds the path to the image. So that's the actual path on our device, or in this case on the emulator, where the taken photo was stored. So that's all nice, but why didn't it work on iOS? Well, because of permissions. On Android, it asked automatically for permissions. On iOS, that's not happening. There we need to manage this ourselves. And to manage this ourselves, we got more functions exposed by Expo Image Picker that help us with that. For example, there we got the Use Camera Permissions hook. This is a hook which we can execute here in Image Picker. What this hook gives us is an array with two values, and the first value is the camera permission status, or camera permission information, and then a request permission function. And of course, the latter, this function here, is very important for us here on iOS, where we didn't have the appropriate permissions. What I will do here is I will add another function, another async function, because we will have to await something, which I'll name verify permissions, like this. In here, I want to check if we already have permission to use the camera, because the first time we're using it, we will have to grant permissions, but for subsequent uses, we of course already have permissions, and we then don't want to try to request permission again. Therefore here, I will check my camera permission information object here and dive into the status property that exists on this object, and compare it to one of the built-in statuses. We can get a list of all these built-in statuses that are handled by Expo by importing the permission status enum here from Expo Image Picker. And then we can use this here in the comparison, permission status, and check if the status is undetermined, which means we don't know yet if we have access or not, if we have the permission to use the camera. And this would be the case because the user hasn't been asked yet. In that case, we want to call request permission, this function here, to get that permission. And that is an asynchronous function because it will open a dialog and wait for the user's response. Therefore, it returns a promise, and that's why I used async here so that we can await this. And then we get the permission response here in the end. And now the user either gave us permission or he or she declined it. Either way, we can return permission response dot granted here, which is a property that's true if the permission has been granted and false otherwise. So that verify permissions in the end returns a promise that resolves to true or false depending on whether we got the permission or not. But maybe the status wasn't undetermined. Maybe we didn't have to ask. In this case, the promise returned by verify permissions should also yield true or false to tell us whether we have the permission or not. And therefore, we might want to add another check here, where we check if the camera permission information status is equal to one of the other built-in statuses, denied status, which means we don't have permission. In this case, I want to show an alert that tells the user that we won't be able to continue with the app here because some core functionality, the feature of taking images, is blocked because of permissions. Therefore, I'll use the alert API, which is imported from React Native, to show an alert dialog where I say insufficient permissions. And then I'll say you need to grant camera permissions to use this app. So the user may deny that, but then the app is not usable. And then I will return false because verify permissions should return true if camera access was granted and false otherwise. And in this case, we don't have the permission to use the camera. If we make it into neither of these if checks, we know that we're not in undetermined state and it was not denied, so we do have the permission to use the camera, and hence I'll return true here. And now with this verify permissions helper function added here, back in take image handler, we can use this helper function here. We can await the result of calling verify permissions, which will request permissions if needed, or give us the current permission status otherwise. And therefore, what we get back is a boolean that's true if we have permission to use the camera and false otherwise. Hence, I'll store the result in a constant named has permission. And then I'll check if has permission is false, if we don't have the permission, hence the exclamation mark, in which case we can't proceed. So then I'll just return to cancel the execution of this function so that we don't try to launch the camera because we don't have permission to do so anyways. Otherwise, however, we should be able to continue. And now with those changes made, if we reload on Android, nothing changes because we granted permission before anyways. However, if you didn't grant permission before, or if you haven't made a choice before to be precise, you now will see a dialog again, and that dialog might look a bit different from what it looked before. But on iOS, now we also get this dialog. Now, actually here, I'm getting a different dialog than you might be getting because I actually already granted permissions behind the scenes when I prepared this module, so my Expo Go app already has the permission, and keep in mind that during development this app is hosted by Expo Go, so therefore I now just need to confirm it like this. But with that, we would be able to open the camera here as well. You will probably get a different permission dialog. But of course, it seems like what I'm saying is not true, because the camera is not opening up here. And the reason for that is simply that the iOS simulator has no camera simulator. Android does. There we get this camera simulator. But on iOS, that is not the case. iOS doesn't have that for its simulator, but still, this will work. You see that in that warning as well. The error that we got is that the camera is not available on the simulator. Now, to still see this in action, what we can do, of course, is in that browser tab that opened up when we ran npm start, we got this barcode. And keep in mind that at the beginning of this course, we actually launched our first dummy React Native app with help of this barcode and the Expo Go app on a real device. So therefore, that is what I'll do here again. I will now again open my camera app on my real iPhone, and then open this in the Expo Go app, which I have installed on the iPhone. so that I can preview this app on my iPhone, on my real iPhone. And there, if I now click Take Image, I get this dialog that asks for permission. And then thereafter, the camera does open up. And hence now I can take a picture here of my, screen in the end, edit this as needed, and then of course use this photo. Now with that, we still don't see a preview here, but this is working. So you can test it on a real device like this, and this proves that requesting permissions and opening the camera is working on both Android and iOS. And that's our first native device feature in action. Now the next step, of course, is to use those images that are taken and to store them and to show a nice little preview. So now we're able to take an image and we can log that image to the console. Here you go. But of course, that's not the main goal. Instead, it's nice that we have this image. It's nice that it seems to be stored on the device as a default, but I also want to show a preview now, a preview of that image. To do that, we can go back to the image picker component, and there I have this view in which I want to show a preview. And showing a preview is actually pretty easy. In this view, we could add the image component, which is provided by React Native. So of course, therefore, it must be imported from React Native. And this image component wants a source prop, as you learned. You can set the source prop to an object with a URI property, as you also learned throughout this course. And now the interesting thing is that this image, which we're logging to the console, has a URI property itself, but even if the property would be named differently, this is a path to the image stored on the device, and it is a path we can use as a URI for our image component. So therefore, all we have to do is, instead of logging that image that was taken, we have to store this image object that describes the image in some state that belongs to this image picker component. So here we can register some new state in this component, imported from React, of course. And the state which I do want to have here is in the end the picked image and an updating function which can be called set picked image. Now we want to set the picked image once we have it, so therefore here, once the image was taken, we can call set picked image and pass our image as the picked image here. Or, since we don't need all the other data, we could also just pass the URI. So in this case, I'll just store the URI of the picked image, the string that is that URI, that path to the image on our device. Now, with that, we can use picked image, which is that URI here, for the source of our image. But of course, that won't always be available. That's only available after an image was taken. Therefore, I actually want to show some fallback text if we don't have an image yet, if we haven't taken an image yet. For this, of course, we can add a variable here, let's say, image preview. And by default, this could be some text instead of the image. Some text where we say no image taken yet. Something like this. And then we can check if picked image is truthy, which it is once we set a full path to an image. And if that is the case, we can set image preview equal to this image component here, like this. And then here in this view, we output this image preview variable, which is either that text or the image. Now with that, we should be able to see a preview once we took an image. So therefore, I'll save this and force a reload. And then on Android, where we have a built-in emulator, this text is pretty hard to see, we'll work on this later. But here on Android, we can now take an image, like this, confirm it, and we should see it here, but actually we don't. Well, actually we do. At least the text is gone. The text was hard to see, but it is gone. And therefore, something changed, but we don't see the image. And the reason for that is that we set an image, but we also need to set a width and a height if we're not requiring the image, which we only can do if it's an image we're bringing ourselves, so which is already part of the project, which is not the case here. So we need to set width and height here, and we could use the width and height of that taken image, but then we would have a super large image, and I don't want to have that here. Instead, I'll set some fixed width and height here with some styles we can define with the style sheet imported from React Native, created like this. Here, I now want to set some image preview styles for that container that holds the image preview, so for that view, and I'll give this a width of, let's say, 100% so that it takes the full available width, but a height that is 200 pixels. I also will add a vertical margin of 8 here, and I will add justify content center and align items center so that if we show the fallback text instead of the image, that text is centered in the container. In addition, we can also give this container a background color of, let's say, colors. Of course, importing this colors constant here. And then choose a color of, let's say, primary 100, which is a light blue. I will also add some rounded corners with border radius 4. So that is the image preview style, which I will add to this container here. So that receives styles.image preview. The image itself will also receive some styles. Hence, I will add an image style object where I set the width to 100% of the container it's in and the height to 100%, which will be the 200 pixels set on the container that holds the image. So now it's this image style that's added to the image itself here. There we can add styles.image. With that, we can see this preview here already, now that this was updated automatically. Or if we go back and come back, we see this starting state. And then if we take an image here, like this, we can see the preview here. So now this preview is working, and it would also work here on iOS, but there, as you learned, we don't have a camera on the simulator. So now we're able to take images. The next step is to work with the user's location. But before we do that, I want to style this button differently. And that is, of course, 100% optional, but it is something I want to do here to practice this again as well. Now, for that, in Components UI, I will add another file, and I'll name it the outlined button.js file, because I want to create a button that has a border and no background color, and actually a button that is a combination of text and an icon. So for this here, I have my outlined button component function, which of course is exported as always. And then in there, we can return the pressable component, which we need to register presses. And in there, as I said, I want to have a combination of icon and text. Hence, from @expo vector icons, I will again import Ionicons here. So that inside of pressable, we can render an icon, and then next to it, the text with the text component exposed by React Native. Now, we need some configuration from outside, so I will destructure a props object, expecting a onPress prop, a icon prop, and a children prop. Children will be the text that should be displayed on this button, so it will be passed between the opening and closing tags of our custom component later. The name of the Ionicons icon here will be the icon we receive. And the pressable component will receive the onPress prop, which points at the onPress prop value we get from outside. Now we will also need some styling here with that styles object, like this. And I also want to make sure that on this icon here, we set a size of 18 and add the color. And the color here is colors, using my colors constant, which is imported, dot primary 500. And then here in this style sheet object, we can add a general button style, which will be added to the pressable component. then a pressed style, which should become active when it is being pressed, then a style for the icon, and a style for the text in the button. Now for the button itself, I want to have some padding horizontal, so left and right of 12, and a padding vertical of 6, and some spacing around the button, for which we can add margin, for example, to 4. We can then also add justify content center and align items center to make sure that all the content, so the icon and the text, is centered and that they are aligned on the same line horizontally and vertically. Then we can add a border with a width of 1 and a border color, which can be colors.primary500, so the same color as I chose for the icon. And I'll set flex direction here to row so that the icon and the text sit next to each other. And I will actually add this above my justify content and align items settings so that I have all the flexbox settings grouped together. This is not required technically, but can help with reading and understanding this. Now for the pressed style, as so often, I want to change the opacity to make it slightly transparent. And then for the style that will be applied to the icon, I just want to make sure that there is some spacing between the icon and the text. So here I will add margin right of 6 because the icon will be on the left side of the text. So by adding margin right, there will be some space between the icon and the text. Alternatively, we could have added margin left to the text. But here on the text, I'll now just set a color and set this to primary 500 as well, so that icon, text, and border of the button all have the same color. With that, all these style objects are defined, and they can now be added. Here on pressable, it's the button style that's added. On the icon, it's the icon style. And on the text, it's of course the text style. Now back here to the pressable style though, there I actually want to use a function and pass an array of styles then. And this function, as you learned, gets an object with a pressed prop, which allows us to conditionally add the pressed style to this button. But with that, the outlined button is finished, and I now want to use that here in my image picker. There, instead of using this built-in button, I'll use the outlined button. And for this, of course, we should import the outlined button, and we can get rid of the import of the built-in button. And then here we don't set a title prop. Instead, we use opening and closing tags and pass our title, our button caption between the opening and closing tags. And then we need to set the icon here. And here I'll set the icon to camera, which is one of the supported icon names by Ionicans. And if we save all of that, we got this nice looking button here, which I prefer over the button we had before. But of course, ultimately, it is up to you. So now we can take images. We also added this custom button. Now let's move on to the user location and to using a map and so on. So let's now continue with picking a user location. For this, just as I built the image picker for, well, the image, I'm now going to add a location picker component that will handle picking that user location. And here it's actually also important to understand that we will be able, or we will offer, two ways of picking a location, either by locating the user through GPS and so on, or by allowing the user to pick a location on a map. Now we will get started with locating the user though. So here is my location picker component, which is also exported here like this. And now in this component, we of course also want to have some JSX code. Now it's not that different compared to the image picker, because I also want to show a preview of the location here. I want to show a preview by rendering a little map where we highlight the user's location. And for this, we'll use Google Maps as an example soon. So in here, I want to have a view with another view that will give us the preview of that map. And below that view with the preview, I want to have another view with two buttons next to each other. Two buttons because one button should locate the user, whereas the other button should open a new screen with a full screen map that allows a user to pick a location on the map. So here we can then add our outlined buttons, these custom buttons we built in the previous course section. And the first button should locate the user. The second button should open a map. So I will say pick on map here. Now the icon for the first button is the location icon, which is one of the supported icons by Ionicans, and it's the map icon for the other button. And then here we need two functions. The getLocation handler, we could say, for locating the user, and the pickOnMap handler for opening a map and allowing the user to pick a location there. And the first button is therefore bound to getLocation handler like this. The second button receives a pointer at pickOnMap handler like this. Now we got these buttons set up, and now it's also time to add some styling before we continue. Therefore, I'll again add my styles object here with stylesheet create. And for this, I need to import stylesheet from React Native. And then here in this stylesheet object, I want to style my map preview. So this container that displays the map preview, and then my actions, as I call it. So this view with the two buttons. Now for the map preview here, I want to add a margin vertical of 8. Basically what I also did here in the image picker, and indeed I will copy that setting here from the image picker and use that here for the styling of the map preview, because those preview containers should look pretty similar. Of course, that's not a must do, but it is something I will do here. And therefore, only the actions are left, and here in the end I will set flex direction to row so that the two buttons sit in the same row. And then I will add justify content space around to add some spacing around the buttons and align items set to center. And with that, we can add those styles. We can add a style here to this view which holds the preview later. So here we will add styles.mapPreview. And then on that other view that holds the buttons, we can add this actions style. Now we can use this location picker in the place form, and there, just below the image picker, I will add the location picker. By the way, these pickers later also need to communicate with that place form so that the images and places picked in those pickers are available in that form so that we can use them there later. For the moment though, we can ignore this. We will work on this later in this section. So for the moment, I just add this location picker here below my image picker. And with that all done, I get an error. Can't find variable colors, which makes sense because in location picker, in the styles, I'm referring to the colors constant, but I'm not importing it. So of course, we should make sure that this import is added in that location picker file. And with that, those apps now reload successfully. So now here, we also see this location picker down there, but of course the buttons don't do anything. And that therefore is the next step, starting with the locate user button. How can we locate a user with this locate user button? Well, for this, we need to talk to the device again and ask the device for the user's position. And this again requires the usage of native device features. And again, thankfully, it is pretty easy to use this functionality. If we search for Expo Location, we find a package that helps us with the Expo Location package. This is a package that allows us to get geolocation information from the device, so information like the current position of a user. Again, you find installation and configuration instructions here as well, including instructions on how to use this package if you're not using Expo, which is possible. And then we can copy this and run this expo install expo-location command in our project folder to install this package. Now, installing the package is the first important step, but we also need to talk about permissions again. And for this, the official documentation again is the place to go. Now, location requires some permissions, especially if you need advanced forms of this package, where you are, for example, interested in getting the location whilst the app is in the background. This is possible, but requires special permissions and special configuration, as you learn here. Now, our app does not require the location of a user whilst running in the background, so we don't need to care about this, but if you're building a different kind of app, you should go through these instructions as well. For us, this app requires some permissions, but thankfully, it will basically handle those permissions automatically. It will take care about these permissions automatically, and therefore we don't need to do anything special here. Still, you should always have a look at your different configuration steps here. Now, with that all set up, we can use this package already though. We don't need any extra configuration, as you can see. And we want to start with this getLocationHandler function, which is triggered when we click this locate user button. There, we want to use some functionalities from that Expo location package. Therefore, I will import something from Expo location, and that something here is the getCurrentPosition async function. That is a function exposed by the package, which will give us the current position of the user, and we can then use this position in any way we want. So therefore now here in getLocationHandler, we can call getCurrentPositionAsync, but again, it's called async because this operation will take a bit longer. Locating the user is not an instant task, though it might be really quick, but it can take a bit longer, and therefore this actually returns a promise, and therefore I will again use async await for convenience here. Now what we get back here will be the location of the user, which will be an object. And I will console log that location here so that we can see what's inside of this object once we have the location. Now you can also pass an object to getCurrentPositionAsync to configure this, for example, to configure the accuracy or an interval that controls that this location is fetched every X seconds or so on. But here I don't want to do that. I will therefore not set any such options. Now, just as before, if we save this, we will not get the desired result though. On Android, if I tap this, it looks like nothing is happening, but then I get a warning. And on iOS, it's the same. And we are getting these warnings because of permissions. Yes, we don't need to configure anything special here. We don't need to announce as part of the app configuration that we are using the location, because Expo or this package will do this for us. But we still need to ask for permission as part of our code, just as we did it with the image picker. There we also had to ensure that we have appropriate permissions. For Android, we didn't have to do it there, but for iOS we did. Now for the location, it is required for both devices, for both operating systems. Now the approach is the same as before though. We can add an async helper function that could be called verify permissions. And in there, we again want to check if we already have the permission and request it if we don't. Now, just as with the Expo image picker package, we can use a special hook for this, the use foreground permissions hook, which we can execute and which gives us an array with two elements. The first element is location permission information object. The second element is a request permission function. So it has the same functionality as the camera, the use camera permissions hook did. Now, inside of verify permissions, we can then use this information. And we can really copy the code from the image picker, and we could therefore, of course, also kind of build a reusable shared component or helper function, but I will just copy it like this from image picker into verify permissions in the location picker. But of course, instead of the camera permission information, we have the location permission information. It has the same status field though, so that does not change. We have the same permission statuses, but we need to import permission status now from Expo location. And we also need to import the alert API in order to show an alert if we have permission issues. There, I then want to say you need to grant location permissions to use this app. Now with that, we got this verify permissions helper function, and we can now, of course, use this function again. For this here in getLocationHandler, we can await calling verify permissions, and we get back true or false telling us whether we have the permission or not. And therefore we can then check if we don't have the permission, in which case I want to return and not continue with the function execution, just as we did it in the image picker. There I also returned because we can't continue if we don't have the appropriate permission. Otherwise we will continue and we should be able to get the position of a user in the end. Now, if we save all of that, we can go back and give this a try. And if I press this button here on iOS, I get this permission dialog now. And if I allow this, we don't get any visual feedback at all because we haven't added any logic that would do that, but I get a little object logged here with information about my position. It's an object with a coords property, which is another nested object with a latitude and longitude coordinate, and then also a timestamp. Now it should also work on Android. There I now have to grant permission. But in my experience, fetching the user's location on the Android emulator can be clunky. You see here I'm not getting any new log because indeed it just doesn't fetch the location. It also doesn't crash, there is no error, but fetching the location fails. You can try playing around with those settings here, but I was not able to make this location feature work here in my case. Therefore, I can only show this on iOS here. It will work on a real Android device though, and it will work on a real iOS device as well as the iOS simulator. So here the Android emulator is the problem. The code is correct. And therefore, with that, we are able to fetch a user's location. As a next step, I now want to show a preview of that location by showing a little map here after we fetch the location, before then thereafter we work on a full screen map. Now to show a little map preview, I will use Google Maps and I will use a specific API provided by Google Maps. The Maps Static API. Now, this is definitely not the only way of showing a map, but it is a popular way and it is simply a demo here in the end. You should be aware that if you want to follow along, you will need a Google account and you will need to add a credit card to this account. You should not be billed for the amount of usage we have here in this demo, but you need a credit card and a billing account nonetheless. You can check the pricing pages to learn what will cost you money. And again, the amount of usage we have here should be free since you have a free usage every month. And we definitely don't use Google Maps close to enough to exceed this billing here. Nonetheless, you need a billing account, otherwise you can't follow along, but of course you will still be able to follow along with the rest of this section, you just can't add this Google Maps based preview here. But that's not the end of the world, you will still learn all the other things. Now here in my case, to use this Maps Static API, I will sign in with my Google account, and once signed in, you get instructions on how to use this static API here. And it is super simple to use. In the end, you can construct links like this that contain your API key, which you can get as soon as you signed in. And then this will return you an image of a map with the markers and the map region defined as part of this URL. And it's this image which we will output as a preview in here. Therefore, in order to do all of that, we need such an API key. Once you logged in, you can click on your API key here to choose a project and create an API key. And you should be able to create a new API key and a new project if you don't have any. Alternatively, you can also click on Get Started here to be taken to the Google Cloud Platform console and there to the Google Maps platform already. And you can then select a project here as well, or create a new project. And that's what I'll do. Name it React Native course. Choose your organization and location and create that project. And then there you can go to APIs and make sure that under enabled APIs, you have the Maps static API. There also are some other APIs here, and we will need some of these APIs later as well. Then you can go to credentials and make sure that there you have an API key, or click on Create Credentials and create an API key. Now that is an API key that you can use to send such a request. You can also restrict that key to be only usable in certain apps and so on, but here to keep things simple, I will keep this API key like this, unrestricted. And now back in our code, we can use that to send a request to this static API endpoint to get back such a map image. Now for all of that, I will add another folder in my project, the util folder, where I add a location.js file. And in this location.js file, I will add a new function, getMapPreview. And in there, I want to create that URL that returns me that image. Now in here, I will also set up my Google API key stored in a constant. And you don't need to try using mine. It will be gone after I finished recording this. So you need to bring your own API keys here. And then here in getMapPreview, I want to construct a link that points to such a preview image. For this, we can go back to the static API docs. And in the end, it's this URL, which we have to tweak a little bit though. So we can now get our image preview URL here. And I will create a string with the template literal notation here, so with 2 backticks, so that we can easily inject dynamic content into this string. And then here, this is my URL, but now it needs to be tweaked. For example, here after center equals. I don't have an address here. Instead, I have some coordinates. And thankfully, instead of passing a human readable address after center, you can also pass a pair of latitude and longitude coordinates. For this, I will inject 2 pieces of data here, separated with a comma. So the comma here in between is important. And the data injected should be the latitude and longitude, which I expect to get as parameters. So here I inject my latitude coordinate and here my longitude. Thereafter, we can set the zoom level, and I'll set this to 14. And for the size, I need a smaller image. I will use 400 by 200. That should be enough for me here. Now the map type can stay set to roadmap. But then here, for my markers, I only want to add 1 marker on the map, not a ton of markers. So I will actually delete all these markers except for 1. And for this 1 marker, I will choose a color of red. Then I'll keep that label, but here, after the C, we will again inject our latitude and our longitude, so that we have a nice marker in the center of the map, because that will be our position, our address. Then I will make sure that this is all one long string again. And now with that, I got my URL here where latitude and longitude is injected. And we then in the end also inject our API key. So here I inject my Google API key. That's now the URL, which can be returned here by getMapPreview, this image preview URL. So this is a helper function that constructs this URL. I want to use it in the location picker component though, because there I have my preview. Now here, in this view where the map preview should be shown, I therefore now want to output an image here using React Native's image component. And the source is set to an object where the URI should be that preview URL we are constructing in that util location file. Now, of course, this only makes sense once we have a location. So similar to what we did in the image picker, we want to manage some state here in the location picker to find out whether we have a picked location or not. So we use state here, imported from React, and we have a picked location here and a set picked location state updating function. And initially that is null, that is undefined. But in the get location handler, instead of logging the location here, we can now call set picked location and set our location to an object where we have, let's say, a lat property and a longitude property. Lat is simply our location, which we're getting here, dot coords. As you can see here in the terminal, we have this coords nested object. And then there we got a latitude and a longitude property. So now these are the nested properties I want to access here. Latitude and location.coords.longitude. And this object is now my picked location, which I want to set here. Now we can use that down here to get our URL. Here I want to use my utility function, getMapPreview, which therefore must be exported. And with it exported in the location picker, we can call getMapPreview here and simply get our preview by passing the picked location latitude and the picked location longitude, the lat and lng properties as parameters, as arguments to getMapPreview. Of course, we only want to do that if we have a picked location. So just as before, we can add a helper variable, location preview, which initially just stores some text where we say no location picked yet, and where we then check if picked location is truthy, so if we have a picked location, in which case location preview then will store this image. And then here in our view down there, we output location preview, which is either the text or that image. Now we just need some additional styling. So the map preview image style object can be added here, or just image to keep it a bit shorter. And here I want to give this a width of 100% and a height of 100% so that it takes the width and the height of the map preview container which holds the image. So therefore now here it is this style which is added to this image, this styles.image style. With that we should show a map preview after picking a location. If we save everything and we reload everything, if I go back to iOS and I locate the user, this image shows up. By the way, that's not my real position. Instead, as a default, we get some location in San Francisco here on the iOS simulator. With that, this works. And in case this is not working for you, check your Google setup here. Make sure that you have a valid activated API key, that the static API is enabled, and that your URL here is correct. You can also use the downloadable course resources, the code snapshots, to verify your code. Just make sure to bring your own API key because mine won't work for you. But with that we got this preview, we are able to locate the user, and therefore we made another major step forward. As a next step, I now want to make sure that we can also open a full screen map where users can pick a location. Though before we do that, there's one glitch I want to fix, and that is this map preview here. Of course, it would be nice to have rounded corners there as well. The same is, by the way, true for the image preview in the image picker. And therefore here in location picker on my image, I will also add a border radius of 4. So the same border radius as I had here. Alternatively, we can add overflow hidden here. Both approaches would work. And I'll do the same here in the image picker. There I also add overflow hidden or a border radius to the image so that the rounded corners persist here. But now with that, let's move on to picking a location on a map. So let's now continue with that pick on map functionality. For that, the goal is to open a full screen map whenever this button is pressed. Now for that, we already added this map screen at the very beginning of this course section, but at the moment this screen component file is empty. I'm going to change this now by adding my map component function in there. And in this component function, I now want to return this full screen map that should be rendered. And that brings us to another third-party package provided by Expo. If you search for Expo Map View, you will find the Map View package, which is a package that helps with rendering maps, Apple Maps or Google Maps, as part of your React Native apps. Under the hood, it uses another React Native community package, and it works just like this. And it's super easy to set up and use in Expo apps. You can also use it in non-Expo apps though. As always, you should definitely take a look at the configuration options here and the installation instructions. For our Expo managed app, we just need to run this one command here though. So again, I'm going to install this package, this time with expo install react-native-maps. This installs this extra package into our project, and as before, we can of course also learn how to use it here and also in the official documentation of this third-party package, which is in the end just wrapped by Expo, so to say. Here you can learn way more about this package, about the installation and the usage of this package. So definitely take a detailed look at this documentation as well if you plan on using maps in your applications. You also should be aware of the configuration options mentioned down there, which become important once you start deploying your app, once you start publishing your app to the app stores, something we will do later in the course as well. Then additional configuration might be needed to make your maps work for both iOS and Android. So that is also something to be aware of. For development, however, we don't need to worry about that, and we can just start using this package. To use it here in map, in my map screen, we can return a map view component here. And map view is imported from React Native maps like this. In addition, I will also import one other named export, the marker component, so that I can not just display a map, but also a marker on that map. Because the map view component will render a map, and marker then can be used to place markers on that map. Now, of course, the map should be configured though. We want to tell React Native and this package in the end which region of the world should be visible on the map. And we do pass this information to map view with help of the initial region prop. I don't get auto completion here, but if you take a look at the official documentation, you'll learn that such an initial region prop can be set on the map view. And this will control which region is visible on the map when it's first loaded. Now, this initial region that is set here should then be an object with a certain set of properties, which is not up to you, but defined by this package. And again, you learn all about that here if you take a look at the official documentation. Now, here the object that we have to pass as a region to initial region is an object that has a latitude, property written like this, so not just lat, but latitude, a longitude property, and then also, very important, a latitude delta property and a longitude delta property. Latitude and longitude will define the center of the map, and the deltas will basically define how much content besides the center will be visible. It indirectly sets the zoom level of the map. Now here for the moment, I will just set some hard-coded coordinates. For latitude, I'll choose 37.78. For longitude, I'll set minus 122.43. And for the deltas, I chose some deltas in advance, which give me the zoom level I want. And that would be the numbers 0.0922 for the latitude delta and 0.0421 for the longitude delta. And this will now render us a nice map with this as a starting region. Now, in order to view this map, we must make sure that we can reach this screen. And for this, of course, we can go to app.js and register a new screen here in our Stack Navigator, because up to this point, I haven't registered this map screen yet. But now I will add a new screen named map, and the component at which we point here is the map component, which we import from the screen's map file. So this screen is registered here. The map component is imported from our screens file. Now we just need to navigate to that screen. And that should be done from inside the location picker. Here in the location picker, we don't just have the getLocation handler, we also added this other handler function, the PickOnMap handler. And it's that function where the map should be opened. Now, how do we open this map screen? As we always do, we navigate to that screen with help of the functionalities provided to us by the React Navigation package. Now, since Location Picker is not a screen component, we don't get a navigation prop here. That won't work. But we can use the useNavigation hook, of course. So here we can call useNavigation, which must be imported from @reactNavigation/native. And this will give us a navigation object, which has a navigate method. So now with that set up in PickOnMap handler, we can call navigation.navigate and then enter the name of our screen, which in this case is map. And that should be all. If we save that and force a reload maybe, if I now click on PickOnMap, this screen opens up, but there is no map. And there is no map because we need to style this map in order to see it. So in map screen, we also must add some styling to the map. Though no complex styling is needed, instead the only thing we need to do here is create a style sheet, for example, as we did it many times before, and set up a map style object where we set flex to 1. And that's the only thing that's needed. This style should now be added to the map view through the styles prop, which is supported by it. And that will then make sure that the map takes all the available space and therefore becomes visible. With this, if we now click this, we got a map. And here on iOS, it's the Apple map. We can also now navigate around on it, so that all works as you would expect it to work. And on Android, we get Google Maps, and we can also navigate around there. So now this opens up. Now we got this map screen with a map centered around an initial region which we set up. Now, of course, the next steps are all about making this app clickable or pressable so that we can select a location and then giving us a way of confirming that picked location. So we are able to display a map now. The next step is to make it pressable to detect when the user selects a place. And this again is quite simple because map view has an onPress prop which will be triggered whenever the map is pressed, and it will give us an object with information about the place on the map where the press occurred. So it will give us the coordinates that were selected by the user. That will be very convenient, of course. So therefore, all we have to do here is add another function to our map component, the select location handler function, which will get an event object. And it's this select location handler which we connect to onPress. Now in here, we can then get the selected latitude and store it in a constant by diving into event.native event, as it turns out, .coordinate.latitude. And we could, of course, console log the event to the console here to learn its structure if we wanted to. Now, this is the structure it will have, though. We will be able to get the selected latitude like this, and we can use the same approach for getting the longitude, accessing the native event, the coordinate, and then there the longitude like this. With that, we got these two key pieces of information, and as a next step, we can now use that information to add a marker to the map to show the user that we registered the tab and that we registered a certain location. For that, we want to add some state to this map screen component as a first step, imported from React, of course. The state which we have here is the selected location with the set selected location state updating function. And then here we can call set selected location and set this equal to an object where we store the latitude and set this equal to this latitude, and store a LNG property which is equal to this LNG property. And I'm doing this because now the component will be re-evaluated after selecting a location, and we can use this state to add a marker now, with help of this marker component which we're already importing. This can be rendered inside of our map view like this, and marker just wants to get a coordinate prop, which is an object where coordinates are set up in a certain way. To be precise, it's an object where we should have a latitude property, which we can now set equal to our selected location .lat. So our state object has a lat property. I'm accessing that here. And we set a longitude property written like this in this object, which we pass to coordinate, which can be set equal to selected location.lng. Alternatively, we could have chosen latitude and longitude as property names in our state object and then use the state object itself here as a value for coordinate. Here I'm doing it like this though. We can also give this marker a title, and here I will give it a title of picked location. With all that done, we should be able to reload this, open the map again, and I'm getting an error that we can't access selected location.lat. The reason for this is, of course, that I'm always trying to render this marker even if we have no selected location yet, which of course means our state is undefined and trying to access lat or LNG will fail. We should instead render this marker conditionally by checking if we have a selected location, if that is truthy, and only rendering the marker if that is the case. Now with that, if we save this and we reload this here, it should work. And we should be able to click this, open the map, and if I tap here, a marker gets added at the place where I tapped. So that is working, and this will also work on Android. Here I can also tap to add a marker in the place where I did tap. So now with that, we are able to choose a location and we get some visual feedback here on the screen. Now I want to add a header icon that allows me to save this chosen location so that the location is then passed back to this screen, and on this screen we can then use it to show a preview again. So let's start with adding an icon button to the header that allows us to save and confirm a location. So let's make sure we can confirm a chosen location. And for this, I will add a new function here to my map screen component, and I'll name this function SavePictLocationHandler. This function should be executed once a to-be-added button in our header was clicked. Now, in this function, I want to check if we maybe don't have a selected location. If we don't have it, hence the exclamation mark, I want to tell the user that a location must be picked first. We can do this with the alert API, which is imported from React Native. And then we could say no location picked. And the message could be, you have to pick a location by tapping on the map first. So we show this feedback and then we return to make sure that we don't continue with the function execution if no location was picked. If we make it past this if check, we know that we have a picked location. And then, of course, we want to go back to the place form, so to the add place screen in the end, where we need that location. Now we can go back with help of the navigation prop, which we do get in this map component because this component is a screen component registered as a screen. So now we can use this navigation prop here, and we could go back by calling go back, but the more elegant approach, which allows us to also pass some data along, is to call navigate and go back to add place. React Navigation will automatically detect that this is the screen we're coming from and play the appropriate back navigation. So it will automatically handle this correctly, but by using navigate here, we can pass a second argument to navigate to pass some parameters to that screen. Yes, you can also do that when going back, because we're still navigating from screen A to B, or in this case, maybe B to A, but still, it's a navigation from one screen to another. Hence, when using the navigate method, we can pass some parameters along, some data. And here, the data which I want to pass along is my picked location, which is my selected location object. Alternatively, we have a picked latitude, which is selected location.lat, and a picked longitude, which is selected location.longitude. And I'll use this approach here, but both would work. So this will now pass the data back, but of course this function is never being executed at the moment. It should be executed once a to be added button in the header, to be added here, is clicked. And therefore we need to add this button and then connect it to this function. Since this function is part of my map component function, and it must be part of that function because we are relying on the component state, we should set our header options to add this header button from inside this map screen component. And you did learn how this can be done with help of use layout effect, which is imported from React. Use layout effect allows us to run some code right when this component is rendered for the first time. And the code I do want to execute in here is in the end the code to add this header button. Therefore, we will access the navigation prop and call setOptions and pass some options to it. And the option I want to set here is the header right option, which wants a function itself, a function where we can extract the tint color, as you learned before, and where we then return the JSX code that should be added on the right side of the header. In this case, I want to add an icon button, so that is the code I will use. And of course, icon button, in order to use it down there, must be imported from our components folder. But then we can use it down here, and we can add the icon prop, and I'll set it to save, which will give us a nice disk icon, and then set the size to 24 maybe, set the color to the tint color we're getting from React Navigation. And on press, I now want to execute this SavePictLocationHandler. So I will point at SavePictLocationHandler. That is my configuration for the icon button here. Now, since this is in use layout effect, we should add all the dependencies of this effect here. And the dependencies are the navigation prop here, which I'm using in this effect function, and also the save picked location handler function. And since I'm passing a function here to avoid multiple re-render cycles or potentially even infinite loops, I will wrap this save picked location handler function with React's use callback hook. For this, I'll convert this into a constant, which holds an arrow function. So it's still a regular function, just written differently. But now we can wrap this arrow function with use callback, which is a hook imported from React, which helps us ensure that a function defined inside of a component is not recreated unnecessarily. For that, you add a second argument to use callback. The first argument is the function itself. The second argument is a dependency array, just as in useEffect. And then you can add your dependencies here. And here the dependencies are navigation and the selected location state. So whenever the navigation prop or the selected location state value changes, this function will be recreated, otherwise it won't, and this can help us improve performance a little bit by avoiding unnecessary re-render cycles or even help us stop infinite loops. And it is required because this function is used as a dependency in another effect, and I want to avoid that this effect is re-executed unnecessarily. With all of that out of the way though, we are setting this option, we are adding this header button, and this header button should take us back to the previous page. If we save all of that, if I try to hit this button, which we can see now, without picking a location first, I get this alert. But if I do pick a location, we do go back. We don't see the location yet because we're not using it here, but we can go back. And it's the same on Android. We either get the alert or we go back. So that's working. Now as a next step, we have to work with that picked location here on the add place screen when we are coming back from this map screen, but only if we did pick a location there, so that we update the preview with that picked location as well. So now we need to deal with a location that was picked on this map screen once we're back on this place form screen or in the place form component, which is loaded by the add place screen. Ultimately, it's still the location picker component in which we want to work though. There we are interested in getting the data from the map screen because there we have this preview for the location which we want to update after a location was picked on the map screen. Now, how can we get access to the data provided by the map screen from inside this component though? With help of another hook provided by React Navigation. We can use the use navigation hook, which we are already using, to get hold of the navigation object, which helps us to navigate, for example. We can also use the use route hook here to get hold of route parameters, so of data passed from another screen to this screen. We don't have to do this in this component. We could do it in another component as well and then pass data to the location picker through props. But since this picker will only be used in a place where we want to have that functionality of picking locations on a map, we can also simply extract the route parameters directly in this location picker component. Therefore, besides calling use navigation here, I will also call use route to get my route object. And that route object can then be used to get my parameters, my route parameters. Now I'll do that here. I will add a constant, the map picked location, let's say, where I check if route params is truthy. So if we do have route params, which will be the case if we are coming back from the map screen, but which will not be the case when we first visit the add place screen. So if I'm coming from the starting screen and I land on this screen, then we won't have any route parameters because then no parameters are passed as part of the screen navigation. But if we are coming back from the map screen after picking a location, then we will have route parameters. But that's why I'm checking this here, if route params is truthy. And if it is, then my picked location will be an object where I set a let property which should be equal to route.params.pictlet. Pictlet, because in the map screen, when going back here, we are setting a pictlet and a pictlng property. So these two properties can be extracted now, and here I'm extracting the pictlet property. And then lng is set equal to route.params.pictlng. Else, after this object, we don't have any route parameters, so then my map pict location should be null. And hence we can also shorten this just as we do it sometimes in JSX. We can use the AND operator here to only set map pict location equal to this object if route params is truthy, otherwise it will be undefined. So now map pict location might contain such an object, depending on whether we got that data from the route params or not. And if we do have this object, we of course want to use those parameters to show a preview. Now to show a preview, I in the end want to set my pict location, because that is what I did before as well when we located the user. Therefore, we can add useEffect here, the normal useEffect hook imported from React, to register a side effect, so to execute some code conditionally. In this side effect here, I want to check if map pict location is truthy, so if we do have an object in there. And if that's the case, I want to set my pict location equal to this map pict location. Now, pict location is set to an object with lat and lng here in the locate user scenario as well. And I have an object with a similar shape now if a location was picked on the map. So I can set my state to this map pict location object, which also has this shape with lat and lng here. So with that, I'll update my state whenever we got new route parameters. And my only dependency here is this map pict location constant here. The effect should rerun whenever the value here changes. With that, we should be able to update the preview once we pick the location. If I pick a location on my map here, I go back, but it's not reflected. Why? So we have the problem that our location here, our preview, is not updated even though we picked a place on the map. Now, the reason for that is that actually, when we go back from a screen to another screen, so when we go back from the map screen to the add place screen, that add place screen, that component and all its child components is not recreated. Instead, when using the stack navigator and you go from one screen to another, that new screen is simply pushed on top of the stack of screens, but all the other screens, for example, the add place screen when going to the map screen, is preserved. The component is kept around. If we then go back to the add place screen, the add place component is not recreated, and neither are its nested child components like place form or ultimately the location picker component. Because of that, the component is not re-evaluated and our effect function doesn't run again. To work around that, there is another useful hook we can use from React Navigation. It's the useIsFocused hook. This hook can be called like this, and it simply returns a boolean, which I'll name isFocused. This will be true if the screen is currently focused and false otherwise. So when we move from add place to the map screen, this will yield false. I'm calling this in a component which isn't a screen component, but of course this location picker component is part of a screen component, so this will be true whenever the screen component to which this component belongs is the main screen, and it will be false otherwise. Therefore, this will switch to false when we enter the map and true when we come back from the map. Therefore, here in useEffect, we can change our code a little bit and move this map picked location constant into useEffect like this. And then add route and isFocused as dependencies. And simply check if isFocused is true and route params is truthy, so we have route params. Then
I want to create my map pick location. And now here I don't need to check for the truthiness of route params anymore because I'm doing this here. And we can then simply call set pick location like this and get rid of this if check. If we restructure use effect like this and we take advantage of this is focused state here, then if we save this now and force a reload, we should be able to pick a location on the map and see a preview. Here we go. Now we got a preview, and this also should work on Android. There, if we pick a location and save this, we also load a preview there. And of course, the preview reflects the location we picked here on the map, as you can tell. So now this also works, and we learned about a new feature and a new behavior of the React navigation package and how we can work around it with help of the useIsFocused hook. With that, we're now also updating the preview after we're picking a location on the map, and therefore we are now able to take a picture, at least here on Android. There, we can take a picture now, as we saw before already. We can pick a location, and of course we can also enter a title, so now we can finally work towards our final goal of making this form submittable and storing all that data on our device in some device storage. And therefore these are the things and features we will work towards in the next lectures. So the ultimate goal is to make this place form submittable. For this, of course, it also needs a button because at the moment there is no button. Of course, we can add one here in place form below our inputs and our pickers. We can add a button, and for this, I want to build another custom button. I have an icon button and an outlined button. Now I will add yet another regular button. Now in button.js, we can create a button component function as we did it multiple times before and export it. And then my button will be a pressable component wrapped around some text, both imported from React Native. The button should be configurable. OnPress is a prop that should be set from outside, so from inside the place where our custom button component is used. And I get the children prop so that we can pass the caption of the button between the button opening and closing tags. And then we can set onPress to onPress and output children between our text component tags. Now, of course, we also need some styles here. And for this, we will, again, of course, create a style sheet. And then, as always, the exact look is up to you. But I want to set up some styles for the button, for the pressed state of the button, and for the text of the button. Now, when the button is pressed, I simply want to set the opacity to 0.7 to have some slight transparency. For the text, I want to set text align to center the text. And I want to set the font size to 16 to ramp it up a little bit. And then for the button itself, there should be some horizontal padding, let's say 12 pixels, and some vertical padding of 8 pixels, and a margin around the button of 4 pixels. In addition, this button should have a background color, which can be set to colors imported from this colors constants file. And the color I want to choose here is primary 800, which is a dark blue. The color of the text, therefore, should be colors.primary 50, which is a very light blue, almost white. Then I want to add a shadow with elevation 2 and some shadow properties for iOS, like black as a shadow color, then a shadow opacity of 0.15, let's say, a shadow offset to the width of 1 pixel and height of 1 pixel, for example, and a shadow radius of 2. Last but not least, I want to add some rounded corners, so we can set the border radius to 4 here. And these are my button styles. Of course, you can bring your own styles if you want to. With that, we can add them here. So on pressable, we use this function form as we did many times before to return an array of styles.
where we always set the button style, but then we check the pressed property, and if it's true, we also add the pressed style. And on the text, we of course set the text style. That's my custom button, and I want to use this button in the place form component below those pickers now. So here we can add the button, and of course therefore also add the import to this button component. And then on this button, or between the button tags to be precise, I want to say add place, and then add the onPress prop, which should point at a function that is executed when this button is pressed. And that will be the savePlaceHandler function. This is the function responsible for saving the place on the device. However, right now we do get the title here. We are saving that in the entered title state, but we are not getting the picked image or location. Those are used for preview purposes inside of the respective pickers, but we're not passing the data back to the place form component. And of course we should do this in order to store and ultimately submit the picked location and image and the chosen title from inside this place form. So how should we pass the data from the image picker and from the location picker back to place form? Well, just as the text input provides us with the entered text. We could expect to have some prop on image picker that could be named onImageTaken. The name is up to you because it's your component, but we could expect to have this kind of prop on this picker. For the location, we could expect to have onLocationPick prop. Again, the name is up to you. Or maybe to be in line with onChangeText, we could have onTakeImage and onPickLocation. These props could exist on these components. Then we could add more handler functions, like the ImageTaken handler or the TakeImage handler to again be in line with the name I chose here for the title, and also add a PickLocation handler. Just as with the title, we could then manage some extra state here. We could have some state for the picked location and some state for the selected image. So here I have the picked location and the setPickedLocation state updating function. And I also have the select image and setSelect or selected. So selected image and set selected image, a state updating function. I got these two state slices now in addition to the title state slice. And now inside of TakeImageHandler, we could expect to get the image URI and then set the selected image equal to that image URI, just as we set our title equal to the entered text, which we get in this function. For the location, we could expect to get our location here and call setPickedLocation and set it equal to the location we are receiving as a parameter here. And now those functions can be passed as values through these props to the image picker and the location picker. For the image picker, we want to pass in our TakeImageHandler function here. And for a location picker, we want to pass in the PickLocationHandler function. And now these functions here, which we just added, will update our state in place form. We can then use this state later for submitting all our data, but now we must make sure that these functions are called from inside the image picker and the location picker. Now, since we pass them to these pickers through the onTakeImage and onPickLocation props, we must call these props as functions inside of these components. So starting with the image picker, there we want to call this onTakeImage prop, which will be that function in the end. We want to call that whenever an image was taken. Now we got our TakeImageHandler in here, and there we do set our picked image. Here we now also want to call onTakeImage, and forward our image URI to this function as well, so that we don't just manage the image URI internally in this component for preview purposes, but so that we also pass it back to the placeForm component. Of course, in order to use onTakeImage in here like this, we must use it or accept it as a prop, so we must destructure it from the incoming props object. And we can do something similar in the location picker. There, I also want to destructure some props, and I expect to get the onPick location prop here, because I'm setting it here when using the location picker. So we can destructure it in here. And now we want to call this function whenever a location was picked. Now, in the end, a location is picked when we located the user or when we picked a location on the map. Either way, it's fair to assume that setPickedLocation will have been called and the picked location state will have been updated. So in order to execute this function with the latest state, whenever that state changed, we can add another effect with useEffect here. Here our dependency is picked location, therefore we don't need to worry about this component being focused or not. Whenever the picked location state was changed, the component will be guaranteed to be re-evaluated, because that is how React works. If a component state changes, the component is re-evaluated. So if we add the state as a dependency here, this function will be re-executed. And in this function, we can then call onPickLocation and forward our picked location. Now, technically, since onPickLocation is called in this effect, onPickLocation is now also a dependency which we should add here. And to avoid unnecessary re-evaluations of this component function or even an infinite loop, I want to make sure that the function that is received on this onPickLocation prop doesn't change unnecessarily, because whenever it does change, this effect function will be executed again. Therefore, in the place where the function for this prop is defined, in the placeForm component, I want to wrap this pickLocation handler with useCallback. So I will change it to a constant, like this, and wrap it with useCallback, which is imported from React, so that we can set the dependencies of this function, which is an empty array because we have no external dependencies here. Only the state updating function, which could be added, but which can also be omitted because React guarantees that it will never change. So therefore now we ensure that this function, the pickLocation handler function, isn't recreated unnecessarily, and we therefore avoid running this effect inside of location picker unnecessarily. Now with that, we should call onPickLocation whenever we picked a new location, no matter if we picked it by basically locating the user or by picking it on a map. Either way, onPickLocation should execute. And therefore, ultimately now, both takeImageHandler and pickLocation handler in the placeForm should be called whenever an image was taken or a location was picked. And therefore, we are now gathering more and more data here in placeForm. To see that this all worked, on the SavePlace handler, which is executed when the Add Place button is pressed, I will simply console log the entered title, console log the selected image, and console log the picked location, so that we see that all that data did arrive successfully inside of the placeForm component. Now, if we test this on Android, since there we will be able to take an image and pick a location, if we test it there, we can enter a title, of course. We can then take an image, and here I restarted the app basically, or I reinstalled it, which is why I have to grant permission again. But then we can, of course, take that image and confirm this. And we can then also pick a location on the map, like this. If we do all these things and we then click Add Place, we should be able to see something in our log. And there we should see all that data we gathered. The title,
the path to the image, and our location object with the latitude and longitude. So gathering all that data and collecting it with state and our functions here in place form does work. Now that is another huge step forward, and we're one step closer to saving that data on the device, but there's one piece of data that's still missing, and that would be the human readable address. In my model, I also added this address property to my places, and I want to get that besides my location object, which holds the latitude and longitude coordinates. Therefore, in the next lecture, we will learn how we can translate such coordinates to a human readable address, and then we will have all the data we need to really start creating place objects, which we can then also store on the device. So how can we convert such a picked location to a human readable address? We can again use an API provided by Google. In this case, the geocoding API, which you can find if you search for Google Maps geocode. Now this is another API to which we can send HTTP requests, and this is an API which allows us to translate addresses to coordinates and coordinates to addresses. The latter is called reverse geocoding. Now we already did create a Google Cloud Platform project, so we can easily get started here with this geocoding API. We just need to make sure that we actually have this API enabled. For that, if you're logged into your Google account, under APIs, you should make sure that the geocoding API is enabled. And then we can use the same API key as before to talk to that API. For that, of course, you should make sure that under credentials for this project, you have an API key. In this case, I even have two, but you should at least have one. And that's the API key you want to use here for getting that map preview. And that's also the API key we will use now for translating a location or a pair of coordinates into a human readable address. To do that, back in our code in the util folder and there in the location.js file, we can export another function which could be called getAddress. And this function wants to get a latitude and a longitude coordinate as well. It will be an async function because I want to use await in this function, because in here I want to send a HTTP request with the fetch function, which is built into JavaScript, also available here in React Native apps. Alternatively, we could also install Axios again, which is a third-party library we used before in the course for sending HTTP requests. In order to show both, I'm going to use the built-in fetch API instead here. So fetch allows us to send HTTP requests. And if you go back to the geocoding API documentation, you also learn where to send requests to. In our case, it's the reverse geocoding request which we want to send. Now here we learn all the details about this request, including the URL to which the request should be sent. So we can copy that and then construct this URL here in our code. So here again, I will use a template literal with backticks so that we can inject data. And then here we have to inject our actual latitude and longitude coordinates, starting with the latitude and then followed with the longitude. So these are the two parameters we're getting injected into that string, separated by a comma after this lat_lang query parameter. And here at the end, we also inject our API key, the Google API key. That's the URL we now want to send a request to. And we want to send a regular GET request. And you can learn more details about the request and the response that will be returned in the official documentation, of course. Now, here I will simply pass my URL to fetch and then await the result of that to get my response. That's how the fetch API works. The fetch function, it gives us such a response object once the promise generated by fetch resolved. Now I then want to check if my response is maybe not okay, which we can do with the built-in OK property on this response object. And if it is not okay, if we got an error code, then I want to throw a new error where I say failed to fetch address, so that we also handle the case that we get back an error response code. If we make it past this if check, we know that we successfully sent a request to Google's API endpoint and that we get back some address data. So now we can get our response data by calling the JSON method on the response object and awaiting that, because JSON returns a promise which eventually resolves to the actual response data. And then we can get the address by diving into this data and there into the results array, which we'll find in there, and then the first result, and there the formatted address. How do I know that? Well, I know that because of the official docs. That's the kind of response we'll get back. There will be a results array in the response, and we can then get the first element of that array, and in there we will find a formatted address field, which gives us the human readable address. And that's exactly what I'm extracting here. And then in the end, I return this address here as part of the getAddress helper function. Since this is an async function, we will actually return a promise, but that promise will eventually resolve to this address, or in case of any errors, it will be rejected with the appropriate error. So now we can use this getAddress helper function to translate coordinates to an address. The question just is where we want to do that. And there will be different ways and different places of doing that, but I think the location picker is a good place for doing that. Specifically in there, we already have some code that executes whenever the picked location changes. This useFact code. I would argue that this is a great place for then translating this picked location, which is a pair of coordinates, a pair of latitude, longitude coordinates, into a more complex object that still has these coordinates, but also a human readable address. And therefore in here, in this useFact call, we can check if picked location is truthy, so if we do have a location. And if that is the case, I want to eventually call on pick location, but I also want to call getAddress. And getAddress is this helper function we just worked on, which is imported from util location here. So getAddress is imported and then executed here. And then we have to pass the latitude and longitude to getAddress. Well, for this we can of course access pickedLocation.lat and pickedLocation.lng. Now this actually yields a promise and I want to use await. This function, however, shouldn't be turned into an async function because useFact doesn't want a function that returns a promise here. Hence, I'll add a helper function in here. Handle location could be the name. It's an async function, and I will move this code into this function. And since it's an async function, I can use await here to get my address. And in the effect function, so after this inner function definition, we can execute handle location. Of course, we also want to use the address, and here I simply want to forward my picked location as part of a new object to the onPickLocation function, but I also want to merge in that address which we got, so that we actually return both to the place form. We let the place form know about the picked location, so our coordinates, but we also merge in the human readable address. All that is merged into a new object, which is sent to the function that is received on this onPickLocation prop. And that, of course, is this pickLocation handler function defined in place form. So now the picked location we're setting in place form is an object that has the latitude and longitude coordinates as well as the human readable address, which is exactly what we want. If we now save this, we can give this a try. For this, I'm reloading the app, and then again here on Android, if we pick a location, and we also fill in all these other details, and we of course also take an image. Now if we do all of that and we then add this place, we still don't get any feedback here, We'll change that soon. But in our console, we now also get this address field as part of our location. And that is all coming from placeform. So this is all the data available in our placeform component. And we now also got the human readable address here. So with that, we are gathering all the data we need to really store a meaningful, helpful place on the device and to have a meaningful place in the first place to work with. So therefore now, with all of that out of the way, we can focus on outputting these places on the starting page, and we can of course also explore how such places might be stored on the device thereafter. So let's now continue by taking that entered data and not logging it to the console, but instead now I want to pass that back to my all places screen so that there we can manage an array of places which can be output on the screen. Now again, for that we got various ways of handling this. I actually want to handle my navigation back to all places from inside the add place screen. So there I want to use this navigation prop which we get in this component since it's a screen component. And there I want to add a create place handler. And my idea is to pass this to placeform through props so that from inside placeform we can trigger this function. It's of course the same pattern we've used many times before in other places. Now in placeform we can therefore expect a prop, for example the on create place prop, the name is up to you. And this will receive a function as a value, so we can execute it as a function. And I want to execute it here in the save place handler function. And then I want to pass my place data to that function so that in the receiving component and in the function that is called in the end, this data can be used, for example, to later insert it into a database. Now, the data I want to forward here should be an object, and it should actually be an object that follows my structure defined here in this model. Therefore, I want to export this class here in models place.js. And in place form, we can now create a new place like this by simply importing this place class. So we need to import this place class here. And once this is imported, we can use the new keyword to create a new instance based on this class blueprint. And now we can forward all that data this class's constructor function wants. For example, the title, so the entered title, which is that state we're managing here, which manages the title entered by the user. We can also pass in the selected image, which we know is actually the image URI, so exactly what we want here. Now next, my place constructor function wants the address, and here we have to keep in mind that the picked location we got here in place form will actually be an object with the coordinates, latitude and longitude, so lat and lng properties, but also with the human readable address stored in an address property. Therefore, I actually will change my model class definition a little bit, and I will just expect a location object here, which should have an address property which I extract like this. And then for the location property that I want to create in my place object, I will create a new object here with lat, which should be equal to location.lat, and lng, which is equal to location.lng. So I'm pulling out the data which I need in different places in this class constructor. With that, we can just pass in the entire picked location with address and lat and lng all in one object to the place constructor function, and that is exactly what I'll do here by passing picked location into this constructor function. And now this place data is such a place with an ID, because the ID is generated as part of the constructor as well. And that is now the data which I will pass here to onCreatePlace. And onCreatePlace is now a prop that must be set on this place form, and we can do this in addPlace. Here we can now add the onCreatePlace prop and point at the createPlace handler. Here we get our place data, or actually we can just name it place because it's a finished place object in the end, including an ID. And now we can insert it into a on-device database because that will be the final native device feature which we'll use in the future. Right now we don't have that database yet though, and therefore for the moment I'll do something different. For the moment I'll use the navigation prop here, call navigate to go back to all places, and I will forward my place here to all places. This is just a temporary solution, we'll change it later, but for the moment this allows us to pass the place data to all places and display it there. So now here we can add our place property and point at this place argument value, and now that place data will be sent to all places. Which means that now in the next lecture in all places, we can work with that data and then pass a list of places to our places list before we thereafter then also work on storing that data in a database. Okay, we're almost done. The next step now is that in all places, we want to get that place that is generated and created with help of the add place screen, and we are passing that place through route parameters to all places. Therefore here in the all places component file, since all places is a screen component, we can use the route prop. We will get it here, passed in by React Navigation, and we can use this to extract a parameter. But of course, the first time all places is loaded, when the app starts, we won't have any place in our route parameters. Instead, that will only change after we added a place. Therefore, what I'll do here instead is I will again use useEffect, imported from React, and define an effect function that should execute whenever this component receives focus. And that can be achieved combined with another hook provided by React Navigation, the useIsFocused hook, which is imported from React Navigation /native. This gives us a isFocused boolean, and we can now pass this as a dependency here for our effect, so that this effect reruns whenever this changes. And here we can check if isFocused is true, and I also want to check my route params if that is truthy, so if we have some route params, and therefore since I'm using route in here, route should also be added as a dependency. And then in this check, if we do have this screen focused and we have some route params, then I want to manipulate my state here in all places and update my list of places to include the new place. For that, of course, we first of all need to manage some state in here, so we can use state here to register some state and have our loaded places here, let's say. The name, of course, is up to you. And we can use the setLoadedPlaces state updating function in here, in our if check in this effect, to update our places and add this newly received place, which we get through route params, to our list of places. For this should initially be an empty array. And then here I will use the function form of using this state updating function, where I get my current places and I return an updated array, a brand new array of places, where I include all my current places, of course. But at the end of this list, I will actually add my new place, which I get from route params.place. .place here because in add place, I'm setting this place route param here. So therefore, that's the param which we use for extracting that value. With that, we should manage a list of places here, and therefore for places list, we can set the places prop and forward our loaded places here to places list. Remember, places list is a component we worked on at the beginning of this course section. In there, we have a flat list where we output our places. And for every place, we output a place item, which looks like this. Okay, so now with that, if we save this and we give this a try, if I reload everything and back on Android, I again add a place here where I, of course, also take my image, confirm this, and pick a place on the map. If I click Add Place, I'm going back to the starting screen, and even though it's hard to see because it's totally unstyled, we can see some place data here. The title and the human readable address. The image is missing because it has no styling, and we would need to set a width or height for the image to show up, but it generally works, and that of course is a major step forward. This also means that now as a next step we can work on styling this place item before we then thereafter make sure that we don't just store data temporarily in memory by using state like this, but that we instead also store it on the device storage. So let's work on styling this place item here to make sure that the image shows up and this overall looks a bit prettier. For that, I already prepared this styles object down here, this style sheet. And now in there, I want to add an item style object, which will be applied to the overall container of the item. In this case, this pressable component. I will add a pressed style object because we will be able to press this later to navigate to a different screen, and I want to provide some visual feedback when the item is pressed. We will also need some styling for the image, and then also for the container that holds the info text, so this view which holds the title and the address, and then also for the title and the address themselves, so for these two text items. Now let's start with the item overall. As always, it's totally up to you how things should look like, but I will start by setting flex direction to row to make sure that the image and this view are side by side, so that the image is on the left side of the item and the helper text, the title and the address, is to the right of the image. I will add line items flex start to make sure that all the content is moved to the vertical top of this row. And then add some rounded corners with border radius 6 here. We can also add a vertical margin here of 12 so that there is some distance between multiple list items. And give those items a background color of colors using this colors constant, which is imported from constants colors. Colors.primary 500, for example, which is a medium blue color. I also want to add some shadows, so we'll set elevation to 2, and then basically apply the same shadow setup I used before in this course already on my button, and hence I will just copy my shadow properties from there: shadow color, shadow opacity, shadow offset, and shadow radius, and add them here below elevation. Of course, you can also tweak the values, but for me, they will work like this. On pressed, I want to change the opacity, as we did before in this course as well. And here I just want to have a very light transparency effect, which is why I set it to 0.9. And then for the image, I'll add flex 1, so that it takes all the space it can get, relative to other elements in the same container that might also have the flex property. And I will indeed also add it to the info style object, which will be applied to this view, which is in the same container as image. They are both directly impressible, so this view and this image are siblings. And by adding flex here as well and setting flex to 2, I will make sure that this is twice as big as the image. So this takes 1/3 of the available space, this takes 2/3 of the available space. Then on this image, I also will make sure that the rounded corners by the parent container are respected, and therefore I will set the 2 left corners, the border bottom left radius to 4 and the border top left radius to 4. So that on the left side, these 2 corners are rounded, because the image will be on the left side of this overall item. Last but not least, I'll give this image a height of 100 pixels. Now for info, besides setting flex 2 here, I also want to add some padding so that we have some spacing between the edges and the text content that is inside of this box. And then for the text content, for the title, I'll set font weight bold and ramp up the font size to, let's say, 18. And I'll give this a color of colors.gray 700, let's say. And I will copy these two settings, font size and color, to the address, but there set the font size to 12. Now these styles can be added to the JSX code. And here for pressable, again, as so often, style will receive a function where we get this pressed property, which is destructured from this object that's passed into this function automatically. And we always add the item style, but we then check pressed to conditionally add the pressed style as well. Now on the image, we of course add styles.image. On this view, we add styles.info. And then on the first text, it's styles.title. And on the second text, it is, of course, styles.address. If we save all of that, this is what we should get here. This is how it should look like. Now, of course, I also want to have some space around these list items, and therefore we can also style the place list component. And there I will add a new list style where I actually want to set a margin in all directions of 24 to have some spacing around the list. And this will be added as a style to the flat list. So there we can set style equal to styles.list. And with this in place, now there is some space around the list items as well. So we can also tap them, even though at the moment nothing happens. But this is how our list items look like now. And that is again another step forward, because now we can output and display a nice looking list item. The next step, before we make sure that we can also tap them and navigate to the detail screen, the next step before we do that will be to make sure that we store them on the device in some device storage, to be precise, in a database that's running on the device. So by now we are able to create places and output a list of places here. But at the moment, this list of places is only managed in memory in the end. It's managed with help of state in all places, and therefore it is just managed in memory because all that state is managed in memory by React. That means that whenever we would restart the app, all that data would be lost. That's why, of course, we typically want to store data like this. And very often you will store it on some backend by sending a HTTP request to some backend API, where data then gets stored on a database. This is particularly important if you have data that must be accessed by multiple users, because then the backend acts as the one single place to which multiple different devices and users can talk. Here, to show you how you can also tap into native device storage, we will not use a backend though. Not because that would in general be wrong, but because we want to focus on native device features here. And therefore, I want to show you how you can store data like this on the device in a database running on the device. That of course means that only you and your device will have access to that data, but for some apps and some kind of data, that is exactly what you need. And this list of favorite places could be very personal, so just storing it on our local device actually also makes a lot of sense. But how can we now store data on the local device? Again, with help of another third-party package and a specific on-device database. If you search for Expo SQLite, you will find the documentation for the SQLite package here, the Expo SQLite package. SQLite is a SQL-based database that runs on both iOS and Android. So it's a database, a SQL database that can be set up on Android and iOS. And this package helps with setting up such a database and with then interacting with such a database. For this, just as before, we of course have to make sure that we install and set it up properly, and then you can learn how to use this package in this documentation here. Now you also learn how you could import an existing database if you have one, but we don't have that here, so we can skip all that initial part and just install the package like this and then use it like this in our app. So for this, just as before, I'm going to run expo install, in this case installing the expo-SQLite package. And once this is installed, we will be ready to use this package. So let's wait for this to finish. And then in the util folder, I'll create another utility file, the database.js file, where I want to store my database related logic. Now in that file, in the database.js file in the util folder, I will import everything as SQLite from this expo SQLite package. You also find this code here in the official docs. That's how you get access to these SQLite features. And what we can do in here, in this helper file, is we can create a database by calling SQLite.openDatabase. And to openDatabase, we pass a string with the name of the database file, which could be places.db. .db as an extension for this database file. Now, this of course initially doesn't exist, but SQLite will create it for us, or this package will create it for us if it doesn't exist yet. And if it does exist thereafter and the app restarts, it will simply open this existing database. So it will do the right thing depending on whether we already have the database or not. And then we can add a couple of utility functions that interact with that database. For example, I want to add an init function which sets up the initial base database structure. This only needs to execute once, but of course we must make sure that it runs at least once so that we have a properly configured database in place. I will also export this function because we will use this init function from inside other files in our project later. Now in this init function, I want to use this database and send a query, a SQL query to that database that will set up a base structure. To be precise, that will add a table with a certain structure to that database. For this, we can use this database object here. And on that object, there is a transaction method which we can execute. And this will in the end perform a query. It will execute a query against the database. Now, transaction, this method, wants a function as an argument, and this function will get a transaction object, which we in the end need to really create and send the query. So in this function, we can now use this transaction object, which we get as a parameter automatically, because this function will be executed by the SQLite package, and we will get this transaction object automatically then. And on this transaction object, there is an execute SQL method. And then here we pass our SQL instruction, our SQL command as a string to execute SQL. Here I'm using the template literal notation so that we can split this across multiple lines for readability purposes. Now the SQL query I want to execute here is create table if not exists places. This will create a new table named places if it does not exist yet. We need this annotation, if not exists, because we will later call init whenever the app starts, and of course this table will exist for most starts except for the very first time. That is why we must add this check so that we don't get an error if places already does exist. But if it does not exist yet, this table will be created. By the way, if you don't know SQL, that's no problem. You can just type along, and if you want to learn all about SQL, we got a complete SQL course as well that might be interesting to you. But it's absolutely not a requirement here. You can just type the commands I'm typing. So here we then add a pair of brackets, and between those brackets we now add the configuration for this places table. We add the different columns we want to have in that table, so to say. For example, I want to have an ID column, which should be of type integer, which should be a primary key, and which should be not null. Adding a primary key integer column will create an automatically incrementing ID for us, which means that whenever we later insert data into this table, the ID field will be populated automatically by SQLite. Then we add a comma and we add the next column definition, which could be the title here. This should be of type text, and it should be not null, because of course we want to have a title for every place that we store. Now in addition, every place has an image, and we're not going to store the image in the database. Instead, the image stays on the file system where it was stored by the image picker, but I want to store the path that points to that image in the database. And that's a general best practice. You don't store files in databases, but paths to files. So here we can add the image URI field, which is of type text, since it is the path to an image, and also not null. And then I will also add address, which is of type text and not null, and the latitude, which is a real number, which is basically a number with decimal places, and not null, and LNG, which is also real, not null. So this will now create a table if it doesn't exist yet, and create those columns in the table. Now, execute SQL actually does not just want this SQL statement, but we can pass more arguments into this function. For example, after defining this statement, we can pass an array of values that might be used in this statement. In this case, we're not using any special values, hence this is an empty array. Later, we will change this in other queries, which we're going to write later. Then thereafter, we can also add a callback that will be executed if everything succeeded. And we can add another callback that will execute if we have an error. This callback receives two arguments. It receives the transaction that failed. I don't need that here, so I will add a blank. But I'm interested in the second argument, which is the error that was generated. The blank signals that I have to take this argument for technical reasons, but I'm not using it. Now, inside of these callback functions, I am not doing anything right now, but that's about to change. My plan is to promisify this library and its functionalities, because by default, SQLite, this package, works with callback functions. I would like to return a promise here in init, which resolves when this transaction is done and rejects if we have an error. To achieve this, we can create a new promise here, like this, and pass a function to this promise constructor function, as we always do when creating promises. This is not React Native specific, but a standard JavaScript feature. And then here we get a resolve and a reject function as parameters in this function which we pass to the promise constructor. Those parameters will be passed into this function by JavaScript in the end, because the promise object and class is built into JavaScript. And then here, inside of this function, I want to execute this code, so that will be moved in here. And if we now have a success scenario, so we succeeded running this command, I will resolve. If we have an error, I will reject and forward the error. By the way, if the table already exists, that will not be an error, that will also qualify as a success. An error really only occurs if something fails here, if we have a syntax error in the command or anything like this. Now this is promisified, and now we can return this promise here as part of the init function at the end of the init function. So that when we call init from somewhere else in our code, init returns a promise that will execute this command and will then resolve, so succeed if the command succeeded, or reject with an error if we had an error. And that's now our first step towards using this SQLite package. We're opening a database and we have some code for initializing it. Now that code needs to be executed. And a good place to execute this code is app.js. This is the first component that is executed when the app starts, and therefore it's a great place for initializing our database. So inside of the app component, I want to initialize my database, and this can be done with useEffect, which is imported from React, of course. So I'm importing the useEffect hook, and my goal then is to call this init function, which we defined in the database.js file, whenever the app component renders for the first time. Therefore, in here we can call init, which is imported from util database. And I want to execute this whenever the component is executed for the first time. And since I have an empty dependencies array, that is exactly what will happen. When the app component was evaluated for the first time, this effect function will execute, and we will therefore then init our database. Now I actually want to show the app startup screen whilst we are still initializing. And we can do this with help of the app loading component, which we also saw earlier in the course already. For this, we can expo install another package, the expo-app-loading package, which gives us access to the app loading component that allows us to prolong the startup screen in the end. So that's another package I will install here. And once it is installed, we can use that to show it until we're done initializing. To find out if we're done, we can manage some state here in the app component with the use state hook. Here I want to have some state, and the state I want to have here is the db initialized state and the set db initialized state updating function. And then here init returns a promise, so we can add then or wrap this into async await a function as we did it before in other parts of the app as well. But here I'll use this good old then method here. And in this anonymous function, which is passed to then, we add the code that should be executed if init succeeded. So here I will call set db initialized and set it to true. And initially it's false. And with that in place, we make sure that we then can use this db initialized state to show app loading whilst it's not initialized. Initially it's false, and we set it to true once we're done initializing. So here we can check if not db initialized. And if it's not initialized yet, I will return app loading. And for this, app loading is imported like this from expo app loading. So this app loading component is returned if the database is not initialized yet, and this will ensure that we still see the startup screen whilst the app is initializing. Now, of course, init could also fail, and therefore we can also add catch here and handle the error case, but for the moment I'll just log it here. You could of course add better error handling and show a different screen if things go wrong. At the moment we would be stuck in the app loading screen, which is not ideal, but for this demo I want to focus on the success case so that we can move a bit quicker. Now with all of that done, if we now save this and reload our apps, these apps should still start up, but now they will have that database initialized. We don't see it yet, but it should be there. And we will be able to prove that it's there in the next lectures when we will finally insert some data into the databases and then also get some data from the databases. So in the last lecture, we worked on initializing our database here in app.js. And now with the database initialized, we can of course also work on inserting data. And for this, as a first step here in database.js, I want to add another utility function that helps us with inserting data. It will be another function that of course will be exported, and we could name this function insert place because this function will be about inserting a place. Now, as a parameter, this function expects to get a place object, which should have the shape defined in our model, in our place model. So it should have these properties. The ID won't be too important though, because we'll not use that ID. We'll use an ID generated by the database instead, but the other properties should be there. And with that in database.js, we can then write the code for inserting such a place. Now, I again want to promisify this, so I want to wrap my code with a promise so that in the place where we use insert place, we can simply react to that promise, resolving or rejecting. And therefore, I'll add this function here to the promise constructor, which gets the resolve and reject functions as parameters.
And then in the end, we will return this promise. And in this promise function, or the function wrapped by the promise to be precise, we now want to insert this place into the database. Now, of course, the place should be inserted into this database, which we opened here and initialized here. Therefore, I will use that same database object. And again, we can call transaction to start a transaction, where the transaction then will execute the query that should be executed. And just as before, when we initialized the database, we pass a function to transaction, this function, and this function will receive that transaction. And in this inner function, we can then execute a SQL command against our database. Now here, the command which I do want to execute is insert into places, to insert some data into our places table. And the table name used here should be the table name used here for initializing the database. So here I want to insert some data into this places table, and that's the standard SQL command for inserting data into a table. And then we can target the different columns into which we want to insert data. And in my case, that will be the title, the image URI, the address, and the lat and lng columns. So basically all the columns we set up here, except for the ID column, because that will be set automatically thanks to the setup we implemented here in the init function. All the other fields should be set by us, but the ID will be assigned automatically by SQLite. So therefore we should insert the data for these other fields, and we should make sure that we insert the right kind of data. So for title, image URI, and address, we want to insert some text. And for lat and lng, we want to insert numbers with decimal places. Now here in our SQL command, to insert values into these columns, we add the values clause here. And then thereafter, between brackets, we can insert the different values that should be used for these columns. Now we could dynamically inject values into this template literal, but here with this third-party package which we're using, the better and recommended way of inserting dynamic data into this query is to add some placeholders here, to be precise question marks, one for each value that should be inserted. So 5 question marks in total, since we're inserting data into 5 columns. And with that, we can then pass a second argument here to this execute SQL method. And that is then an array with the concrete values that will be used instead of these question marks. And the order of the items in the array should match the order of question marks and columns. So with that, now here between the square brackets, we can set the different values for the different question marks and therefore for the different columns. So for example, the first value we should insert in this array is the value that should be inserted for the title, since that is the first column defined here. And in my case, that would be place.title. Keep in mind that the place we're getting here, this place parameter, will be an object of this shape. So it will have a title property, an image URI property, an address property, and a location property, where the location property contains lat and lng. Hence, here we can insert place.title. For the image URI, we can insert place.imageURI. For the address, it will be place.address. And for lat, it will be place.location.lat. And for lng, it will be place.location.lng. So with that, we're setting the values that will be used for this insert into statement. And then we can pass 2 more arguments to this execute SQL function. And the first one is a function that will be executed in the success case. The second one is our error function. Now, in the success case, we will get 2 parameters passed into this function automatically by this Expo SQLite package. And the first parameter will be the transaction we executed. I'm not interested in that here, so I will use this underscore, this blank name here to signal that I have to take this parameter, but I'm not using it here. But the second parameter will be the result of this query. And for the moment, I want to console log that result so that we see what we get as a result if this succeeds. In the error case, I also get the transaction and then an error object. And here I then want to reject my promise with that error. In the success case, I also want to resolve it and pass on my result here for the moment. But we're also logging it so that we can see what's inside of it. And with that, we got this insert place function implemented, and we should be able to call this function, pass a place to it, and then this place should be inserted into the database. And that is therefore what we will do as a next step. So let's now use this insert place function we worked on in the last lecture. And the question, of course, is where we should execute this function. Where should it be called? Well, we're adding a place here in addPlace.js, and at the moment, we're then forwarding the place to all places when we navigate back to that screen. I would argue that this is a great place to insert the place into the database, and in the future, remove this code. I'll keep it here for the moment, but we'll remove it in the future, because in the future, we then want to fetch the places from the database on the All Places screen. But for the moment here in add place, I'll still forward my place here, but I also want to insert it into the database. Now to do this, we need to call insert place, and we need to import insert place from our util folder and the database file. Now insert place returns a promise, and I only want to navigate away once we're done inserting a place. Hence I will turn this into an async function so that we can await this, and this line of code will only execute after this is done. Now of course we also need to pass our place to insert place, but with that we should have all the code we need to insert our place. Now with that in place, no pun intended, if we save all of that, reload and go back, if we try this on Android, since there we can take pictures and pick locations, on this emulator at least, and I restarted this emulator between sessions, that's why I have to confirm all these or grant all these permissions again. But now if we enter a title, take an image, and pick a location, if we now add this, it still shows up here, but that has nothing to do with the database. But if we take a look at our terminal, we can see a log there. And that's this result which we're logging in database.js. This is coming from this line of code here. And we basically see that indeed a new item was inserted. And what we can also see here is that this result also gives us the ID of the item that was inserted. I did mention that the ID would be set automatically, and it's good to know that we get the ID as part of this result, because that means that we could of course use that ID in that place where we are inserting data. If we then would want to send this to some backend or anything like this, we can get the ID from that result. We don't need it here, but we could get it if we wanted. More importantly though, this item is now really stored on the device in the database. That means that if I reload my app, the item is gone here on the All Places screen, because that was only stored in state and in memory therefore, but it should still be in the database on the device, because I did not uninstall the app, in which case the database would be cleared as well. The app was installed, it just restarted, so the data should still be there. And therefore in the next lecture, we will now work on fetching that data. So let's now make sure data can also be fetched. And for this, I'm back here in database.js, and I will add a new utility function in there, the function fetch places, which will do what the name suggests, and which is exported so that we can call it from inside other places, for example, from inside component files. Fetch places should give us a promise which ultimately resolves to a list of all our places. And for this, I'll create my promise here as I did it before in these other functions as well. And then the promise will be returned by this function. And to this promise, we pass this inner function which gets the resolve and reject functions. And in this inner function, we now write our database code. We will again work on the same database as before and start a new transaction. And hence, as before, we get this function where we get the transaction, where we can then execute a SQL command. That's exactly the same approach as before in all those other helper functions. Now, the SQL command I want to execute here is a super simple one. I just want to select everything from the places table like this. That's all. That is the entire function. Of course, you could add where clauses and filter the data. You could also add order by and order the data. All these standard clauses, which you know from SQL, for example, from our SQL course, if you want to learn that, all these standard clauses work, but here I just want to get all the places without any filters, without any special order, and therefore this query will do the trick. Now, besides this query, we still pass a second argument to execute SQL as well, which is this array of data that should be injected into this command. But here we don't have any placeholders, so no data should be injected, hence it's an empty array. And then we have the success and the error functions here. And in the success case, I ignore the transaction, but I'm interested in the result because that should give us all our places. In the error case, I will accept the error here. And in the error case, I want to reject my error. In the success case, I want to resolve my result. And I want to look into my result so that we understand what we're getting back, so that we know how we can work with that result later on. And that's the fetch places helper function. Now we can call it. And again, the question, of course, is where this function should be called. And I would argue that the best place is the allplaces.js file. Here, we want to show all places. We want to render a list of places. So here's the place, again, no pun intended, where I want to fetch my places. And I would argue that a good place to do that is here in this useEffect clause. When we know that this component is focused, so that this screen is focused, whenever we know that this is true, then we want to fetch our places, because then this screen is active, and then we want to get the latest data. Therefore, here I then want to call fetch places. And actually, I will wrap this into a function here, an async function inside of the effect function, which I'll name load places, simply so that I can use the await keyword. Because fetch places will return a promise, and I want to await that and then do something with my result. For the moment, however, I'm not interested in the result because I first want to see it in the console so that we see how this query result will be structured. But later, we will work with it here. Right now already though, I will comment out this line of code and instead call load places, this helper function which I added here, if this page is focused. I'm also not interested in the route params anymore, hence we can remove that here and remove this dependency. And then also go to add place and remove this code where we set the route params, because we will move away from this approach and instead in the future fetch our data from the database. With that, if we reload everything, the apps reload, and now we should have fetched our places. Therefore, in the terminal, we should have some output, and we do. And we can see that indeed I got a web SQL result set here, and that is that result set from fetching our places. And actually, we got two result sets because it was fetched on both the Android and the iOS simulator. Now, the second output here is coming from iOS. There, it's pretty empty. But for the first output here, that's coming from Android. And here, indeed, we see that our result set is an object with a rows key, which is another object with an underscore array key, which is an array with all the place objects that were fetched from the database. And here, indeed, we see that we're getting back an object with the human readable address, the ID that was assigned automatically by the database, the image URI, the coordinates, and also our title. So all the data we stored. And that, of course, means that we can use this data by drilling into rows underscore array. And I want to do that drilling right here in the utility file, where when I resolve, I will dive into rows._array, and we now know that this will then be an array of places. we could even convert this to an array of place objects that use our model if we wanted to. And indeed, that is what I will do here. So we'll add the conversion code here, where I have my places, which is an empty array. And then I want to go through all the data points of this array here. So I will cut this and insert this here. And every data point basically is a place, just with a slightly different structure than we wanted. So then for every data point, I push a new entry into my places array. And we create a new entry by using the place model we defined with the new keyword to instantiate our place class. And for this, of course, place should be imported from the models folder. And then we can instantiate this by simply passing the data that is expected to our place model. So for example here, I want to pass in a title, and the title is fetched from my data point .title. We know that every data point will have a title property because that is what we can see here. There is a title property. So we can set this. For image URI, we can access image URI. And for a location, I'll pass in an object where I set my address to dp.address, lat to dp.lat, and lng to dp.lng. I now also want to make sure that I set the ID to the ID we got from the database, because that's the ID I want to use for all my actions with a place, so that if we would update the place in the database, we would have the right ID to do that. For this in the place model, we can add another argument here. Let's say the ID argument as the last argument here in the constructor. And this will be undefined if it's not set. But here, when assigning the ID, we can simply set this equal to ID. And this might sometimes be undefined, which doesn't matter. It will definitely be set here in this case when we are fetching places from the database, because here, as a last argument to this place constructor, I will indeed pass in this ID. So here I will pass in dp.id, which is that ID that was assigned by the database, which is now set on this place object that is created with this class constructor. And then we have this array of places that have our own format, and I will resolve this array of places thereafter. With that, we'll have an array of places that is full of objects that have our own standardized format. And therefore, we can then resolve this array of places here. And now we can use the places here in all places and get our places here by calling fetch places. And then thereafter, we can set our loaded places equal to those places, because we know that this will be an array of correctly formatted place objects. And with those changes in place, if we now reload everything, we should again see our place here, but now it's the actual place coming from our database. And now the next step is to make sure that we can tap this place, go to a detail screen, which we have yet to build and fill with live. And then on that detail screen, I want to fetch the detail data for that place. So let's now come closer to the end of this section by working on the place details screen component. In there, I'll start by adding my place details component function, which of course is exported as the default. And the idea here simply is to output the details about a place. Now for that, I will return some JSX code here, and I'll start with a scroll view so that in case we should exceed the available screen estate, we can scroll. And then in there, I want to have an image, my place image that should be output. So of course, that's also imported from React Native. And below that, another view, which is imported from React Native, where I want to have another view inside of it, where I then want to have a text that outputs the human readable address. So here we'll insert the address later. And below that, I want to have my outlined button, my custom button that we built before, which says view on map. And that should allow us to view this place on the map. The icon for this button will be the map icon, and on press, I want to open the map, and for this, I'll add a show on map handler. So that's the function I will point at. That's the general structure. Of course, we also need some styles, and therefore, again, I'll add a styles object here with the style sheet. Create this as we always did. Of course, make sure to import style sheet from React Native. And then I'll set a style for the overall screen, so for the scroll view, where we can set align items to center to make sure that everything is centered nicely, horizontally. And then add the image style, where I want to give the image a height of, let's say, 35% of the available height, and a min height of 300 pixels, so that it is at least that high, and set the width to 100% of the available screen width, so that it takes the full screen width. Then, as a next step, I will add my location container, which will be added to that view that holds the address and this button to open the map. And on this location container, I'll just set justify content to center and align items to center all the child items in that view horizontally and vertically. Then I'll add an address container, which will go on that view that holds the address, where I will add a padding of 20 for some spacing, and then an address style object, which will go on the address text, where I want to set the color to colors.primary 500. And for this, of course, you must make sure that colors is imported. And then I also want to set text align to center the text nicely, set the font weight to bold, and also the font size to 16 to make this text a little bit bigger. And now these styles can be assigned here. On the scroll view, I actually don't even need to add that. So actually we can remove the screen. We don't even need that. But on the image, I want to set a style of styles.image. On this view here, I will add a style of styles.location container. And then on this view that holds the address, we can set style equal to styles.address container. And on the address text, we set style equal to styles.address. So now we have the styles in place. Of course, the data is missing though. Now to fetch the data, we need to kind of reach out to our database to get the data from there when this screen loads. And for this, of course, in that screen, we need to know for which place to load the data. So therefore, I actually will assume that we get this place ID via route parameters. So we can use the route object here to then use useEffect and fetch the data for a specific place when that screen loads. So here, outside of useEffect, I will get my selected place ID by accessing route.params.placeID. Assuming that there will be a place ID route parameter set, we will have to do that in the place where we navigate to that screen in the future. And in useEffect, we can add selected place ID as a dependency, because inside of the effect function, I want to use selected place ID to fetch data for a single place. And we'll add the code for that in a second. So for the moment, this won't really work, but we will make sure that it works soon. For the moment, we can go to all places where we have our list of places, and here I want to make sure that we can navigate to a single place. For this, we actually should go to the places list and then to the place item where we have this pressable item. Now, upon a press, we trigger the onSelect function, which is coming from places list. And therefore here, we now want to make sure that when we render such a place item, we also add onSelect, and then we navigate to that place that was selected. So here in places list, we want to be able to navigate, and for that we can use the use navigation hook, which can be imported from @react_navigation/native. This hook gives us access to the navigation object, and we can then use this hook and this navigation object here to navigate away whenever a place is selected. So for this, we can add a function, select place handler could be the name, where we want to call navigation.navigate and go to the place details screen, which we have yet to register. But when we go there, I also want to set up some route params, because in the place details screen, we expect to extract the place ID. So we should pass that place ID route param into this place when we navigate there. So here in places list, I therefore want to set my place ID. And now I assume that I get the ID here as an argument, as a parameter in select place handler, and we can then use that value as a value for the place ID route parameter. Now, to make sure that we do get the ID here, we can set select place handler as a value for the onSelect prop, and therefore this is called from inside place item, because there I am binding this to onPress, and we can therefore then make sure that the ID will be passed as an argument to onSelect when it's executed. And to make sure that this occurs, we can use the bind method on onSelect to pre-configure it for future execution, so to say. And as mentioned before in the course, as a first value, you can then set the value of the this keyword in the to be executed function, but we don't care about this here, so we can just set this to this. But then the second value is the first argument, the first parameter received by this to be executed function. And that should be the place ID here, hence I will set this to place ID. And that should make sure that the place ID reaches this function and therefore also is passed on as a route parameter to place details. Now at the moment we don't have any code for fetching a single place yet, but we'll add that code soon. What I want to do right now already though, before we do that fetching, is register that screen. In app.js, we want to register a new screen here with stack.screen, and the name of that screen should be place details. At least that is the name I also used in places list for navigating, so that should be the same name here. And then here we can set the component that should be loaded to place details, which is this screen component, which of course also must be imported. So with that, that screen is configured, and we should be able to go there by tapping on a place. If I do this here on Android, indeed we go to this screen, but of course at the moment we don't see anything there. But we'll change this soon. To be precise, we'll change it in the next lecture. So let's now make sure that on place details, we can actually fetch the details for a specific place. And to achieve this, I will again go to database.js and add a new function, the last function we will add here, which is exported, which I'll name fetch place details. Now I do expect to get the ID of the place that should be fetched here as a parameter value. And then in there, again, I will create a promise like this and return this promise. And inside of this promise function, I then want to write the code for getting the details for a specific place. So in there, we can now again use our database object and create a transaction as we did it before in the other utility functions as well. And then on that transaction, we can execute a SQL command. Now the SQL command, the SQL statement that I do want to execute here is again select all columns from places, but now I want to add a where clause to filter my places. Because I don't want to get all the places, I want to get one specific place. And we want to filter by place ID and look for a place where the ID is equal to this ID we're getting here. Again, we can use a question mark placeholder here, and then as a second argument to execute SQL, pass an array where now we do set all the values for all the question marks. In this case, we only have one question mark, so now this ID is the value used here for this question mark. So with that, we're fetching a place where its ID is equal to the ID we're getting here. And then just as before, we have these functions for success and failure, and we get back our transaction and the result or the transaction and an error. And in the error case, we can reject our promise with that error. In the success case, we want to resolve, and we want to pass on that fetched place. And to see what we can pass on, I will again console log the result here so that we can understand which kind of data we're getting back from the database. With that, we got the fetch place details function finished. We now just need to execute it. And the place to execute it, of course, is place details. Here in place details, we got this useEffect hook, which will execute a side effect whenever the selected place ID changes. And that is indeed the place where the place details should be fetched. Hence, I'll add an async helper function in here. Load place data could be the name, where I want to call fetch place details. And that, of course, is imported from the utility folder from the database file. Now we can await this and then pass our selected place ID to fetch place details, because that helper function on which we just worked wants that ID. So we should pass it in, and then we can execute this helper function here in useEffect, this load place data helper function. And with that, we should load the place data when we visit the detail page for a place. If we save that and reload everything, if I have a look at this place, we don't see anything here yet because we're not really displaying the data yet or using the data yet, but in the console we should see some output. And indeed here we got our result from the database, and again we see it's an object with a rows object with an array underscore array array, and in this case this array has only one object because we filtered for ID equality, but of course the SQLite package doesn't know that, which is why it still gives us an array, because when using a where clause, if we would not be using the ID, then we could still have multiple places. That's why we still get an array. But here we know that we will have an array with exactly one item, so I actually want to resolve that one item here, and I want to resolve result.rows._array and access the first item in that array. That will be that place which we fetched. And now we know that fetch place details will return a promise which eventually resolves to that place that we are looking for. So in place details, we can now get that place here and store it in a constant, for example, and we can now add some state to place details to update that place once we fetched it, so that we can then also output it down there. So for this, we can add use state here, and then have our fetched place and a set fetched place state updating function here. And initially there is no place, but eventually we'll set our fetched place to that place that we did fetch. I also, by the way, want to update my header title to the title of that place then. And therefore, inside of useEffect here, I will then also use the navigation prop, which we're getting from React Navigation, since this is a screen component, to set some options. Now I'm doing this here in useEffect and not in useLayoutEffect, because I can't set it whilst we are transitioning to this screen anyways, because we won't have fetched the place at this point of time yet. So therefore, we will initially see a different title and then switch to that place title once we fetched the place data. But that is fine for this scenario. So the title here can then be set to place.title. To have a nice title whilst we are transitioning to this place, though, I will go back to app.js and add some options here to place details to set the title to loading place here, which is the title we will see whilst we are transitioning to place details. And then once the place was loaded, the title will be updated from inside the screen component and will be set to the actual place title. So with that, we're fetching the place. Now we can also use it down here. And for example, on the image, we want to add the source and set the URI of the image equal to fetched place.image URI. And the address should be fetched place.location.address. Of course, initially there won't be a place, so trying to access this data would fail. Therefore, I also want to add a if check where I check if not fetched place. So if this is falsy, if we don't have a place yet, in which case I want to return a view with a text where I say loading place data. Actually, like this. And I also want to make sure that this is nicely centered. So for that, I will add a fallback style object here where I set flex to 1 and then justify content to center and align items to center so that we center this text in the middle of the screen, both horizontally and vertically. So we can add this fallback style here to this view like this. And with that, if we again reload this app, if we go to this place, I get an error that trying to access the address here fails. Yeah, of course, because in my place model, the address is not part of the location object, but a standalone property. So in place details, this should be just fetch place.address. So this needs to be updated to look like this. And now with that, if we go there, we don't even see the loading because it's that quick, but we can now see our data here. So now I want to make sure that we can view this place on the map by tapping this button. Now the convenient thing is that we already got a map screen, which we can use to show a full screen map. We will just have to tweak this screen a little bit to also work with a pre-configured place. Because at the moment it always opens the map in the same region and it doesn't focus a specific place out of the box when it opens. So we'll have to change this, but as a first step here in place details in our show on map handler, we can of course open that map screen by using our navigation prop and then the navigate method, and then by opening the map screen like this. That is all we need to do initially. With this, if we click this button, the map opens. But again, it doesn't focus any specific place. In addition, it also shows the save icon. And of course, when viewing a place that we already created, since I don't want to allow users to change that place here, we shouldn't be able to save it. I just should be able to view it, but there shouldn't be any save button here. Therefore, we now want to make this map screen a bit more configurable. We want to make sure that we can set an initial place and that we can also hide the save button if we do have a place in view mode, so if we're just viewing a place. Well, this can be implemented in a relatively easy way. Here in the map screen, we can accept the route prop, which is provided by React Navigation. And then we could set up some initial location, which could be an object, where we set the latitude equal to route.params.initialLat, let's say, and the longitude to route.params.initialLNG. Now for this, of course, we assume that we got some route params, which will not always be the case. It will only be the case if we're opening this map from the place details screen. Therefore, I will check if route params is truthy and only set this object to these values, which we then know will be there if we do have route params. Otherwise, initial location will be null. And therefore, we can also use an alternative approach and use the AND operator to only set the initial location to this object if route params is truthy. Otherwise, it will be set to undefined, because otherwise route params will be undefined. And then we can use this initial location for our region here. We have these standard starting coordinates, but I want to override them if we already have a location. So we can check if initial location is truthy, so if it's not undefined, which it only will be if we have route params. And if it is truthy, we can set initial location.lat as a value here, and otherwise use our default latitude if we don't have an initial location. And we do the same here for the longitude, just with .lng. So with that, we can set an initial location. I, of course, also want to show a marker if we have an initial location, because then the marker should be at that initial location. Now this marker will be set whenever we have a selected location. And selected location is our state here. By default, selected location is undefined, but we can change this now. We can get our initial location before we initialize the state, and we can then use our initial location as the initial state here. So my initial location can be used as the initial state, and that is either undefined, which is the same as we had before, or it is an object of this shape, which then is an object that can be used down there to show a marker, for example. So when we add a place, that should still work as before, but we should now also be able to view this map with an initial location selected if we have an initial location. I also want to hide this save button if I have an initial location, and therefore here in use layout effect, where I'm adding this save button, I simply want to check if we have an initial location, if this is truthy, in which case I will return and do nothing. So this code will not be executed then if I return here. So this acts as a guard where this code won't be executed if we have an initial location, because then we know that we're in view mode, in read-only mode, so to say, and we won't be able to change the location anyways, hence this header button shouldn't be shown. Therefore, of course, initial location should technically also be added as a dependency here. Okay. So now with all of that, we updated the map screen. This should work. Now we have to make sure that we set this initial location so that we set these route parameters, the initial lat and initial LNG route parameters when we go to this map in read-only mode. So in place details, which is the place where I want to open the map in that mode, we can pass our route parameters to navigate and set the initial lat and the initial LNG values here. And initial lat, of course, should be our fetched place dot location dot lat, and the longitude should be fetched place dot location dot LNG. And with that, if we reload again, we should still be able to open this map here when we add a place, and we can still pick a place and save this, so that works as before. But if I open it from the place details screen, then I get an error. Fetched place location lat is not found here. And this error makes sense because we have one problem in our code. When we're fetching the place details, I am returning the place as we're getting it back from the database. Now we must keep in mind that this place, as it's coming back from the database, doesn't have the shape of our place model. So in order to make sure that we do have that shape, I also want to transform this place here before I resolve from inside this fetch place details function. I will create a new place here and pass in my title, which is the .title prop on that data we're getting back from the database. So here I have my db place, let's say, and then here we can access dbplace.title. The image URI is dbplace.image_URI, but the location now is an object where the latitude is set to dbplace.lat, LNG is set to dbplace.lng, and address is set to dbplace.address. And then the ID is set to dbplace.id. So with that, I'm transforming the place as we're getting it back from the database, which has a different structure than we needed in this app, into an object that has the shape defined by our place blueprint. And then it's this place which I want to resolve. With that, it will have the expected shape, and with that, of course, we will be able to work with it as expected. So then, with that change made, we should be able to dive into the nested location object and then the lat and LNG properties. So if we save that and reload, now the place is pre-selected and there also is no save button.
As a last change in map.js, I also want to make sure that I can't pick a different place and I can't move that marker. So in select location handler, I also want to add a check and check if we do have an initial location, which means we are in read-only mode in the end, because then I want to return here and not set my location to a new place. Because it would be weird if we could move the marker if we can't save that change anyways. So we also want to have that guard here. And then if we reload and we view that place and view it on a map, we also can't move that marker. So with that, we're now fetching the place details and we can view this place on a map. Now that's it for this application. We added a lot of features to this application. Besides building another React Native app with navigation and so on, we made sure that we can now use some native device features, like locating the user, or showing a map and picking locations on that map. We also made sure that we can use the device camera here on the emulator, but of course also on a real device if we would run the app there. We learned a lot about these features, and you learned in general how you can use such native device functionalities with help of third-party packages. And when using Expo, there are lots of packages provided by Expo that make working with those native device features super simple and that are installed without any hassle and without any tricky setup. We used packages like Expo Image Picker, Expo Location, or React Native Maps, which is also kind of provided by Expo as well. And those packages made it very easy for us to tap into those native device features. We also learned how we can use a SQLite database on the device to store data on the device with SQL commands as shown towards the end of this section. Of course, the app which we built here is a demo app. You could improve it in many ways. We don't have proper error handling, we're not showing loading screens in all the places where we might be loading, and in general, there are various things that could be improved. But this app was all about diving into those native device features, and you therefore now hopefully have a good understanding of how you can tap into such features, and that in general, you might want to explore the various packages and features provided by Expo, because there's a great chance that there is a package that helps you with your specific use case. No matter if you need to work with maps or with date pickers or with payments or anything like this, Expo most likely has got you covered, and therefore now you're not just able to build nice looking feature-rich apps, but you're also able to tap into native device features.